Today is Monday, coffee day, which means we're going to go for about 14 to 16 hours. It's Monday, 14 to 16 hours, drinking coffee. PHEXDUM stands for PNG hex dump. We're going to take a PNG file and convert it to a hex dump, and then a hex dump back to a PNG file. And when we say hex dump, we mean a list of bytes, but they're not just going to be bytes, they're actually going to be a comma separated list of hexadecimal bytes, and those bytes are actually going to be packed into uint32s. So each number is going to encode 4 bytes. Now, why are we doing this? Well, we're doing this because we want to hard code some bitmap-like data into the engine so that we can use it. However, in order to do that, we need to come up with our own tool chain for doing that. And we're going to use this utility. We're about to create it, and it's going to be used to encode bitmap data by taking a PNG file. It's going to take the raw binary of a PNG file, turn it into a hex dump, and then we're going to encode those bytes into an array literal within the C code. When we want to unpack it, we take that array literal in the C code, and we feed it into load PNG and say, hey, load PNG, this is a PNG file, please decompress it. We decompress it, and we get the uncompressed bitmap back out. With that, let's try to get started here. So we already created the basic project structure. We got a data file and a function file called phexdum.d and phexdum.f. And one's going to be for holding data, one's going to be for holding functions, right? And we already decided what all of our variable names would be, so we kind of figured out like all these variable names here. So we have a PNG file, C99 text, naked text, C99 pixel array, PNG pixel array, and PNG text. So PNG text, note that it says there is no such thing. We want to support these commands. PNG file to C99 text, C99 text to PNG file to naked text to PNG file, and internally, we want something that can take a C99 pixel array and convert it to a PNG pixel array. So this is a lot of work. Now, if we look at PNG pixel array, it says deflated PNG file into a U08 array. So this is managed by load PNG, or actually not load PNG, because this is a uint32 array. Basically, this command here is just a U32 array to U08 array, right? That's all this really is we're unpacking it. Now we have to be careful of endianness. Like, endianness will probably screw us up if we're not careful, so we got to be careful of that. So we'll have to have some endianness checks for the operating system, and I don't know how we're going to do that, but we'll figure it out. We'll figure out how to do that as we go. Let's kind of organize some things here. Okay, that's good. And now let's open up the function file. Oh, also, let's erase our push-ups. So push-ups, all this gets nuked, right? Everything has been set back to 0. So set it back to 0. Everything gets set back to 0 because today is Monday. So all the progress we made, and today we're going to try to get 120 push-ups a day. So instead of 110 like last time, we're going to try for 120, right? We're going to add 10 more. And we're just going to keep on doing that until we start losing weight. So 720, we got 720 push-ups last week. Push-ups, crunches, etc. Go. So the first thing we want to do is just create like a main file. And we're going to do that in C11, right? In C11, we're going to do our main file stuff because we want it to be able to just rip out this data file and this function file and just be good, right? And what the hell? And just be good to go. So, and this is the left side one. So let's move these windows to their appropriate positions. Yeah, so we just want to be able to take the argument parsing and do that here. So int main void with args. So I don't really have a shortcut for this. Main with args. That is actually what I want. Main with args, int main. But we're going to do, instead of arg count and whatever the heck, I'm going to that's good, that's what I want. But the arg count, okay, we're going to do something like, we're going to try something like, this. Like so arg count, arg array, just to keep kind of our formatting. And the first thing we want to do is just support these things here, right? So, now, we may have, I think that this is basically what we want to do, and then we want an extra option to tack on to the end of this sometimes, whether or not we want to support a, making the bitmap black and white, like doing some processing to the bitmap to make sure that the pixels are only pure black or white. But for now, let's just support these commands, right? Let's not worry about all the details, all the extra parameters. Let's just get the basic thing working, right? So, we're just going to say that, you know, if arg cow, we're going to -1, so if we have two user-supplied arguments, right? That's what this means. If we have two user-supplied arguments, then else printf we're just going to make a note, hey, you need to give us exactly two user arguments, okay? And if we get exactly two user arguments, then we're expecting that the CMD equals the argument array 1. So this is the command, and the output file, or I'm going to call it file. It could be an input file, it could be an output file, depending on the command, right? Right? So the command, this is the command, and this is the argument, this is in or out file, right? So it could be an input file, it could be an output file. We don't know. It depends on what kind of command it is. Okay, so now that we have that, the next thing we want to do is what? What do we want to do next? I don't know. I feel like maybe I should have got more sleep. I don't know. I just feel kind of... I don't know. I don't feel all here right now. I feel like I could have got more sleep. But, oh well, we're gonna just try to do this. I'm gonna get a glass of milk really quick. To the bottom screen here. And, right, so if the number of user args is not 2, then we're going to say, hey, blah, 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 right? Otherwise, the command, so const, let's do chr pointer, cmd, equals a character pointer, a null character pointer, and then the file, the input-output file, char pointer file equals, same thing, file is also a character string, so character pointer 0, null as well. And let's create a main section and put the correct macros for all of this. And I think I'm actually going to go upstairs as well and get my wrist guards, because the edge of this desk is very sharp. You probably don't know what my workstation looks like, but the desk is actually very small, and so I can't rest my arms on the desk without like hitting this very sharp ridge, and it gets my wrists, and it's bad. Okay, so let's define CHR. Can we define CHR? How about define U32? How about define, what else do we need? I guess that's actually all we need right now. Or actually, no. We need to define int32. Define I32. And then wherever we see int, I'm just going to call it int32. Okay. And the next thing is, I guess, we should just be able to give this a run now, right? Like, so, this thing here, we could just say, let's make a switch here, right? So, if strcmp cmd, if the command is equal to png to C99, right? And we can just do this for everything, right? So we can just say, and we're just going to keep it dead simple, right? Because we could just do this in a big loop. And if that's the case, we're going to do AAC 2020 PHEXDUM, and we're going to say PNG file convert to C99 text. And when we do that, we're going to give it a file. So I just realized that PNG file to C99 text, but we're going to do it with an overload where we use a text file, like a file pointer, rather than the actual PNG file, right? So we can have the PNG file in terms of the binary. So let's call this one CMD line. So PHEXDUM command line, and the command line version of this function, PNG file, is something different than in the so here. So we're gonna say how about don't have to be super efficient about this, so we could do relative file path. I'm going to call it relative file path. And the relative file path could be absolute. And because the absolute path is still relative, right? It's just relative to the root directory. Let's just say RFP PNG file, and then the other thing is CHR. If we do it the other way around, we're going to take a C99 text. So C99 text. And both of these things, sure, why not? Depending on the context. If right, so this is what we would use. This is what we would use if it was this, right? And then for the other way around, C99 text to PNG file, it would be this way, right? So this is a little bit wasteful the way we're doing this, but let's not worry about it too much. And we also want relative file path, PNG file to naked text. Oh, so naked text and the file path to that. And this is if we do naked text converted to PNG file. And we don't have a PNG file to naked text. And why don't we? Oh, we do. PNG file to naked text. So let's take all these really quick. PNG file as relative file path, right? So right, so I just don't want to be confused over what means what. So PNG file means like the binary, unless it's the path to the PNG file. So this will be the relative file path to the PNG file, the relative file path to the C99 text, the relative file path to the naked text. And do we still want to keep this like this? Like, it's still command line, and then we use the RFP version, right? So RFP, relative file path, PNG file. Well, the C99 text we get out is still going to be C99 text. Let's remove this. So so we got PNG file to C99 text. So we have one more thing here. If we did like I know this is redundant. I know this is redundant because we have PNG file here, but right, we have PNG file converted to naked text. Right, so we have these two, and these two, right, and they're paired with each other, and this is what we do, right? So they all are equal to file, right? So so we could say different meanings of right, so we could keep a little definition of this. We could also just say, you know, (26, 42). How about that? Just to be cool. And this section is just for the different meanings of the file variable, right? So the file variable has different meanings depending on what functions we execute. And we're going to do it kind of weird. We're going to front load all these different meanings, right? So we're gonna batch it like this, which might be kind of weird. And like, I don't know exactly how we want to write this. Like, I kind of like it like maybe something like that, I think. Right, so we can see this section divider here. This is kind of a weird section divider, but I don't know if I quite like this kind of section divider, but we'll just mess with it and see how we like it, you know? So, PNG to C99. And the other thing is that we're going to allow not this, just this, but we're also going to allow this. So, PNG to C99. We're going to allow a lowercase version. So we got the lowercase version, and maybe we're going to get a little bit out of hand here, but I would really like to be able to use these ones, right? These ones. So these are the actual internal command names. I would like to use those as well to know what the heck I'm doing, right? So we're just going to allow like a lot of different ways to do this, which could be bad because then you have multiple code paths that you have to maintain, right? Now you have to always support this, we got to always support this, right? Always support this, right? That could be kind of like a bad idea, but we're going to say that it's just good to have these little synonyms so that I know how to follow the code. It's strcmp. Now, how many do I want to actually do? Do I want to just keep this long-handed version, and then I want to keep this version, or what do I want to do here? The part of me that really likes symmetry is like, well, if I'm gonna do this, then I might as well do the dashed version as well, right? Like, so if we're gonna do all this, we might as well, say, hey, do we want everything to be lowercase? Do we want to do lowercase conversion? And I think if we do lowercase conversion, that's going to get out of hand really quick. But I see what we're talking about, where you might want to do this. Like, and we might want to do this. We might want to let's not worry about the fact that this just looks ugly. Right, but we have... Here, we're gonna just support... We're just gonna support... This is just gonna be ugly, 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 but we're just gonna do it, right? So, we have all these commands. We have the underscores versus dashes, and then we also have whether or not the 2 is uppercase or lowercase, and here's the C2. So the thing I really care about in terms of looking at the patterns here is this one right here. And we're not going to do an and, right? So we're going to do an or, right? If any of these cases are true, then we can execute this command right here. A PNG file, convert to C99 text. So the thing that's bothering me here is why did this not highlight right there? So let's look at that for a second. PNG file, convert to C99 text. Does it light up there? Okay, yeah, that's good. So if that works, then we want a character string for the output text. So like txt out, right? Because txt out is going to change depending on what the command is. So over here we have this character pointer. And we're just going to say this is OT output text, right? So this is the output text of one of the functions. This is a file path argument. Right, this is a file path argument. And this command, cmd, command to execute. Right? And these are the different ways that we can cast the file variable. So now the question is, should we... It looks like the thing we're going to do here is even, no matter how deeply nested we are, we're just going to keep all our variable declarations at the top, right? So we can call this declare vars, right? And declare variables. We can actually create a nice little section for this. And if we create a section for this, well then we have a little problem where our commentary is a little bit too verbose, right? Because if we want to indent this, then we have this kind of like, let's just say relative file path, right? Like that. And yeah, all these, we need to make sure we initialize them later, because right now, unlike these ones up here, which are being proper, we're giving them null pointers, we're like, hey, we don't have enough room, so whatever, let's just, let's not do that, let's not be stupid, let's not be stupid because of our formatting, right? So, take a char pointer 0, right? And now we have a null pointer to a character string. And then let's just write this as RFP like that. There we go. So, this is a PNG file as a relative file path. This is C99 text as a relative file path. Naked text as a relative file path. And then we can also make a note that what RFP means, right? So, RFP, relative file path, right? Inputs and outputs for command line. Right, these are inputs and outputs for the command line. You might notice my formatting is kind of weird, but I want this formatting to be readable even if we don't have any syntax coloring, and that's why I had this visual space between here and here. Okay, so here is see, where did we screw up here? We forgot a closing whatever the heck. And we forgot it here as well. Okay. So we got all these different ways that we can kind of call this, which is kind of ridiculous. And maybe we've gotten, like, out of hand here. But, I'm just going to go with... I'm going to go with it. I'm going to commit to this. And we're going to... We want 1, 2, 3, 4 commands that are on the console, right? So we're going to take this, we're just going to paste, paste, and paste. And then else, we're just going to say printf, I don't know that command, boss. Okay. Okay, and now, we need to use the correct commands, so we're going to take, this is going to be C99 to C99 text to PNG file. So, right, so PNG. C99 to PNG, right? So we're going to take C99 code, convert it to PNG, aka C99 text, convert it to PNG file. And if we do that, then right here, this is going to be called C99 text, convert to PNG file, right? So now we have 2 of those functions down, and that also means that this relative file path is no longer, this is now C99 text. And it looks like we kind of screwed up this variable here. So it's RFP C99 text, right? So RFP C99 text, this is RFP PNG file, right? So we have 3 namespaces here. So we have a namespace for the command line, right? So I don't know if that's the best way to do this, to make a command line namespace. Because it is kind of confusing. But the thing is we don't want to confuse this function with the other function that's just this without anything in it, right? So yeah, I don't know. That is, the namespacing is going to get a little bit weird, but oh well. We'll worry about that when we get to it, I guess. So I think one thing we could do is, instead of doing this where we have everything is kind of sparse, I think what we can do is we can make a I'm going to call this sanitized CMD. And what we're going to do here is, this is kind of ridiculous, right? Where we have like this big branch. We got like all these different comparisons. And I think that is just kind of ridiculous. I think that I don't want to do that. So I'm going to say the sanitized command I'm going to make this an enumeration. Right, I'm gonna make this int 32. Sanitized command. Alright, so enu is going to be a sanitized command enumeration. Let's keep the same indentation as everything else, so we're not going to indent anymore. And then what we can do here is we can just say that I know it adds more indirection, but then it makes everything a little bit more clearer further down. So the enumeration equals, and we can say AAC 2020 PHEXDUM CMD line CMD name, maybe, and command enum. So that gets kind of long, though. That gets kind of long if you use enumeration, but you get the idea, though. Let's, it's long, but I actually think that's kind of how we want this to roll. Because PNG file is C99 text, it's just the enumeration. Yeah, I think that's how I want to roll with this. I know that's kind of, it's like really long, so it's kind of like this is ugly. This is ugly, but it's kind of like how I think it should be done. So let's so what I'm saying is, you know, the enumeration, right? So we can take this code here, and we can just say that do we want to make a function for this? And I think we do. I think we want to make like enu equals AAC 2020 FileAccess CMD FileAccess command text, like CMD text. Convert to command text to command enumeration, right? And then we'll take the CMD, right? So CMD. Right, and then we can go over here. Command line. So we're thinking that anything in the C11 thing is just not going to be included in anything else, but we might want to keep. We may want let's try to keep everything. So let's keep this and say that this is, you know, int32, right, a command enumeration. And let's indent this a little bit. And then just say that, you know, the input is going to be a character pointer. And it's going to be CMD text. And the output, right, make a little utility, right? So command line helper functions, right? So command line helper functions. It's going to be like a little section. Yeah, I think that if we just put, let's not discard any of the functionality that we write. Like, we may want it eventually for some reason. Like, maybe if we have a built-in command parser in the game, being able to wire into this easily might be nice. So let's take all this nonsense here that's getting, like, way out of hand. And, let's just create some tables, right? So we got these tables of basically synonyms, right? They're synonyms. And we could look at the data here and just create like some type of synonyms table, right? So we can say like AAC 2020 FileAccess, and we could say I'm gonna say table normalized name, and it's going to be table it's a table of strings, really. It's a table of strings, and it's a PNG file. Oh no. Well, first of all, let's make it lowercase. It's going to be a table for PNG file convert to C99 text. And this table is just going to store all the different strings that can evaluate to this thing here, right? So it's going to be a char pointer. And this is for normalizing this command here, right? So PNG file the C99 text. I don't know why the syntax highlighting doesn't work. Like, whatever, it works good enough. But let's create these tables for normalizing the data, I think. Command normalize. Right, so command normalization table is what this is. And we're just going to call it table. and then it's a table of these things, right? And we're going to try not to get any more specific than we have to, right? So the reason we have to call it table is because otherwise we're going to confuse it with a function, right? So tab for table rather than the function of the same name. And let's try to do that for every one of these and hope that this is the proper way to declare a char pointer. And I believe it is, but let's cross our fingers, hope we're correct there. And we just want to get all 4 functions, so this stuff here, let's paste this here, because I believe we already worked on that. Right, so it's just the inverse. And this is, you know, C99 text converted to a PNG file, right? And then, do we have this as well, or is this just not done yet? I don't think this is done yet. PNG file to naked text, right? So none of these say naked text yet, right? Yeah, none of these say naked text, so we're going to take anywhere where it says text, we're going to replace it with naked text, right? So let's take these. Let's go over here, make a new file really quick, and then let's look Control-H, and we're going to look for C99 text, and we're going to replace it with naked text. NAK text. And we're going to go, hey, any of these places, we're going to just replace. Okay, now that we have this, we can close this, and we can paste this over here. Okay, so we have basically these tables for sanitizing or normalizing the commands, right? And then what we can do is, well, we can fix this. So this actually needs to be 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 different things in here. So we need to put like 8s on these. And then the command text to the command enumeration we need to do. So what we're going to do here is we're just going to go through each one of these. And since they all have the same length, what we could do we're going to say that 0 is an invalid command enumeration. So that way it's commands 1 through 4. Okay, and what we'll do is we'll go through all this stuff here. So the table equals this thing. Let's actually create table of tables. I'm just going to call it tab. I can see why doing this, making this more generic, just makes things kind of hard to follow sometimes. But tab could be 1, 2, 3, 4. There's 4 commands, right? So we could say that we're going to take it, we're going to make 4. Actually, we're going to make it 4 plus 1. And the first slot is just going to be we're just going to call it invalid command. But we're going to try to keep the data kind of similar. So we're going to keep 8 slots here. And let's call it invalid command. And then what we can do is we can make the first entry here, we can make it, you know, literally invalid command, right, for slot 0. And then we can take all these and we can say we want to do everything in order, right? So we want to say that we want to do this. We have 1, 2, 3, 4, 5, 6 things we want to do, right? Or we want to do these 4 commands. We're all over the place, so I apologize. But we want to do 1, 2, 3, 4, and this is not going to be a thing, right? Yeah, so we want to do 4 commands publicly, so 0, 1, 2, 3, and 4. And we'll take this thing here. This is the first one. This is the second one. Then we want the third and fourth one. So here's the third one down here. And then the fourth one and final one right here. Let's make sure we didn't lose track of anything, because there's definitely the potential of really getting lost here. So let's color code all these. So let's say this one we're going to make like a, I don't know, green. Sure. 1, 2, 3, 4. So, oh, sorry. 4. So cyan, orange, yellow, and purple, and also this green. So we have the green, cyan, orange, yellow, and purple. So everything is accounted for here. And these are just different lists to sanitize the names. Right? So we have a command normalization table. And what we might also want to do, I do really like it being like 8, but what we might also want to do is, so I want some ways to like know that this is my engine. Like, if I want to be able to prove that this is my engine, how do I do that? How do I put code in here that we can prove that it's my engine? And one of the ways we could do that, and it still doesn't mean people can't like people, if they want to be dishonest, could go through the engine code and strip it out. But why don't we add one more command name to all of this, right? So why don't we add, I know we have 8 things, but why not make all of these why not make all these entries 1-based, right? So we have 9 entries. I'll show you what I'm doing. So let's go invalid command 0, 0. So we could make these kind of like more beefy names where I actually say what the engine is by kanji coder, right? And so we can like have that in there. So when we're searching through the code base, we can see this show up in people's executables if they use our engine, right? And then what we could do is instead of making all these 8s, we can make all these 9s, right? And then what we could do here is we could say, for each one of these, we could say, so it's like, we don't expect anyone to use this command, right? Because this is ridiculous. But now we have... copyright 2021. Yeah, so copyright 2021 Atomic Alice C engine. AAC 2020. Right. And we could just throw that in here like that, right? So it's not actually going to be used, but we can just kind of interlace it into the data and make it kind of like very difficult to... We can make it very difficult to get it out, right? Because it's like it's in there. It's in the source code so deep that if we wanted to get this out, we would have to... It would take a lot of work to get it out of here, right? So we're kind of saying, hey, let's embed this in here so that it's in there, and the only reason it's in there is to know that, hey, this is our engine, right? So copyright 2021, Atomic Alice C engine, and then AAC 2020 in parentheses, and then these numbers here, right? So now we can find this very specific string kind of like embedded into the data for this thing here, right? AAC 2020 engine by kanji coder. Invalid command, right? So cool. All that looks good to me. I think we are getting way too complicated here. I think the amount of indirection is kind of ridiculous right now, and maybe we should rethink how much indirection we have here. But it's something different that we've never done before, so I think that we're gonna just try it and see what happens. And I don't know if it's gonna compile. I don't know if it's gonna let me do all this weirdness. But we can say this table equals the command. So rather than have 1 equals command, 2 equals command, we can say the table equals the command right here. And the other thing we could do is we can list out the different command table things. So CS start. And now we can collect all these in order, right? So let's collect all these in order to make sure we know what the heck we're talking about. So let's just copy this, copy this, copy this, and copy this, right? So copy those 4 strings and then do a CS dump, or a CS dump. And right, so we can make a list of the different commands, right? So these different commands are these guys right here, right? Now, we could keep that list of commands. These are command enumerations, right? And we want the command enumerations to be kind of like in the same order as all of this stuff, right? So actually, we can't have a jump table because a jump table needs to reference functions. And that would violate the functions depend on data, but data does not depend on functions. So we're not going to have jump tables. We could also do this, though. Not allowed. Data cannot reference functions in our so we can make a note that this is not allowed. Data cannot reference. Data is not allowed to reference. Alright, so we can make a note that that's not allowed, and we can still make a section for a command jump table like this. And just say, hey, you know what? But you're not allowed. You're not allowed in here. In case we get that crazy idea to do that, right? And then this kind of thing that we put here, we can make a note of it here. And we can say these enumerations here, we can just say that, you know, these are for these different tables. Right, so instead of table, we can say enumeration, right? So we can use that enumeration to get into here. This table is kind of concerning. I don't know how well that's going to work, but right. So these enumerations, we can say like int32, and these can just equal, you know, 1, 2, and 3. 1, 2, 3, and 4, right? Define int32, undef int32. And then we can use these enumerations. We don't really need these enumerations. we can do a little assert here, right? So really we can be really terse like this, and that'll be everything that we want. But that can be kind of complicated, so we could say, you know, if 1 equals the table, make sure that the actual jump table we're using are these. Yeah, so this is the reason why doing things directly can be a better way than how we're doing things, because then we add a whole bunch of check code anyway, so it's like doing it completely directly might have made more sense than adding all this indirection, I think. But it's worth experimenting with sometimes, right? To say, just to try it out, right? And I don't know if I like this, right? Because this is all we really need for the table, but we might want to, so these are our different, sorry. So these are our different sanitization tables, right? These are the different sanitization tables in order, or not. What the heck here? This needs to be enumeration, right? Let's try that again. So we still have a problem here, don't we? Let's just take all this, paste over that, take all this, paste over this, take all this, and paste over the third thing, and take all this, paste over the last thing here, right? And so we want to assert that, if the table if the command, so looking at the different commands, if we look at these different commands, what we want to do is we want to assert that we have the correct table and the correct enumeration, right? So this command enumeration, if 1 equals the command enumeration, then cmd enum, this command enumeration is going to equal one of these things, right? So it's going to equal one of these things. So the enumeration is going to equal this. And the table is going to equal this thing. Hold on. Right, so we got an enumeration and a table. And this is just a check value, right? And we just want to say, we want to assert that the table, I want to assert that the table that we selected from here equals this, right? So, 2 terse for my 2 terse will be hard to understand in a few months, so add lots of checking code to. So we could just, this right here, this table down here is just this lookup table thing, it's nice how you can do things very tersely like this if you absolutely need to do them. The problem is that it's so terse, this is so terse, that I'm not going to know what it means in like a month or even a week from now, right? So we want to say, you know, at this time in this video, so the video ID is 120. And we just want to make a note of that, right? We want to make a note that, you know, we're not going to know what the heck is going on with this in a month from now. This thing here, this table lookup thing here. So we might as well make, hey, here's our enumeration and here's our check value, right? And so we could say, define enu and cmd enum, right? So we could define enu as the command enumeration, right? And then we can go over here, and everywhere we're using enu, we can just do this, right? And then chk, we can just say chk is a, what is chk? Chk is a check value. And this check value is for a table, and the table itself is a char pointer table, right? So, so this is going to be a chr pointer chk equals a chr pointer 0, right? It's going to equal void to start with. This is going to be int32. I can start lining up everything very nicely. Check. Right, so we're going to check ourselves, right? That's what that variable is for. And 0 is okay, we have our check value, and here we're going to assert. We just want to assert that the table equals our check value. So this is kind of the, what is here is basically the naive version of this table, right? So we're just kind of like, so it's kind of inefficient, right? So if we want to understand this at a very terse level, this is what we're doing. But we're going to rewrite, we're kind of rewriting the code twice. But I like the redundancy, right? To make sure that everything works. And so everything here should be, we have like enu and check, right? So we're going to say enu and check, enu and check, enu and check, and then we're going to make sure we have the correct spacings. And these are these assignments. So the enumeration value, and then the check value, and then we just want to do these asserts here, right? So we want to assert that those are correct. And then we could make a function table. We could make a function table, but this is already kind of crazy, right? I don't know. So this is really a table of strings, right? This is a table of strings. And then we can make a table of functions, table of functions, and that is going to be local. And right here, so this thing right here, we can say, and so rather than make it like this, we can literally make it like this, right? So we can say, these should correspond to the enumerations here. And we can say that if this is a table of functions, well, what's the signature of these functions? Like, so we're almost making kind of an interface by doing this. By making a function table, we have to keep like a constant, a very So it takes a string and it outputs a string, right? Because it's the command line version of these functions, which the input is a string and then it goes to a file. So knowing that, we can say go over to the data file, and we can make a function pointer type. So function pointer types. And I feel like this is kind of over-engineered, but that is why we use C, because we're already kind of over-engineering things as it is. And if we used a more complicated language, we would over-engineer it even further. So I know that some of what I'm doing is a little bit crazy, and I think it's the best way to do this. I think, but I always like to experiment with how we do things and kind of like see how it works, right? So we could, yeah. So I'm not perfect here, but let's get it working and see how we feel about it. Right. Every time sometimes I just like to code things different, just to experiment with all the different ways you can code it. Because if you don't do any experimentation with how you code, you can never improve from whatever your current style is. So the function pointer types, let's just do generic function pointer. And so this is a generic function pointer, but let's create a function pointer. Let's call it FileAccess FileAccess command line function, right? And the command line function is going to take a character. It is taking a piece of, it's just taking a character pointer to the file, right? So it's just taking the file path. And I think we named these, right? We named them something, right? Relative RFP. And I don't know if we want to call it relative file path str or str relative file path. Let's just call it RFP str, and let's go into here and say if that's what we want to stick with, and we're not sure which way to do it, because we're not sure of like what is generic and what's specific. Let's just say let's stick with this. So RFP str. And we'll just stick with that, right? And so and we already screwed this up, so RPF str, RPF str, and we're just going to say typo of relative file path str, right? And if we do this backwards, str RPF, str RPF, str RPF, right? So if we do this backwards, oh, that's wrong, str RPF, backwards and typo of R relative file path str. And so I'm already going to say that I do not like this, because we call it this, and we're already getting this dyslexia of, is it RPF or RFP, right? And I don't want something that as someone who's dyslexic, which I am, but just a bit, I would not say that publicly in a job interview, right? Don't say what kind of disabilities you have in a job interview. You know, you want to state what you can do. But since I do see that I have a propensity to get this backwards, I'm going to say str relative. String relative. And that stands for a relative file path, usually, right? So if we do rpf_str, rpf_str, use strrel, string relative. Right, so string relative will basically means a relative file path. And then strrel, if we use these, then we'll correct them. If we type it correctly, like strrel like this, we'll just say, hey, good job. And if we do it backwards, right, like rel str, we're going to say, so the general part is that it's a string, and the specific part is it's like a relative file path, right? That is the justification for how we are writing these shortcuts here. Okay, and let's just see if we have that already. So rel str, how about strrel? Nope. Okay, cool. So now let's go over back to the code and say, okay, we've kind of thought about this, and this we don't like. Let's make sure that is in our code where we can find it if we type it like that. And no, we do not have this thing. It's a typo of this, but we don't have that anywhere. RFP, relative file path str, right? Once again, it's because all these are the same. Relative file path str, relative file path str, and relative file path str. So this is why I don't want to use this for a shorthand variable, because even while I was documenting it, I was making mistakes. So if I'm going to make mistakes while I'm typing it like that, then I absolutely don't want it. I want to eliminate stupid mistakes like that. So we're going to call it rel str, right? So FileAccess command line function, right? So we're going to make it a very kind of obvious type, which is kind of like, whoa, that's kind of big, but we're going to do that. And this type def, right? We very rarely use type defs, but when we do, we get kind of crazy. And it's just going to take a... it is going to return a character pointer as well, right? So it's going to return... so let's define chr over here, right? So it's going to return const char. And then undef. Sorry. Undef chr, my bad. So there's no really string thing, right? Because a string would imply a pointer, and we don't want to have pointers within our defines. So if we say define str, or define str, use define chr, don't embed pointer within define, so no string define type, right? Undef str, this explanation is kind of long because it takes up RAM. So let's just say no asterisk in defines. And then we could also make a note of what that is, right? So no asterisks types like str cannot be defines because we do not encode pointers into types. There's an exception I use. So the exception is the function pointer types. Besides that, we don't do that kind of nonsense. So yeah, so we have this type def for a command line function, and then what we can do is this table of functions. We're going to say that we're going to say we have an array of these types, right? And there's going to be 5 of them, right? And we're just going to say we'll just initialize it to null pointers, right? And this is kind of long, right? So let's just say this is a command type, so why not define CMD like this and define it up here so that we can just create a command type like that. And then we can keep this a little bit shorter. And let's be explicit. Even though we 0 initialized it, let's be explicit and say that this is a void pointer or a... Yeah, let's just do void pointer 0, because otherwise, since this is a function pointer type, I think it's just going to make things harder to read. I don't know. Right? So no function in slot 0. So we have this table of functions, right? The table of functions maps directly to this command, and the sanitization table maps to this, right? So now the thing is when we're going through all these commands, we don't know if it's the command we want yet, right? We want to go through the table of strings here and decide if are we actually on the command we want, right? So are we on the command we want? And wasn't this supposed to be a sanitization function? Command enumeration? Yeah, it was just supposed to be a command enumeration, right? So we got a little out of hand here. Let's not worry about how out of hand we got. Let's just go here and just say for, and we're going to say that we've hard-coded everything to have like 9 commands here. Or 9 things in here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll loop through all those. For loop through synonyms. So that's what syn stands for, right? So over here, we could just do int32 syn. And this is our command synonyms, right? So this is getting kind of ugly. Let's kind of group things. We got this table of functions. This check value, let's... command synonym index. Yeah, so this is, yeah, I feel like this is over-engineered, but oh well. So we're going to go through all these command synonyms, and the command synonyms are in the table of strings, which this table of strings needs to be equal to this check thing here, right? So these are our different synonym tables here. And now I see that this should be, the top thing should be the enumeration, right? So this should be enumeration, this should be enumeration, and this should be enumeration here. Okay. And we're just going to do strcmp, and we're going to take this table of strings, we're going to take the synonym, and then we're going to take the actual command, right? So this is command text. We want to take the command text, and, you know, so let's take this command, and let's actually go command equals 4. Command is greater than equal to 0. And so if the command is equal to 0, no valid command is found, right? And we could technically break out of it right now, but let's not do any breaks. Let's try not to do any breaks. And let's also make these all else statements, right? So let's do else, and else, and else. And then we can do else here, and we can say, you know, error, invalid command index. Right? And are we on the command we want? So we compare the command text with the table of synonyms. And if the delta is 0, then we're actually on what we want. And if we're on what we want, then we're saying, hey, let's break out of this. Or let's not break out of it. Let's just... do you want to loop through everything just for the heck of it? Now, if we just loop through everything all the time, the processing is inefficient, I think, doing it that way. But we'll detect any problems right away. If, like, if we select this command, and so it breaks out early. Actually, if we select this command, it breaks out early and finds the command. It never executes through this code. And so there might be a problem that goes undetected. So we could just waste cycles and loop through all of the data, even though we already have our selection, and never use a break statement. And that could just, even though it's less efficient, it'll help verify the correctness of the code more thoroughly. So I think I'm going to do it that way. So the command enumeration right here is 0, right? So this command enumeration, the command enumeration is going to equal, right here, this command right here, this command index, is going to be this, command enumeration, right? And if that is the case, we've already created these, we have this table of functions here. This table of functions here, We don't really use it. Whatever. Let's call it 4242 because we want to be cool. I'm just gonna say don't break here. Inefficient. I know. We want to avoid different code execution paths. Let loop run to the end. Oh, hey, let me frame rate. Oh, my frame rate looks good. So, yeah, let me, give you an overview of what I'm doing right now. So I'm in the middle of stuff, and this code is kind of ridiculous, where, like, I could have wrote this code more efficiently. Now, the problem is, like, when you write code very tersely and very efficiently and very compactly, that code can be very hard to follow. So I decided to write the code very compactly, but then I was like, I'm gonna put a whole bunch of asserts in here, and by the time I put all these asserts in here, I might as well have written it in a non-compact way. So I kind of am experimenting with how to write code in different ways sometimes, and so this is kind of like an experimentation, so it's not... I don't even think this is the best way to write code. It's kind of crazy. So let's go into a high-level overview really quick, Luncho, about what's going on here. So I need to get assets into the engine, into the rendering engine now. So let's actually open up the... Let me show you where I am right now. So let's go into the AAC 2020 game engine folder and show you like where we currently are, and then explain to you the utility I'm writing. So I'm actually in a new code base. It's just we're going to write a small command line utility to convert PNG files to hex dumps and hex dumps back to PNG files. And when I say hex dump, I mean like an ASCII string that represents a hex dump, right? So so right now, this doesn't look like much, but this is actually the renderer. If I press P to give it more data, to give it an actual data set that has something in it, then, oh, hey, we see these little tiles. And you'll notice that we still have black over here. And the reason for that is because the default data, that's just the way the default data renders. Like, I don't think there's any actual mistake in the rendering technology we have here. It's just the, well, I do see some mistakes now that I'm looking at this. So I see some mistakes, and we're going to have to figure out what's going on here. But before we even try to diagnose how this visually might not look how I think it should look, we need to get some data into the engine, and we want to make sure that when the data gets in the engine, we know exactly what it looks like. So in order to do that, I want to hard code some bitmaps into the engine. And in order to hard code those bitmaps, I want to encode the bitmaps as just an array of uint32s. And those uint32s are actually just a hex dump of a PNG file, right? So I don't want to do like a literal bitmap encoded into the engine code, because that would take up a lot of space, right? So even if I do a black and white bitmap where it's either a 1-bit or a 0-bit, it's still a lot of memory for the 256 by 256 bitmap that I want to use. So in order to avoid problems, we're going to in order to avoid problems with taking up a lot of memory, we're going to encode the hex dumps of a PNG file, right? Because a PNG file is already compressed, right? So we can use the PNG file rather than a bitmap and encode the PNG file data into the source rather than a raw bitmap, and we can save some space. So let's look at what I'm going to do for the asset that I want to encode, right? So in the mod folder, or actually, is it in the mod folder? No, I made a lib assets folder. And here's what we want to encode into the engine data. So we have this like quad tree like structure. Remember how I said that the tile sets have different layers? So we have 3 layers. We have this layer, this big layer. So on our biggest layers, where we have the most detail, layer 0, layer 1, and layer 2. We want to encode these patterns into the game engine so we can verify the correctness of the renderer code. And so you notice that the first layer here is just blank. It's just, we just surround it with one layer of tiles around the border here. And that's because if we can't verify this very simple pattern, it does not make sense to try to verify these more complicated patterns. And so we want to encode this. We want to take this file and run it through our... We're going to take this file and we're going to run it through our utility to convert it to a hex dump. And then we're going to encode that hex dump into the library. So right now the code is a complete mess where I wrote a little bit too much code before writing all the functions. But we want to do something like where we can write the function on the command line different ways and still get it to work. So we have PNG file to C99 text, C99 text to PNG file. And then these need to be scrapped. This is kind of a work in progress. So this big switch here of all this data here, we're just gonna do this. We're just gonna say PHEXDUM stands for PNG hex dump, and it's the command line namespace, and C99 text to PNG file. That's not quite right. Hold on. I didn't delete enough from here. Hold on. Let's delete more. Okay. So we're going to take the command text and we're going to convert it to a command enumeration right here. And then with that command enumeration, we're just going to... We could use a jump table, right? We could use a jump table like this. And sure, why not? Why not encode like a little jump table? Because I think it'll actually be more terse. So we can just say JMP for jump. And, you know, assert, you know, enumeration is greater than or equal to 1, and enumeration is less than or equal to 4, right? We want to make sure that we're in range, so we don't get a seg fault. And we are doing our jump table, where we're going to use 1-based indexes, just because it's going to be easier to comprehend here, because we have like 4 basic functions we want to map. And for this jump table, we got to declare it somewhere, and do we declare enumeration somewhere? Yeah, sanitized enumeration. Sanitized enumeration and corresponding jump table. Right, so we're going to map enumerations to jump tables. So we're going to sanitize the string command to an enumeration, and then use that enumeration to access a jump table of commands. And so we're going to say command pointer JMP equals yeah, command pointer JMP, and then or actually no, not command pointer. We're going to say it's going to be CMD JMP, and there's going to be 4 plus 1, right? So there's 4 entries, but they're 1 base, so 4 plus 1. And then we're going to 0 initialize it. And then we need a command type. So over here in our data file, we're like all over the place, so I apologize. we're going to just make a define for this. So we're just going to define CMD as a command line function type. And that way we can just use it right here like this. And we can populate our jump table like this. And then all we're going to do is say JMP enumeration. And then after we select our function, then we're just going to execute it. And we're going to execute it with just the text string, the second argument, right? So we got this argument array, and the file is what we want to use. And this is kind of like, let's not even worry about this. We kind of got a little bit out of hand. Execute proper function. So these are all the different ways, these are all the different meanings that the string, the file path string could have, depending on what function's getting executed. And this is probably like just a bad, this is probably a bad idea, I think. But let's just let's just put some no-ops in here for this. And just not worry about it. Say we just got a little out of hand with the way we decided to do things. Let's not worry about it. Let's just say, yeah, our code has some weird artifacts in it, but let's just keep on going. So I would like to kind of like indent this a little bit more, but then we're outside of our boundary. So we're just going to say, you know, call function from jump table. Now the question is this a good way to do this? Now, with function pointers can sometimes make code harder to follow. But we make the jump table right here, and then we just execute it right here. So I don't think it's that hard to follow. It's just that this is just a more concise way. Rather than doing like if else, if else, if else, we can just create a jump table, right? And then that also forces us to keep a common interface with how these functions need to be, right? We know that all these functions have the exact same interface because they're in the same array, right? And that array is all the same type, right? So I'm just going to keep it like that for now. So we're going to call this function from the jump table, and then once we've called this function from the jump table, well, what are we expecting back, right? And we're actually expecting back a string, and a string of data, right? So output text, right? So OT, out for output text, that's actually what we're expecting out. And then we want to save output text to a file. So let's just say that OT here is going to equal error output text message. So how about this? We say error output text message, and then this is going to be a char pointer. And this thing that we kind of hard-coded in here, we're going to just put this here. So we're going to print it, and then we're also going to print it out to the file as well. So okay, and then we can take this, we can printf this message, and then we can also set it as the output text. But the output text can also be set here, right? And then all we want to do is save text to output file. And I don't know exactly how we're going to do that yet. Because it's not like I use File access is not something I do too often, so I'm not, like, up on it. So if, we're just gonna do this to... If CHR pointer cast of 0, we're just going to do this so we have an effective no op in here. Null output text should never happen. So if we get this, we'll make a little error, and then we can figure out what to do here. So we don't know what to do here yet. To do, figure this out. Right, and we can put this off the edge, because this needs addressing, but I just don't know how to do it yet. So we just want to get everything compiling first, right? We're all over the place. We just want to compile everything, right? So character, I32, and CMD types. Do we have any other types besides that? It looks like that's all the types. So let's take all this from the main section and put this over here. And then let's just create the undefs for these types. Create maybe a checksum as well. 1, 2, and 3. So we got 3 different types so far. And 1, 2, and 3. Okay. So what's next? I know we're all over the place. Well, I guess the next part is we just want to get this working, right? So we got this table, we got this sanitization table, command normalization table. So these are the basic things for normalizing the commands, and then this is an aggregate. I don't know if this aggregate is going to work, right? Because it references all of these things. I don't know if that's going to work. I think it'll work. But I am a little bit worried because I've never done this kind of like double indirection. And look at this. This is ridiculous, right? Char, pointer, 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 right? Because these are all lists, right? So they're char, pointer, pointers, and this is a triple pointer. I very rarely do stuff like this. I am kind of worried, but I think it'll be fine. So it's important that these align correctly, right? So so all these commands need to be aligned correctly. And then in here, right, we need the exact same order. Cyan, orange, yellow, and purple. We need the exact same order here. And so here's the command enumeration. And then we want to return that command enumeration. Okay, so then we're just going to say return cmd enum command enumeration, right? So we're going to return the command enumeration. So how about we don't do this? How about we don't write it like crazy like this? And how about we just say, let's just do this. Table of functions, table of enumerations. And then just, because I think that this gives us an easier way to like look over everything and make sure it's correct, right? Because now we can look at this and just highlight these, and we can see right here that like everything lines up correctly, right? And then what we can do here is, I know I got kind of out of hand here with doing this. I think this just makes things harder to follow. Let's just not do that. Let's not do that kind of checking stuff. And just say the table of strings for checking that everything is correct is this. The table of functions is this. And the table of enumerations is the table of enumerations using this command as well. Right? This is a little bit too terse, but we're just going to say, yeah, okay, I can see kind of like why I did that, just because now when we look at this, we're like, I don't know what this does anymore. Command enumeration equals this. Let's take out the 0 is invalid. Let's hope that that can be kind of implied from just the fact that we initialize it to 0, though maybe that's not. But then cmd func we can just do this. Cmd func equals so the command enumeration is this. Table of functions command. So the enumeration is this. Then what the heck is... I think it would be easier to use... So I don't know what this is here. But I feel like it'd be easier to understand this if we do something like this. Not tab func, but table of functions and table of enumerations, right? So the command enumeration equals this. But we should have a table of enumerations. And the table of enumerations is just... so this is just 1 equals 1, 2 equals 2, 3 equals 3, 4 equals 4, right? Which is kind of stupid, but that's kind of how we did it, right? So if we look at our enumerations, do we even have an enumeration table here? No, the enumeration table is just local. And then we have 1, 2, 3, 4, right? So, so we just want to make sure that chk enum, right? So if this enumeration here is not equal to this enumeration here, then enums, right? So the enumerations are improperly mapped. Right, and we could also catch that earlier over here, right? So we want to, if the table of enumerations, if and this is not command 0, this is just 0. So if the table of enumerations is 0, so if 0 so enumeration mapping error 0 all the way to 4. So 1, 2, 3, and 4, right? So this enumeration mapping table is kind of pointless. This enumeration table mapping is just here to verify that these enumerations are in the order 1, 2, 3, 4, so that they can also line up with this to make sure that our jump table works. And that is kind of weird, but I'm going to stick with it. And so we're going to go through every single command, and for every single command, we're going to say, are we on the command we want? And to know if we're on the command or not, we got to go through all of the synonyms. And if the synonym in the table of strings, right? So we're going to say the table of strings and look at the synonym. Now, this table of strings is a table of tables, right? Oh no, but we already did tab CMD, right? So we already got the table of strings out. And so right, so we have a table of strings over here. And do we have a table of enumerations declared yet? No, we don't. Okay, table of enumerations, table of functions. And if we get it, so if the command text that was entered here equals the table of strings, the table of synonyms. So actually, let's take this, let's do this here. So where it says table of strings, it's actually synonyms. They're command synonyms. These are command synonyms. So instead of calling it table, let's call it table SYN for our table of synonyms. Table of synonyms, table of synonyms. So the table of synonyms, table of functions, table of enumerations, right? That looks good to me, and we're not going to break out of this code. We're just going to let it all run, and that's just going to help us make absolutely sure that all the code execution paths are correct. So we're just going to let the loop run all the way through rather than use a break, but just to make sure that anytime we run this code, no matter what command we select, the code execution is always the same. The only thing, right? So we loop through all the data every single time. So if there's any mistake in this data, we're going to find it the first time round, rather than, you know, finding that error being dependent on what command we select. And we're going to change how this works here. We're going to make this like a... We're going to say command text to command enumeration. And we're just going to say char pointer, CMD text. And then we're going to do this. And then we also want, we're also going to do command text to CMD func. And that's going to return a CMD type. And we're going to use this kind of a generic command text to we're going to make this a helper function. And we're going to make this a char pointer. And we're going to call it this. So we could use an enumeration here. But we're going to be kind of inefficient just to make the code kind of easy to follow. And call this this or that, right? And then what we can do is down here, instead of int32, we got to return a void pointer. Returns integer or string. And then down here, we're going to say that if strcmp cmd enum, right, so this thing here, if that equals, not equals, but if 0 equals this, right, so if this, if the input ends up being equal to this, where we want a command enumeration, then we're going to say that, we're going to say void pointer return data. Okay. And if 0 is this, then command enumeration. We're going to say that return data equals this. It's going to equal the enumeration. Else, I know this is a little bit abstract, and it's just a else error invalid return invalid return data requested, and return data CMD func. Right, so we're either going to return the command enumeration or the function. So CMD func or CMD enum. Alright, so we can see that those two match like that. One's quoted, one's not. And this is void, and so we're actually going to make this lowercase, so this is going to be private. Let's just call it, I think it would be easier to read if we just put a private like that on it, just so that we see this namespace, we see private. Oh, and that's nice, that private is 4, 5, 6, 7, 7 letters. And then this big kind of thing here. And then for these, we're just going to say we're just going to use these private functions. And we're going to take the command text. And the second parameter is going to be cmd enum, right? And then we're going to say cmd enum equals calling this, right? And then just return cmd enum. Then we can take all this and we can just paste it in here. And instead of cmd enum, it's going to be cmd func, right? We're going to return a function type. Right, so instead of cmd enum, we return cmd func, so we say or cmd func. And we might want to just shorten this somehow. So what if we did like a define God, that's just way too long. This name is kind of ridiculously long. I don't really like it. I think this is kind of ridiculous. But right, you get that this first one matches. So if we look at cmd enum versus cmd func, right? You see how we have these two different things kind of clustered like this. Yeah, so that is kind of... Yeah, that's fine. It is kind of verbose, but oh well. And then what we can do down here... somewhere we're kind of like getting this jump table, right? So what is this jump table again? Call function from jump table. So it's like we already got the function from jump table. How do we do that? Well, we have command text to command enumeration, right? And is that in here? Yep, so we have that. So what we also might want to do, make sure, is that we see this jump here. Let's do function equals this. So this is also the command text. I know this is really inefficient the way we're doing this. But we have the command enumeration and we have the command function. And we have this jump thing here. And we want to say that, you know, if let's just do an assert, right? Assert that JMP enumeration. So assert that this equals the function, right? Assert that those two things are equal. And we don't want to accidentally... Let's just do address of. We can't really dereference one of these things, right? We can't really dereference a, like, function pointers are already they're already. Now let's just do... So what I'm concerned about right now is accidentally... I'm concerned about if I accidentally do two equals here. If I accidentally do one equal and this just causes problems. So I feel like what we could do is if this is equal to this, right? If these are both equal, then are their addresses both equal as well? And I would say not, because the address of this is the address of the memory. The address of this is the address of the memory slot where we're storing the address to this function. So the address of this function and the address of this are not the same. So we can't wrap this with an AND, otherwise that would not be correct. So let's just do this assert and hope that we don't screw that up, right? And hopefully our assert will catch us if we use an equal there, right? So now we kind of have both of these functions. We don't really need this anymore. And so it's kind of just a redundancy to make sure that everything is in the correct order. And I think that's fine. I think that's fine. Yeah, so we have these helper functions, and they both map to this upper helper function here. And it's just going to return a void pointer called return data. So right down here, we're going to say return data, right? And return data equals the command enumeration, or the command function. We want to make sure that the command enumeration is that integer. Yeah, the command enumeration, command function. That all looks good. That all looks good to me. We need an int32 type as well, so define i32, and we also need to define chr, right? So we need those defines, and that should be, I think that's all we need. Even though this code is kind of complicated, I think that's the only define. Oh, I think we only need 4 defines, so I could be wrong, but and then we'll undef this here. And I do think that we are going to keep these command line helper functions in the F file, just in case if we ever want to use like a command line utility. If we ever want a command line embedded into the game, we might want to access these from the embedded game command line. So that's why I'm keeping these command line helper functions in the main function file rather than in this C11 file. Okay, so we've written a lot of stuff here. So the next thing we want to do here is we just want to say printf got this far, figure out rest. So we got pretty far, but we still need to figure out the rest. Halt is typically the first function. So right here, we're going to make a halting function, so PHEXDUM. And then over here, we're going to call this PHEXDUM. PHEXDUM, right? So PHEXDUM. Let's just take the time, so it's 9:17. 9:17 is too high of a number. So how about, let's just take 1, 8, and 9. 189? The error number really doesn't matter, but I just want to make it a just give it a different number than what I usually do. Okay, so we got the halt function. Oh, we also need that here. So define ERR is going to be this halt function here. So AAC 2020, and then the halt function for the library, right? So, and we are namespacing it with AAC 2020, even though right now we're coding it as a standalone library. And the reason for that is so that we want to cut and paste this into our main engine. We'll be able to just cut and paste it without any like refactoring, and that's why I'm adding the extra namespaces, even though this is a standalone utility. Okay, with that, so we just want to save text to output file. We're going to execute, where are we executing the functions? Right here we're executing the function to get the output text. So that means we need the proper functions. And so these are the function names. So these aren't the function names. This is the table of functions. Well, hold on. This isn't, so why is this called table? Hold on, let's look at this. Table. This is the sanitization table. So let's just try to make this easier to understand, I think. Let's, because right now I'm looking at this and I'm like, that doesn't look quite right. Table of synonyms equals this. Yeah, let's just create a, so this isn't quite right. Yeah, let's call this table of synonyms. These are all tables. Tables of synonyms, tables of enumerations, and there is no table of functions unless we want to make one. And we can. If we want to, so right now the data just needs to be normalized a little bit better. So instead of calling these tables, I'm going to call this syn. So synonym table. And then we're going to just call these synonym, right? So these are synonym tables. And let's just kind of make another, let's just make another section divider for this, like double section it off. And just, we're gonna just put syn in front of all this. So we're kind of like renaming things. Oh, so I see, I don't know if that's you, Luncho, who kind of is back. But here's the demos that I'm working on. Depending, because I don't actually know who is in the chat room when I am doing my stream. I just see the chat, but I don't see who's here. So I'm working on a hex dumping utility to convert a PNG file to a hex dump, like a hex dump string, and then I want to also convert that hex dump string back into a PNG file. And we're going to use that to encode assets into the executable. So I am working, the overall project I'm working towards is a fractal auto tiling engine, but that is like the current thing that I'm working on here. And right now we're just trying to write the code in a very normalized fashion, and so we haven't really gotten this compiling yet because we keep on changing our mind about how we want to do this. So we got a table of synonyms, we got a table of enumerations, and we have a table of commands. So this table of synonyms just needs to be like a character pointer 0, or like a null character pointer, right, for the first one. And it's not a... Each table is a list of strings, right? So, like, each one of these things is a list of strings, right? Yeah, each one of these is a list of strings, so it's a character pointer. And... so let's... yeah, so I'm just trying to normalize what I have currently, and so it's getting kind of out of hand, but... so... do you want to go enumerations? Well, what's the order in which we access the data? We need to first go through all of these synonyms, and then we can grab an enumeration and a function, right? So synonyms should probably be at the top. Synonyms, enumerations, and functions, maybe? Yeah, because the enumeration is used to access the functions, right? So synonyms, function synonyms. So table of function synonyms, table of function enums, right? And then we also have table functions, right? So we have these are 3 different tables that we need to go through. And the table of functions we need the actual functions. We haven't actually created those, so we're going to say these are the command line functions. So so these are the helper functions. Yeah, these are command line functions. So, and these are command line helper functions. Okay, so for the command line functions, well, what do we want? So let's put the data over here so we can kind of see the list of what we want. And we can see that these are the names of the functions we want. And we were thinking that for the namespacing of this, we actually wanted to call them CMD line whatever the heck, right? So... yeah, so over here, we're going to say care pointer, and we're going to just call it and they are going to be public, and these are command line functions. And the command line functions are going to be named directly after these enumerations for the different things we want. So we want PNG file to C99 text, C99 text to PNG file to naked text, and naked text to PNG file. So this thing needs to be changed to NAK for naked, and NAK for naked, like that. So we're going to say PNG file convert to C99 text. And we're going to say that we're going to say right now we have relative string. So we're going to just call relative string. Do we just want to call it rel string PNG file, right? So we know it's a relative string, but it's to the PNG file, right? Because we know when we say RFP for relative file path, we got kind of confused. So like that, and we can just do character pointer, right? So this is a string to the PNG file. We actually want this a few more times. And for each one of these, we're going to name it based on the function we want to eventually code for. So this one is going to be rel string NAC text for naked text. This one's going to be rel string PNG file again. This is going to be rel string C99 text. So I could call it C11 text. Same deal, really. But I feel like calling it C99 text is a little bit better because C99 is a little bit more readable than C11 because 11s look like L's. So why not just call it C99 text? Is kind of the justification there. And yeah, so we have the input and the output, and that looks good to me. Let's just return a to-do message, right? So let's just return return to-do, and then something like that, right? So let's just return a to-do message for now, until we can get this working. And it'll have the command line, whatever the heck. Command line this. Command line that. And command line that. So if we highlight these, we should be able to see the names of the functions kind of light up there like that. Okay, looks good. And for these things, let's just do an error check, right? So kind of a no-op as well, but we're just going to say that, you know, if CHR pointer 0 equals this, equals the input, we're just going to say error null input right, so we'll say kanji coder says null input, right? And then we'll do that in each one of these things as well. Just check for null inputs, just as a way to get like a really quick no-op, so this compiles. And notice that these error messages are not completely unique, right? Because it's unique here for it's not unique here for PNG file, right? Because PNG file is two different inputs, right? And then str naked text needs to be like that. Str naked text. Let's do it like that. Let's put like colons here like this. I know this is just a little bit different, but that way we can see. I just want to be able to. I want to very quickly kind of see. I just very quickly want to see kind of this thing here like that. So we're going to rewrite that a little bit. So instead of like this, we're going to take like that. So this thing converted to PNG file, right? Or this thing, this relative PNG file, converted to naked text. Or the last to do, it's going to be this thing, converted to just PNG file, right? So if we take this and this, we can see those both kind of highlight here and here, here and here. So let's kind of highlight. So if we highlight this and this, we should see it kind of like go this to this. And then we got kind of the inverse going on here. Let's kind of align this a bit better, right? So let's align this better so we can see the what is I'm going to change the alignment here a bit just so that I can see. Actually, that's kind of bad. Let's not mess with the alignment that much. But I just want to really quickly let's define nil character. I'm going to use this here just to shorten this a bit. Yeah, I don't know. Just shorten this a bit so that I can see this kind of lined up here. And then we can just say, you know, make an error message like that so you can kind of see everything kind of lined up. And then for this to-do, we're getting out of hand with this to-do message. Define ret as return. If you do that, then this kind of fits here, right? And so it's going to be the same name. Let's not get out of hand with that, right? So ret, all this we can say ret for return. And then we can just take these names here, and we can just put those as, for now, we're just going to say, we're just going to return these strings. And we got to fix them to be a to-do, we got to fix them to be something else, eventually. But for now, we're just going to return the name of the function. And that's going to be like our to-do message, right? Okay, so we got this PNG file thing. See how all three of these things kind of line up nicely? That's what I want to keep on doing. So anywhere we see this, we're going to say just NC for null character. All right, so null character. So it's a null character pointer, or null character pointer string, right? It's a null string, really, right? Not null. So NS would actually make more sense. NS for null string. So NS for null string. And these should match up, right? So these should match up. This should match up with that, right? All these things should match up. And how did we do that? We added extra space on this side to get that to line up, huh? And it's still kind of weird where we got like a little extra spaces, so I'm thinking what we can do is we can kind of indent that a little bit like that, right? So we can put this, I know that's kind of unconventional. The idea is just to get everything to line up a little bit better and be able to see that last thing right there, right? So this relative, these things here, they all need to line up correctly, right? So for the null input, we're going to change the null input to just these simple error messages here. Because I think, right, so these things here. And so relative string PNG file, relative string C99 text, relative string PNG file as well, relative string naked text. And this will be nil4. This will be nil3. This will be nil2. And this will be nil1. Just so we can keep track of them, because right now, these two messages, these two errors are almost identical, because of just the way the function works. So we don't want to get confused there. And so now we have these kind of functions that are kind of stubbed in here, these command line functions. And these command line functions are going to be used in the jump table. So CS start, let's do CS start here. And we're going to copy this function, we're going to copy this function, we're going to copy this function, and we're going to copy this function. So it's very important that those functions are in the exact order that they need to be in, the enumeration order. And then we're going to do CS dump, and we're going to dump all those enumerations out. And then we're just going to put them in here, right? So we're going to put these 4 enumerations down in here like this. And oh boy, that's pretty long now, isn't it? It's kind of flowing over our stuff here. So we got to think, how are we gonna deal with this kind of thing here? We could say CMD for command line. But do we already do this in here? So what kind of enumeration? So we got sin. No, we don't have anything called. We have enumeration. We have enu for enumeration. Yeah, we got enumeration. But we don't have, so instead of calling it command line like this, if we really want it to fit, we could just call it CMD, and then it's normalized with all of this stuff, right? So I might actually just want to call it that. And it's important to know that these commands are not, function pointers, right? They are literally commands, right? So they're not over here, right? So what we could say is, functions not pointers. Not function pointers. So we could make a not function pointer section. So since we kind of know that we have this kind of similar naming convention, but this thing that has a similar naming convention is not actually data, we want to call this section not function pointers. And what we might want to do is we might want to just say extern extern CMD, call this CMD whatever the heck, right? So the exact same naming convention, right? We've got commands, we got enumerations, and we have these sin things here, right? We can also do this as well. So even though they're declared right down here lower in the file, we can still use extern, right? So we could do this. Right, we can go 1, 2, 3, and 4. And then we can take these synonyms, and we can take the synonyms, copy them, and we can paste them right we can paste them right here. So we have all of the synonyms. Even though they're extern, they declare they're down here. But now we can see all of these similar pieces of data here, all these pieces of data here, all of these pieces of data here, right? So we can see so we could also do that down here as well. Do we want to say this kind of breaks our naming, so I'm just going to say invalid command like that. I don't know. Right, so that way we can see everything in the exact same order, right? So we can see 1, 2, 3, and 4. We can see all that in the same order. And so this command thing here, right? Command is just this FileAccess command line function. And so we'll just say that, we'll just say define CMD as one of these. Right, so that's what this is here. And then we'll just say, undef CMD. So I can see why you wouldn't want to put the pointer in here, right? So I see. So the way, so if we do it like this, I think that then we can say, we can call this command pointer like that, right? Yeah, I actually do like that a little bit better. I know I was taught to do it the other way, but I actually really like that. That makes sense. And then over here, that means that all these things where we use command, anywhere we use command in here, we're going to have to make a note of that, right? So this is now command pointer. This is command pointer. This is command pointer. Right, so all this needs to be changed now. But anywhere we see CMD in all capitals like that, this is command pointer. This is a command pointer. Yeah, I think that makes a lot more sense. So these are not function pointers, right? These are just the commands from over here. And, oops. So all these things that are saying CMD line, we're going to just say, we're just going to call it CMD, right? Command for the command line, right? It's a command. And we could do this. We could do, we could keep a list of all these again here as well. So you could take this extern here. We could just keep a list of everything that's going to be below. Now if we do this, we're doing kind of like forward declarations, but they're forward declarations in a certain section. They're trying to say what's coming, what is beneath here. So I'm not too worried about these forward declarations kind of like messing with the way we put things in certain orders. And these error messages are going to be changed. Let's change these. I'm going to change this to CMD. Alright, so all these kind of match now. Let's do that one more time. 1, 2, 3, and 4. 1, 2, 3, and 4. So we're going to just say CMD is the namespace for that, right? And command pointer, we need to declare what command pointer is over here, as well as error. So we can see that command pointer is this function pointer type here. So we're just going to define CMD as this. And we're going to define error as... Oh, we don't... Error is going to be this. And now we have kind of like... What else do we have? Do we have any int32s? I'm guessing there's... Even though I don't have int32 yet, I'm fairly certain there's going to be an int32 in here. So let's define int32 as well. So let's just do it up here. Define int32. Let's create a little checksum. And then we need to make sure that all this code, right? We wrote a lot of code. More code than I'm comfortable with, but... Alright, so we got these 5 checksums here for the command line functions. We're going to undef all of those down here for command line functions. So we're just going to say undef. And now what? I think that we got our table of synonyms, our table of enumerations, our table of functions. We want to make sure the table of enumerations is just basically 1, 2, 3, 4. And this no longer is called tab, it's just called syn, right? So a synonym table. And so this is really not table of, this is really syn. It's not, yeah, this is actually a syn table, isn't it? So this thing here is really going to be, this is really going to be a char pointer. First of all, character, this is just a character pointer, but it should be a char pointer, right? So this is a table of synonyms. So actually this should be like a char pointer, right? This is a char pointer table, right? And this is we're just gonna call this syn, right? So syn, you're gonna take these different lists of synonyms, these different synonym lists, right? So these are different synonym lists. So they are char pointers. Yeah, right? Because char pointer is this, char pointer, it's a list. So table of synonyms, well, it needs to be char pointer. And we're going to rebuild this synonym list here. And then this table of synonyms should be got it. So a synonym table. Table of synonym, table of enumerations, right? So it's kind of we've kind of wrecked the ordering, so it's not quite. Yeah, everything's not really exactly how I want it, but syn here, and the table of synonyms. So we want to just say, we want to do some error checking, right? We want to, if the table of synonyms that was selected, so if this table of synonyms, right, that is currently a null pointer, if this is not equal to the table of synonyms, so this syn here needs to also map the same way as how we populated this, right? Syn table mismatch. Right, so we just want a little check here. And then we really, if we're going to do that, then we're going to have to, we should really make that the same everywhere, right? So table of functions. Table of functions this equals table of functions. Well, that's not right. That's not correct, right? Table of functions. We just want to say that yeah, I don't know. Yeah, we've written this kind of weird table of synonyms, right? So we're going to go through the synonyms. And we're going to compare the command text to the current synonym index. And if there is a match, then the command enumeration equals this. The function, we go through the table of functions here to get the correct function. We go through the table of enumerations here to get the correct enumeration. And that's that, right? And then, depending on what kind of data, we're going to return either the enumeration or the function. And then, over here, we have a whole bunch of junk here. We need to... Well, actually, no, this is our data now. But I don't think we wrote this correctly. I don't think we fixed this yet. So, PNG file to C99 text. C99 text to PNG file. PNG file to naked text. So anywhere we see this should be NAK for naked. add naked text to PNG file. So anywhere we see this, this should be NAK for naked to whatever, right? Okay, so the sanitization table looks good to me. We need some like little dashed lines between each section. So dash line I1 x64, and then after this we're gonna take a quick break. Okay, so we have a lot of things in here. So let's define CHR, and we also need to define, what else do we need to define in here? Is that just all we need? Yeah, so we just need to define what character is, and then undef it down here. Extern this, because it's in a different file. We're externing these because they're actually below. And these externs, they take... They're just they're triple pointers, aren't they? So these externs are not double pointers like this, they're actually triple pointers. And it just went over our head because we see the 2 pointers here, but we have to remember that we have an array syntax here, right? So it's actually a... Or actually, hold on. Oh, I see. So it's not a... Okay, we just got this wrong. So this is a triple... These are triple pointers, but part of the pointer syntax is right here, right? So double... This is single. This is single. This is single. This is single. We got that kind of mixed up there. So singles and doubles here. But then when we're up here, when we're kind of talking about them, this is a triple pointer. Let's just get rid of that invalid command thing. I don't care about it that much. It's not too important. I think the most important thing is just to know, hey, we got a whole bunch of double pointer things, and this thing is a triple pointer. That's good enough for me. Actually, it's not going to let us do that because this is pedantic, right? So pedantic, we got to just... Okay. So that makes a little bit more sense. So we got int32s, we got the command pointer type here, command pointer type is declared here, const char. Okay. So we've done a lot of stuff. I don't know if this is really going to work yet. Let's go over here for a second. So we want to figure this out right now, but for now we're going to say got this far, figure out rest. But actually, let's just kind of print off the result of the command, right? So we have this output text. Let's just print off the output text rather than that little message, because we already have this output text from executing one of these commands, right? And one of these commands here is from the jump table. The jump table is right here. So we have this says table. This shouldn't be table. This jump thing should be a command, right? And the commands, if we look in our function file, we actually have the commands, right? Command this, command that. That's what these need to be here, right? So this should actually be called CMD, right? Because it's the command. And do we want to just call it CMD, or do we have something that's already called CMD? So CMD is the command to execute, but it's the command string. So we call it command text to command enum here. So first of all, instead of command text, it makes more sense to call it command name, does it not? Yeah, anywhere we see command text, let's do cmd name, right? It's command name. Command name, like anywhere we see command text, we're going to say we have command name and command enum, right? And then over here, same thing. Anywhere we see command text, we're going to replace that with cmd name. So I know I'm taking a lot of time to be like, hey, let's and let's also make a note of that over in our shortcuts, right? So if we do something like cmd text, cmd text, cmd text, command text, command text, use cmd name because more clear name implies text/string. Right, so then cmd name, if we use cmd name, we're going to say, good, that's exactly what we wanted. Okay. If we use something close enough, so cmd name, or cmd name, or not cmd name, if we use something close enough, we're just going to correct it, no problem. If we go backwards, though, so name cmd, or name cmd, or name cmd, we're going to say backwards, use cmd name. Now, we also have another variable style, which we might want to use, so we might want to make sure we don't accidentally do that. So if we do something like nam cmd, or nam cmd, or nam cmd, use 7-letter version, and so that's going to be cmd name. So backwards and use 7-letter version. So it's backwards and use 7-letter version. If we do cmd name like this, or cmd name, or cmd now, if we do any of that, we just want to say use 7-letter version, right? And if we do something like cmd txt, or cmd txt, wrong and use 7-letter version, right? So we're wrong, and we want you to use the 7-letter version called cmd name, right? Now, if we do txt cmd, this is backwards, it's wrong, and we want you to use the 7-letter version, right? So txt cmd, or txt cmd, any of these, backwards and wrong, and use 7-letter version, right? So a lot of mistakes there, cmd name, right? So we have, like, the idea here is that we want all these different names, all these possible variable names, we want them to all converge on cmd name. We want to avoid having spelling the same variable multiple different times in the code base, because that's just going to make it very hard to locate things if the variables all have these different names that they could have, right? So we're going to call this cmd name, and then anywhere we use cmd here, we're just going to be more specific, right? So this thing here is going to be this thing is going to be cmd name, right? So anywhere we see cmd, we're going to say cmd command to execute is cmd name. And then right here, we're going to use the command name here, right? So now you can see command name. We can see the transformation is a little bit more apparent, because cmd name to cmd enumeration or cmd func, right? And then we also would probably want to do the same thing with the file path. So the input-output file, we might want to say this is file. It's file input output, so what do we want to call it, right? I don't know what we want to call it yet. So we're thinking FIL for file. So what about file IO? Like that. 3, 4, 5, 6. We could do that, like file input output, right? So, but why is it an input output file? Is that correct? It's the input output file. No, it's always an input file, is it not? Because this argument is the input file, right? It's the, oh, no, it's, I know why. That's because, right here, this is an input file because we take it and we process it. Oh, I see. Yeah, no, the second argument. So here's the first argument. Here's the second argument. Yeah, so this is the input file to process, right? So now that I'm looking at that, let's just do file input. Do you want to call it like this? Or we want to call it file input, right? That, like, file input. But it's a file path, right? So what about this? Like, file path in like that? That might make more sense. Let's just get rid of this nonsense. Let's just nuke this nonsense here. File path in, right? File path in right there. And then, let's assume that two user arguments. So if there's two user arguments, or there is three user arguments, and this only works if there are three, right? So if you take the argument count, and the first argument is always that, you know, one special argument, right? It's not user supplied. So if we're greater than or equal to 3, then we can get this file path out, right? Otherwise, file path out equals a just a character pointer, right? File path out, right? And this one's going to be file path in, right? So file path in, right? So input and output file path. FIP in and FIP out, right? And then CMD name, is that declared up here? Yeah. So this thing here, we're going to change this to FIP in. We're not going to initialize it just to save some space. And CHR pointer FIP out, right? So file path out. And this is file path in, right? And that's the command to execute, that's fine. And what else do we have here? File path in, file path out, and this is the output text. So how about we call this, instead of output text, why don't we call it text out, right? So we have a file path in, out, and then we also have a text out, right? So output text. Output text. So let's actually make some variables for this. So we have FIP in, FIP out, right? So why don't we make kind of like variables for that? So try file out or file in, right? Okay, I need to take a quick break, so I'm going to be back. Also, I need to do some push-ups as well. So let's go on break. Let's give it like 20 minutes. Actually, let's not give it 20 minutes. Let's give it like 15 minutes. And I'm going to do, or 16 minutes, and I'm going to do push-ups. If I have time to do like some extra push-ups, I'll do some extra push-ups if I get out of my break early. Or if my personal break is shorter than 16 minutes, I will do some push-ups to make up for that. So red timer. So we're gonna just go on a quick break, and I will be back. So yeah, I'll be back. Okay, so not enough time. I have stolen frozen peas, or frozen green beans. I see you. I need more fiber in my diet. Okay. I feel like today is a rough start because we're 4 hours in, I don't even have any of my push-ups done. But I already took a break, so we just gotta keep on chugging along here. Okay. So we don't actually want file in, file out, right? Unless it's like an actual file pointer. We want FIP out and FIP in. And if we do write something like fill out, or fill out, did you mean right? And if we do something like same thing. Path. And if we do something backwards, so like outfill, outfill, outfill. So with this, right, we want the same thing, but we want the input version. So FIP in for file path input, and this is going to be called in. So all these are going to be changed to in like this. Oh God, you can't even see this. So I'm just kind of working on my shortcuts here. So that's why I need the preview up there, so I know when I'm doing something wrong. So file path input, file path output, and right? And if we do FIP in means, we want file path input, right? We do two ends just to make sure that it aligns with stuff. And if we do FIP out means file path output. A few other ways to spell it. Just in case. And what else do we have here? If we accidentally do in case we ask for the definition of the similarly worded thing, we'll also put that in there as well. And we'll put that here. Oh, we got those inverted. Input and the output. So in, out, right? In and then out. So really we should flip this around, right? In and then out in that order. And so now we have these like input-output variables. We can look over the code once more. So we're going to have to keep on looking over the code until we decide that all of the code has naming conventions that we like, right? So that's the difficulty of this code right now, is just, hey, let's make sure that these kind of things make sense to us. So this is going to be a null pointer unless we have enough arguments, and we'll eventually use this, but right now we're not using it. And this output text, instead of OT for output text, we're going to use text out, right? So text out. Now, and for this, we also need some variables, right? So we want to make sure that it's text instead of txt. Or do we want to do txt for text because text is like texture, right? I do like text out instead of txt out just because there's no way I'm going to pass a texture as output. So and I like my variable names pronounceable. So if that's what we're going to stick with, that's what we're going to stick with. But if that's what we're going to stick with, then we don't want to accidentally read that as texture output, right? So these are the correct spellings. And if we do something like text out, right? Text out, or text out, text output. Right, anything similar like that, we'll just correct it, right? And same thing for text in. So for the text input, what did we screw up here? Oh, this is text in. Any of these, we'll change to this, right? We'll change to the correcting. Now, if we do something backwards, if we do like out text, or out text, or out text, I'm going to say backwards use text out, right? For text output. And then if we do something like in text, we'll want to say backwards use text in, right? So the text in or text out. So the general aspect is it's text. The specific aspect is it input text or is it output text, right? We also want to correct ourselves, or no, we want a definition. So text out means so any of these, we're going to say okay, and if we do the input, then same thing, text input, text input, right? Okay. What else? So there's a large amount of names that we could do for like making these incorrectly or making these wrong. So let's make sure that if we have any wrong spellings that we correct ourselves. So there's like many, I can see like a few permutations, right? So if we use str out, Or if we use out str, use not okay. And then we also have the same thing for the inputs, right? So let's take this and copy it. And then let's just do in and out, right? We really want to do in and out. We're kind of like inputs then outputs, and I keep on doing this backwards for some in and then out, right? Inputs then outputs in that order. So let's name these to in. So anywhere we see out, we're just going to replace it with in, right? So str out becomes in. Right, any of these. And then this out becomes in, so we just kind of... Oh, wait, wrong. Okay. These are the inputs. So we got the text input and we got the text output corrections. Now, the other thing we might accidentally do is instead of calling it str, another thing we might accidentally do, I can see, is that we might accidentally use str for string because we use that abbreviation a lot. So text is more specific than string. So, sorry, we might use txt. So all these are str. So we want to take everywhere it says str, we're going to do txt. So remember, we have decided that we don't really like txt for text. That we're going to keep it as text for text, even though that could be mistaken for texture. But I don't think we're ever going to have a texture input-output. I think that we'll have text strings input and output. I don't really ever think we'll have a texture input and output. If we ever do, we'll get to that when we get to it. But right now, we just want some very terse variables with exact definitions, right? So let's... Right, so now we have definitions for the text as well. So let's put that over here on this screen, and then look at this code again, and say, okay, so this is text output, and you have text output, that all looks good. So now we just gotta like go through here and make sure that this code actually can compile, because we got like a lot of stuff going on, and I'm sure that I've screwed up a lot of stuff. I don't know what I've screwed up, but I've been all over the place in terms of doing this. So, well, JMP is not... Oh, we were going to say that now that we have like command name like this, I was thinking that we could call this CMD or CMD func, right? Command name here, and then don't we have like command func here? Yeah, command func and command enum. So anywhere we see, so let's refactor these names. So if we see jump, we're going to call it CMD func, right? Because it's right? Oh, I see. So command func is a specific command function. And this is like a this is a jump table of functions, right? So you have a command function. So this, we call it like, it's a command jump table, right? And this enumeration here is still a command enumeration, right? So, command enumeration, right? And so anywhere we see enumeration, we're just going to write to command enumeration. So we're going to change that. This func here the func here is actually going to be just cmd pointer this is an array of them, and this is just one. All right. So we're just going to keep the initialization so we can kind of see what that is a little bit better. Though we didn't do it there, so cmd enumeration. This is command enumeration. These are all command jump table. And this is function, right? So cmd jump, right? So that means that all of these things that are JMP here can be this command func, right? Or no, this is the jump table. So let's just take this JMP here. And anywhere we're using jump, we're going to just define... We're going to define JMP as this command jump table here, right? And then down here we'll undef that. Right? That's just the jump table. And this function here is going to be the command function, so we'll change that as well. Then we got to indent this a bit. So we got the command function. We want to make sure that the command function is equal to the jump table lookup for that. And then this enumeration thing, remember, enumeration now is going to be cmd enum, right? So cmd enum. So the enumeration needs to be between 1 and 4 inclusive. And we just want to make sure that that works out correctly. So now the question is, do we have command enum? Do we have command whatever? So we don't have command enumeration. Do we have command func in our shortcuts? We don't have the enumeration. We don't have the func. Do we have command jump table in our stuff? I don't think we have that either. So let's look for that. Okay. So we need to note that as well in here. So let's just do cmd enum. cmd func, which is the actual function. And cmd jump, which is the jump table itself. cmd jump. So any of these, if we type them, we're just going to say that, hey, you did the correct thing. You typed out what these actually were. Congratulations. Let's make sure that these are only in these two spots. So if we look for find next, we can only go between these two spots, right? And then for finding this, it's only in these two spots as well. This, only in these two spots. So let's add all of these synonyms for these functions here. So if we type anything similar, so cmd enum or cmd enum or cmd enu, cmd, or actually let's say okay, cmd func. So if we do cmd dash func, cmd dash underscore func, then we're going to correct that as well. cmd func, right? It's just back to our 7 letters, right? And then cmd jump, cmd jump, cmd jump, and if we do that, cmd jump. Sorry, jump. Okay, now if we do something similar, so if we do So let's do more of this. So if we do cmd enu, cmd use 7-letter version. So use 7-letter version, and we're going to do cmd enum, right? So cmd enum. And that is kind of a mess, this variable name. Like, you look at it, you're like, what the heck is that, right? But the idea is we just want one token. And we want to know kind of what that means, right? So cmd enu, and we want to look for the same thing for cmd fun, cmd fun, cmd fun, right? So if we have that, once again, we want to say use the 7-letter version, and the 7-letter version of this is cmd funk, right? cmd funk. And also, the last thing is for the cmd jump. So cmd jump for jump, cmd jump, cmd jump. If we get that, if we get any of those, we also want to say, hey, use this 7-letter version, which is called cmd jump, and that's the cmd jump table, right? Now, if we use something like cmd tab, cmd tab, cmd tab, you want command jump table. Alright, so if we accidentally do something like that, we also want to correct it, because I can feel myself writing something like this, or tab of cmd, table of commands, tab cmd, tab cmd. If array of functions, you probably want cmd jump, right? Because it's a jump table of commands, right? So just in case we accidentally get that wrong, we can do that, and we can say command jump table, command function jump table, jump table of commands, command table, function jump table, or even function table. If it's a function table, so if it's a function table, we want to call it cmd jump, right? Because it's a jump table of functions, right? Now I saw that function jump table was giving us something already. Oh, no, not that. Something we did earlier. Function jump table, that's good. Jump table, it's just jump table that was leading to something bad, right? Jump table? I don't even know what we did wrong. Jump table. If we look for jump table in our shortcuts, do we already have something that's called jump table, or can we insert this down here? Nope, we don't have a jump table anywhere, so we're going to just call this jump table. Right there. And we just have some things for, you know, for this. If we look for something similar, we can find that, oh, we want to use command jump, right? So command enumeration, command func, and all these. I'm going to call this B6 for bad spelling 6 characters. It doesn't really matter, but I want to keep track of what I'm doing here, and I'm kind of losing track. B6, bad spelling 6 character. Right. So we want to take all this stuff that starts with command whatever the heck, and we want to invert it, right? So we want to make the backwards versions of all of this. So And let's just say that B7V means, and then we can make a note of what I mean by B7, or B7V. Backwards, and use 7-letter version. Right, so instead of having this big message in each one of these shortcuts and using up even more RAM, we just want to be kind of terse about this and say that all these things are backwards and whatnot. So now we're going to just take all of this and we're going to flip everything around, right? So we're going to take these parts and we're just going to flip them, right? And to flip these, this is going to be a little bit more difficult because we have to go like this. We got to go, we got to take this, right? We got to take them like this, and then we have to insert the underscore in the middle, right? So now we flip that. Let's flip the last thing. So now we got to flip these as well. So let's flip, and flip. And then let's put the dashes in the middle. So these are both backwards. These are backwards. And we want you to use the 7-letter version, right? So that's what this is all about. So we have quite a lot of things for command enumeration, command func, and command jump. We are missing something though, aren't we? We're missing the definitions, aren't we? So let's make a note of that at the top here. So let's just say, you know, cmd enum means, cmd enum means. So any of these is good enough for me. And I'm getting really sick of this, so if we could just get this over with, it'd be nice. Command enumeration. Right? And we're going to have a similar thing for all of these. So command enumeration, command function, and command jump. So we have the function and the jump table. So let's highlight the... hold on. Enum, function in the middle. Screwed that up. Okay, so enumeration, this one's going to be function, and this one's going to be jump. It's going to be a jump table, right? And then we need to make sure that all these are correct. So any of these where we say this is going to be jump, cmd enum, that's going to be changed to jump. These are all going to be changed to func. So this is func, cmd func, enum. So let's see, we got enums, we got funcs, and we got jumps, right? So now we have the definitions for all these in our shortcuts. So, oh hey, so I see somebody kind of showed up again. Like, I can't see my viewer list, so I don't know who's watching. So every time I see kind of someone pop in, I just want to show off the demos. I'm working on a fractal auto-tiling engine. That's the overall goal. Those are my technical demos of all the things that I'm going to put into this engine. And right now we're working on a thing that's going to take a PNG file and turn it into a hex dump string. And alternatively, we want to do the inverse, take a hex dump string and turn it into a PNG file. And I just got done kind of like defining all of the variable names I want to use in this code. Just because I want to have I have very terse variable names, so I want to make sure that I have like an index, like a master index of all of my variable names, so I know exactly what a variable name, I want to know exactly what a variable name means by looking at it, and I want only one variable name for a specific concept in the code base. So, for example, command name, file path in, file path out, text output. Now the reason why I'm very terse about my variable names is because we don't want something like this. We don't want somewhere to have a variable like this, text output, and then somewhere else we have a variable called like txt out, and then maybe txt output, and then maybe we have string output, but the string output is actually still a text file. It's just the text file data. All right, then maybe somewhere else in the code we have like txt out like that, right? Or we have a text string output, right? Or maybe do some camel case and do text string output. And so you want to look through the code base and you want to find where you're outputting a text string for like file contents, but because you've used all these different names, you have to search for this, you got to search for this, you got to search for this, and this, and this, and this. You got to search for all these different things. And so it makes it a lot harder to look through your code because you can't just in one fell swoop search for one variable. You have to search for all 7 of these, right? So if we meticulously make an index of all our variable names and say, you know what, anytime it's a text output string, it's going to be called text out, then you can just search for this in your code base. You can find everywhere you're doing that rather than have like it fractionated like that. So now we're gonna, let's close this, and I'm gonna go back to my variable definitions here in my shortcut file here, and I'm just gonna look for text output just in case I don't have a variable for that. So we have something like that, but do we have text output? Yeah, we have text output. That's good. So yeah, we have all these nice little synonyms, right? So all this file does is creates shortcuts so that we converge onto the variable names that we have decided on, right? So any of these variations right up here will converge into this variable when I use my shortcut. So when I'm like, hey, I need a variable for text output, I can use these shortcuts. So I can make a shortcut called, hey, I need a variable for text output, right? I could make something like that, and then I could say, well, that's going to be text out, right? But yeah, we can just make tons of shortcuts, synonyms, and all that stuff, and we can use that to reduce the amount of mental search space in our code when we're creating function names. So I have no clue if this code is going to work yet. We have not actually written any of the parsing code yet. All we've done is kind of made the basic function that is going to decide what function to run, right? Like all this code is just command line helper function to figure out which function to run, and this private function, where is it referenced? It's referenced down here, that's fine. Let's also make some dividers here. Dash line I1. So we want a little dash divider between our different functions. And same thing here. So these functions, we don't know what the actual body of these is going to look like yet. We got to figure that out. And I'm going to change this to public command line functions. Just instead of calling it command line functions, I'm going to call it public command line functions because I feel like we might have some other this is the actual command line functions, and these are public command line functions, and then we might have some helper functions. I don't know, but we could. Alright, let's just give this a run and see what we're missing, because I know we're missing something, because we've been, like, all over the place here. But let's just give it a run and see what needs to be done. Oh, well, also, we need a build script here, so let's add a new file here. So, see, we haven't even ever ran this before yet, and we added way too much code. But, yeah, so PHEXDUM.sh, and in this file, we're just going to say, like, HKMF C11 Lite, HKMF Mini. Okay, so now we got, like, a little build script. We can get rid of this line. We don't use that anymore. It won't affect anything, but I'm just going to get rid of that. And the file we want to compile is going to be called phexdum.c11, right, for PNG hex dump C11. And that's a decent build file. That'll work. Let's give this a run and see what kind of mistakes we made, and then just fix everything. Okay, so some of the mistakes are just from not including the correct files. So, AAC 2020 library includes. So, let's include printf, include exit. I don't know where exit is, but it's somewhere, stdlib. And include u32, or include integer type defs. So I know that's what this shortcut should be called. I don't have it, so I'm going to make a note of that and say, what about include integer types? Include integer types. Nope. So I'll make a note of this. Include int type defs. How about that? No deal there? How about we say include I32? I might have that. Nope. So all this is wrong. Include bit wide integers. Yeah, I don't have a shortcut for that. So here's what we're going to do. We're just going to hack it. We're just going to say define I32, and the comment actually includes what we want, right? So we're going to add that to our shortcuts. So over here, next time we want to like have these, we'll have them, right? So we want to hashtag include stdint. However, that won't go over very well in our shortcuts. So what we have to do is we got to go file new, and I'm going to put this over here. I don't know where it's going to open. SC files, CXX, snips. Okay. Okay, so now we have a little snippet in a file called include stdint, and we're gonna take that and we're gonna put it over here, and we're gonna paste the file contents. We're gonna paste the file contents, and it's gonna dump this out in there, and we're gonna use that so that next time we do this, it's gonna be faster. So let's figure out what to do next. stdint.h, right? And we can make a note of this. This is, you know, u32, i32, u8, etc., right? That's what these ones are for. So now we know kind of like what all that is for. And let's give that a run now. Looks like we have some more spam. Okay. So this is in, where is this in? This is in the data file. So let's go in the data file and clean up some of our mistakes. So right here, the first entry cannot have a lax comma in front of it, right? Because it's the first entry, right? So we can go into here and just make absolutely sure we do that correctly. And now let's just give that another shot. Let's give that another run, and let's keep on fixing stuff. And then once we get this fixed, once we get this compiling, we're going to do some more push-ups. We haven't done any today. Okay. So as we were trying to figure out our data, we may have made some screw up. We got conflicting types for whatever this is. So let's look at this for a quick second. So right here we have char pointer pointer, and this is char pointer. It's char pointer and then this, so that should actually be a char pointer pointer, right? Extern char pointer pointer. Oh, you know what it is? It's not the types, even though that's kind of like valid the way we did it. What it wants to see, and I'm fine with doing it that way. It wants to see this. It wants to see. It wants to see. I don't even know how to do this. It wants to see this. I think it wants to see that. Let's try that. I did a lot of weird things that I don't usually do in this code. Yeah, I don't know. Is that not correct? Char... Oh. So these things are... Oh, I see. We have to use it. We gotta do it. We gotta do it. Yeah, this kind of sucks, but the C convention of how we need to do things is like this, I think. We're gonna have to fix this one, but I want to make sure that I'm doing it correctly for these four first before I go look around and try to fix the other ones. So sin is incorrect. So this sin, and that's because we want a double pointer and then a 5 in the middle. And we can do that. And that's a little weird. I don't know where we want to put this. I guess it's different enough where maybe we don't want to line it up like that. AKA so these are actually char pointer types as far as I'm concerned. And this is char triple pointer types, right? As far as I'm concerned. I know that we can't write it like that, but that's, as far as I'm concerned, that's actually what we have in here. And so I'm going to make a note of that. Also, let's put an S like this so that we can write it as types, where it's like there may be more than one. Okay, let's give that a run. And I know we're going to just encounter like a lot of trouble in terms of the typecasting because I got a little crazy. So this looks like we got it wrong. So this invalid command thing, is that not how we wrote it? Oh, yeah. So all these are no longer called table, because we have a lot of different tables of a lot of different kinds. So we're just calling it syn for synonym. A node type name char in our function file, line 25. So let's just define that, right? So let's define it right here. Or do we want to just keep on adding it on? I don't know. Does the exact order really matter? I don't really think it does. So let's just define CHR right here. Right, so it's just a const char. And we may want to change our mind on the const aspect of that, but for now, we just have const char, right? And then at the end of the public command line functions, we can undef CHR, right? So down here, undef, and I see a big problem here. It's just undef without any tokens at all. Like, what the heck is that? Let's take this for a second. Let's paste this over here. Let's actually fix this nonsense. I don't know how I screwed that up. Now, do we want to do it like that, or did we like doing it like this, where we had like a, something like this? I don't know. I don't know what I like. Keep on changing my mind on that a bit. Let's not worry about it too much. But yeah, we just want to get this basic thing working. And 148, looks like we have some bracket balancing issues. So we're going through here, and then we're saying if 0 equals this comparison. And this comparison, we need an extra thing right here, right? Sure. And also, I think strcmp actually needs to be included. I don't think it's going to know. Okay, so I have a table of enumerations, and we use that to get a check enumeration, right? So this table of enumerations here. So let's just say I32 chk enum. And is this check used anywhere, or is that what that was supposed to be? I think we just changed that. Yeah, so this is actually... I don't know why this says char pointer pointer though, because that's wrong. Unless we have a, or we're checking something else. Are we checking a character? I don't know. It's left over from something, I think. Let's just get rid of it. Check enumeration. Right. So that's all that is. we could go over here and say, hey, well, if that's a thing, we might as well make that a variable as well, right? So chkenum, and if we do that, we're going to say chkenum, and then say, hey, you typed that correctly, awesome. And chkenum like this. Any of these are close enough to where we'll just correct it. And if we do chkenu like that, then we want to make it the 7-letter version, right? So chkenu, so use 7-letter version, chkenum. And if we do enu chk, or enu chk, backwards, and use 7-letter version. Right, so if we do chkenum, right, so we want to use the 7-letter version rather than the 6-letter version with the underscore in between. Also, what does it mean? And if we type this, we want a little definition. Check enumeration value, right? It's a check value. It's just to make sure, it's a redundancy to be like, hey, did we get that correct, right? Okay. So now, the next thing you want to do is give it a few more runs. Let's see if we can get it working. So once again, we have not been writing our string comparisons correctly. So on 172, same problem that we made earlier. When we do the string comparison, right, we need one more of these, right? So right over here, one more of these. And if we can't get a string comparison to either cmd-enum or cmd-func, then we didn't request the right data to be returned, right? So we realized that we were doing a whole bunch of work in here. And so we made this function a function that could give us the enumeration or the command, right? And then we made a wrapper where we can convert the command name to the enumeration, or we can convert the command name to the function. Okay. So for this to work, to get this command enumeration, well, first of all, we have a problem here. Command enumeration and command func, I don't see them declared. We did not declare them. So first of all, this is an int32. This right here is a command pointer, command func, and command func is fine. Ooh, oh no. We can't mix. We're gonna get a problem where we're mixing function pointers and data pointers. Well, we'll find out when we get to that. But this right here, we need to convert it to a int64. So before it's an int32, we gotta widen it to the size of a pointer, and we're on int64. Now this is gonna hurt us pretty bad if widening this type by converting it to int64 first would really hurt us if we end up on like a 128-bit system in the far future. So let's do oh, actually, no. Oh, actually, this is fine. This is fine. Never mind. This is not the generic part. This is not the generic part. This is the wrong part. Command enumeration, command func, that's fine. It's where we're using this up here. We're doing our crazy duck typing stuff and returning the data. This enumeration here for the return data, it's this enumeration before we can turn it into a void pointer. We got to cast a void pointer, and this also needs to be cast a void pointer, and this might also, these both might fail us, or actually, you'll see what I mean. Of different size, got it. So, to get this to work, so if you want this kind of backwards compatible, I don't know what we're going to do. I guess define int that's the size of a pointer. I don't know what that is, though. So int p, so it's like an int pointer type, so int ptr typ. Nope. Int pointer type. Int pointer type def. We need an int pointer type def. I don't know what it's going to be. Int ptr. We'll have to figure that out. Int pointer. And we want it in C. Yeah, that's what we want, but we want... Okay. So... we want to find that type in stdint. So, edit stdint. Okay, so let's look at stdint really quick and see if we can find what we're looking for in the stdint header. So int whatever the hex, okay. Exact with integer types, that's not what we want. Unless we have something that's a certain integer for a pointer. Doesn't look like it. Minimum width. Nope, that's not what we want. Fastest minimum width integer types. Greatest width. Greatest width would be the integer pointer type, I think. Because the max width of an integer is going to be the max width of an integer is going to be our pointer size. So these look like the ones we want. Int max or uint max. I'm going to go with that. So int max or uint max. So let's copy that and say use Alright, so we want to use those. Okay. So now let's go back to the code for a second and look at where we're kind of... So int pointer, what we're going to do is say that int pointer is int max t and we'll say that this is the so we put int pointer directly beneath int32. So right here, directly under that, we want an int pointer, right? And so when we use this int pointer type, we're going to use it as a signed integer. That may not always be the case. So let's just go define IP, define int pointer. Define UP. How about define UP? Define unsigned int pointer. Right, if we do this, then we want the same kind of thing, but instead of int max, we're going to use uint max type. So we got int max type, and then we got uint max type. Now what do we do? That's wrong. Uint max, not unit max. And because I made that mistake, let's put that here. Unit max. Unit max. And unit max to... You mean uint max t, not... Right, so... This, not this, that was a mistake, so typo. Now these are not going to work yet because we can't have hashtags in our shortcuts, so we're going to have to... We're going to have to... put these in their own file in order for them to work properly. So let's copy and paste these into int pointer. The unsigned int pointer is going to be UP, right? Uint max, yeah. Okay, so let's take these, put them in their own file for next time. Close stdint. We don't even know if this works yet, so we're taking a big bet to say, you know, I looked at this, I'm pretty sure. So in define, we're going to say, we're going to have UP, and we're going to say, this one is actually UP, say this is IP, so int pointer. So we got int pointer, and then we got unsigned int pointer. The unsigned int pointer is this define right here, so copy that. Put that in unsigned int pointer. That looks good to me. Let's add another thing there. That way they're still kind of aligned. That's nice. Okay. Copy both of those and paste them in their correct location. So one is going to be IP, the other one's going to be UP. So this is UP. This one here needs to be IP for int pointer. So int pointer, uint pointer. While we're here, we might as well create some defines and undefines for that. So let's go and create undef UP or undef and we want to undef the IP as well, so the unsigned int pointer as well as the signed int pointer. So signed int pointer and undef int pointer, right? So any of these undefs, and we'll just create new files for that. So undef space IP, and we should have like a CXX shortcuts snippets for undefs. So if we go into undefs folder, we have undefs, and we'll say, hey, this is going to be called IP._. For undef int pointer, and then we're going to create another one for undefining UP for unsigned integer pointer. And we'll call this UP. Okay, so we got IP and UP. Go over here. We'll paste both of these here. We'll shorten these. And then this was UP. This needs to be IP. UP and IP. Okay, cool. So now we have type defs for pointer types, or integers that are the bit width of a pointer in our code. And the reason why we need that is so that we can do our casting correctly. So we can't just cast immediately to void pointer for this enumeration value. Before we cast to this enumeration value, we have to use the int pointer bit width and cast it that way. So we're going to expand the number of bits it has, right? We want to do this upcast to expand the number of bits it has before we can cast it to a void pointer. Now for this, I'm still kind of scared that this won't work because of the needing to use a function pointer type, so we'll get to that when we get to that. Which is probably right about now if we did this right. Yep. So we can't do a function pointer to object pointer type. So that creates a little bit of a problem for this function, because it returns this void pointer. So we need a void pointer that we could use a union. I don't really want to get that fancy. So what we need is a void function pointer, right? Okay, so let's go into the data and go into our type defs. So we have some type defs for function pointer types, and we're going to say we're going to get rid of this, because I like the way we did it earlier. Um, so any function, right? So we're gonna have, this is a, like, so, we need a void function pointer for this, right? And what we're hoping is that we can do this. We're hoping we can do this, like, void function, right? Use VF for void function. What we're hoping here is that if we do VF pointer, so pointer to a void function, and then instead of using void pointer, we're hoping that we can just do VF pointer, right? And sometimes it's we're taking a enumeration and converting it to that, right? It's not the correct thing. We might have to, if we can't get this to work, we might have to use a union. But let's see if we can get this, because it says we can't take a cast a function pointer to a void pointer, like a function pointer to a data pointer, but I don't know if can we do it the other way around, or let's just see what we can get away with here. So now this command enumeration, we need a int32 cast of this, and this right here is going to get a command pointer cast, right? So a command pointer cast, but it's already returning a void command pointer, and so we're going to take that void command pointer. We're going to take a function pointer and convert it to data, right? So instead of taking a data pointer and converting it to a function, which is not allowed, we're going to take a function pointer and convert it to data and see if that is allowed, or if we're still kind of up a creek without a paddle. So let's give that a run and see if we can get away with that, or if it doesn't like us. I see. So when we do this, void function pointer is going to be 64 bits, and we're downcasting it. So if we want to downcast like that, we can, but we're going to have to do int pointer. We're going to have to upcast first, and then once we've upcasted to an integer pointer bit width, then I believe we can downcast and we'll be fine. Unless we lose track of what we're doing. So here's our int pointer. Here's where we're... Oh, crap. So I put that on the wrong thing. That's what's going on here. So this is already out of hand. We got way too many parentheses. I'm gonna be ridiculous here. I'm gonna do a command point. I'm gonna cast it to command pointer twice. And the reason I'm gonna cast a command pointer twice like this, which is completely useless, is so that the structure of both these functions is identical, right? So we can make a note of that, right? So actually, let's just do hashtag y cmd cmd cast. And then let's make some room. Let's make a note of that in our notes. So in our hashtag documentation. Oh, this is not hashtag documentation. Let's just do @videoid 120. And the time is 4 hours, 56 minutes, and 7 seconds. And it is kind of depressing that we haven't really gotten that far. We've just kind of like figured out what we want to do. Yeah, we have not gotten that far. That sucks, but oh well. So anyways, to iterate for the screen why we are doing what we're doing right here, why we have this command, we only are doing this so that it is analogous to this line, right? Because we got 2 casts here, so I just wanted to have 2 casts here so that when we look at this code, it looks analogous, right? So that when we compare this code and this code, it's visually similar. So you can visually link the code because the patterns exactly match. So I only did this command cast so that we could pattern match and kind of see the analogy between these 2 casts here. Okay, so let's give that a run. Integer from pointer without a cast. And this is on line 37 of the C11 file, so I think we made it out of there. Awesome. I mean, we still have problems, but we made it out of one place. So let's look over here. CMD enum. Now, it's kind of obvious from the name. The enumeration is a integer value. The jump table is an array of pointers to commands. And we're going to zero initialize that table. And it is stack allocated. The function, this is a function that's going to be extracted from the jump table, or another jump table with the exact same data. And that is correct. So, okay. Let's give that a run. And once we get this compiling, right? Once we get this compiling, then we're going to do some push-ups. So this needs so 0 never is false, or if this is true, or if this is true. And we are in the C11 file again. Let's say we got some bracket balancing. 6648 CMD. Oh, yeah, this is called hey, no, that's not what it is. What the heck is it? Oh, I see. It's called this is called we are parenthesis happy is what that's called. Asserts, we have to include the asserts header. That's pretty long. Let's just call it define and debug to turn off. Let's not get too verbose about that. And I don't know, let's just... Okay, so now I think we're pretty close to just getting this basic shell to work. So anytime if someone stops in, I just want to drop my demos in there. My technical demos. I'm just trying to get the basic... So I haven't done any of the raw logic that needs to be done yet. We're still working on the interpretation of the command line. And so all of the functions that we want to do, we haven't written any of that yet. So if we go up, if you want to see what we're going to eventually write, like once we get into the actual interesting stuff, these functions are all stubbed in, right? So we have a command where we're going to take a PNG file, we're going to convert it to C99 text, right? So it's going to be an array literal of unsigned 32-bit integers that describes the bytes within the PNG file. Then we're going to do the exact opposite, right? So you take a file that has C99 code in it that describes an array literal of unit 32s, and it'll reconstitute it into a PNG file and save that to disk. Then we also have something very similar, PNG file to naked text. So naked text is going to be something like this, like 0x So naked text will be something like this. So this will be naked text. And then when we're talking about C99 text, we're talking about like something like U32 table output, some number in here. We don't know what the number is, right? So if the output is this is called C99 text. This is the C99 text variable. So we could call this C99 text if we want to. Well, it's not really C99 text here. This is C99 pixel array. But the actual file itself that contains this is called C99 text. Now, if this is all that's in the file, then this is called naked text, right? So now the reason why we have these two is because sometimes if we want to create some type of build system, we might want to do something like this for our build system. U32 C99 pixel array, and we might want to do this. And then in here, we're going to say, like, include the naked text dot txt, right? So if we want a build system for taking all of the assets in our assets folder and putting it into arrays that are encoded into the binary, then we might want to do something like this to get that build system working. So then what we're going to do is we're going to procedurally generate this file here, and this file will contain just this kind of stuff. You might be one of the greatest... I don't know about that. I think... I think I'm just crazy as hell, right? Because I think I'm just very meticulous. I think that, like, I'm going very... The way I'm writing this code, I'm going very, very slow. Like, it is 5 hours in, and I haven't even written any of the functions I want to write. Like, I want to write this function, and this function, and this function, and I've been spending a lot of time figuring out the exact variable names for everything, and the interface for this command line utility. Like, I don't know if you've seen this yet, but let's go over here for a second. Like, I've been just making all these shortcuts for all the variable names. So, like this is... Here, let me get rid of the coloring for a second. So, we have a variable name called cmd jump. It's going to be a jump table of commands, right? Or a jump table of functions. So, we also have a variable called cmd enum, which is just the enumeration that corresponds to a certain command. We got this thing called cmd func, which is a function taken out of cmd jump. And so you see, this is just ridiculous. And all these variables that I started defining, where did I start today? So 5 hours ago, voxel engine. So 5 hours ago, this is where I started. And so like, I have a lot of cruft here, but all of this stuff I did 5 hours in the last 5 hours, right? It's all this like crazy, like, stuff where I'm just creating shortcuts for my variable names and creating definitions for my variable names. But I know I've gone over this before, but I'm gonna explain. So you see, like, if I type any one of these things here, it gives us me this variable, right? So check enum, if this is going to be the variable for check enum, and if I type any of these, it gives me this out, right? So I want to converge all my different all the different ways in which I could write a variable, I want them to converge on one single variable name. And I don't know if you've seen me already go over this or not, but the reason for that is, let's say we have, I have a variable for text output, right? So the actual string that's going to be saved to a file, it's going to be called text output. Now let's say somewhere in your code you have a variable called text output like that, and then somewhere else you have a variable called text output, right? Or you have text string output, and then maybe somewhere else you have like string text output, and maybe somewhere else you have like text to save to file, right? Maybe you want to do like a really clean code descriptive variable name thing, right? Well, the problem with all this is if I want to find all of the different places in my code base. Oh, yeah, so I made a shortcut, I made my own script in AutoHotkey for this. So how I'm doing all of this craziness is I take the... So first of all, you see how there's like all these synonyms. So the synonyms are between bars, right? So these are shortcut synonyms. So any of these shortcuts will resolve to this file, and then we paste the file content. So the way I'm loading all these shortcuts and getting that to work is this entire file. Like this file has like over 30,000 shortcuts, right? So this is like huge file, right? And what we do is we go through the whole file and we collect all of the shortcuts. Once we have all the shortcuts, we sort them using a hash sort. Is it a hash sort? Hold on. It's a tree sort, but I use it's a heap sort. I use a heap sort. So it's like a tree sort, except you are sorting an array rather than a list of nodes, right? So a tree sort is where you have a whole bunch of nodes in a tree and you sort it, and it's a very efficient sort. A heap sort is the same thing, but it's done on an array. But the array itself is encoding a tree. So a heap sort is just a tree sort, but the underlying data structure is different. Or you could think of a heap sort as it's a tree sort, but it's kind of like on a contiguous strip of memory rather than a sparse kind of linked list kind of tree kind of thing, if that makes sense. So right, I sort all of these shortcuts, and once these shortcuts are sorted, then we can do a binary search to figure out what shortcut I've typed. So let's say like I typed like pizza is the best, right? If we have all of our data alphabetically sorted, or more specifically lexicographically sorted, then we can search for this specific phrase by just going through our sorted list of terms. So it's almost like going through a dictionary, right? So if we wanted to find pizza is the best in a dictionary, right, we'd open up the middle of the dictionary and we'd say, hey, is this word pizza is the best? Oh, it's not. Okay, well, everything's sorted in alphabetical order now, so we know it's either in the next half of the dictionary or the previous half of the dictionary, right? So we can, if it's in the first half of the dictionary, we'll cut the dictionary in half, and we'll now have a new smaller dictionary that's half the size of the previous. And we'll do the same thing again. Now with our smaller dictionary, we'll open up it to the middle of the middle, right? We'll look at the middle page within that dictionary and say, are we at pizza is the best? And if we're not, we're going to say, well, is the word further in the dictionary, or is it like is it further forward or is it further back? And if it's further back, either way, if it's further back or further forward, we're going to cut the dictionary in half, and then we're going to take either the lower half or the upper half, right? And we're going to keep on doing that until we find what we're looking for. That's called a binary search. It's kind of weird to call it a binary search because when people say binary, I think ones and zeros. But think about this. So if you... Yeah, it's a great algorithm. Yeah, all you got to do, like, sorting your data, it's all about just sorting your data, right? You can do a lot of stuff. Like, when I was first doing programming, I did not understand, like, what's people's fetish with like sorting data? Like, why do programmers care so much about sorting data, right? And that's the reason. So think about this, like, right? So you get the idea of like exponential growth, like 2, 4, 8, 16, 16, and then we got like 32, 32, dot, 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 right, explodes out of control really fast. But the opposite is also true. Large numbers converge to 1 really fast, right? So we can take that exponential aspect, that exponential explosion aspect, right? And we're just turning it on its head, right? We're just going backwards the other way, right? Yeah, but a binary sort is just, yeah, it's really powerful because it does take about 5 minutes to sort my shortcuts because of how much data is in it. But once it's sorted, once that data is sorted, like I can find that stuff fast because because I can just binary search through it. Now, I will say that I need to get a new computer or more RAM pretty soon because, right, with the big list of like, 30,000 shortcuts, I'm starting to take up a lot of RAM. Like, I don't use a fancy IDE, but I have like one gigantic shortcut script that takes up a lot of memory in terms of RAM. And I'll have to figure that out when I get to it. So far, things haven't collapsed on me yet, but, I'm adding more and more every day. I never subtract from it, I only add to it. So, it's going to get out of hand eventually. Because my goal is to eventually get to, like, 1 million shortcuts. Because that would be, I think that would just be pretty cool to say, right? Like, you could say to somebody, I have been programming for so long that I have 1 million different shortcuts. And when I say 1 million shortcuts, I don't mean... So when I say 1 million shortcuts, I don't mean this is 1, this is 2, this is 3, this is 4, right? These are all synonyms for this shortcut. So I mean 1 million of these kind of shortcuts, right? So here's a shortcut, right? I want like 1 million of these. And right now I'm at like, I know I'm over 30,000, but I don't know, I have no clue where I am right now. I need to make like a add code to actually tell me how many shortcuts I have. But for now, I don't know, because it doesn't add to my productivity to know that. It's just like bragging rights thing, right? I could be like, look how cool I am, right? And so I don't really care too much, but like eventually, like maybe when I'm like bored or something, or feel like taking a little break on what I'm working on, then I'll kind of do that. Okay, so let's get this working here. We are on C11, and once I get this compiling, I'm going to go take a break and do push-ups, because it's been 5 hours and I haven't done any push-ups, and I need to get 120 done for today, and that's like push-ups, crunches, a whole bunch of stuff. I'm trying to just like add like 10 more per day every week until I start actually losing weight, which doesn't look like it's happening. Yeah, you'll think you'll make it in terms of push-ups or in terms of shortcuts. Hold on. So let's look at line 72 here. 72. So there's this user like RBS. I forgot. Yeah, there's this user called RBSRBS. I don't know if I'm pronouncing his name correctly, but he, yeah, push-ups are good as well, yeah. So a lot of times with function pointers, I used to do function pointers, where are we? So I used to do function pointers where I'd put the pointer type in here. So I'd put it like right here. But I actually like doing my function pointer types this way now that I've seen how other people do it. Yeah, I think probably the cardio is probably what I need. TDEE. What's yeah, I do 100 trampoline jumps a day. So like every time I get up to 100 push-ups, I go jump on the trampoline for 100 jumps. And it's usually freezing outside, so I have to like brush the snow off the trampoline and just jump for 100 times. But this summer I didn't really jump on the trampoline much, so I'm like, you know what? No more excuses. We're jumping on the trampoline every day. I don't care if it's freezing. We're getting out there and we're jumping on it. Okay, air macro. So air, where are you? 96? So in this file, we need an air macro. We have an air macro somewhere in this file. Let's look for the air macro. And match case. So right here, we're going to have to create an air macro, and the air macro is going to have to be for the C11 file, which is going to be a little bit different than the way I usually do it. And I am going to read your comment right after I finish this thought. I don't know what we're going to call this. AAC 2020, PNG hex dump, C11 file halt. Yeah, which is kind of a, this is kind of a ridiculous name, but we don't want it to collide with the other air function that we usually create. So we're just going to do kind of a different air function than we usually do. And, oh, and so I really was thinking I would have more to show by now, but I just need to get better data into the renderer before you can see more, and that's kind of why I'm kind of like off on a little tangent here. And I am going to read your comment. I just got to finish this one thought here. So let's do 489 paste, which should be our halt function. And then we're going to take this name here, paste that in there, and then fatal error from C11 file. I don't really care. Actually, FileAccess C11. Okay, we just want a little message that kind of tells us, okay, it's from the C11 file for this namespace. I think that's good enough. And then we can't be stupid like that because really we have to be under 255, or 255 or an under, because if this is executed from bash, there's kind of like a size limit for the integer that's returned. And I am going to get to your comment. I swear I'm going to get to your comment. I just gotta finish up this thought here. So halt is typically the first function. Okay, that looks good. Okay, it shows your BMI and all other stuff, like how much calorie you should take. Yeah. So I think I should figure out stuff like that. I think my metabolism is just getting slower because I'm older. What am I? I'm like 35 or 36. I don't keep a very strict count of how old I am because I'm like, it's depressing. So I'm like, you know what? 21 I could drink legally, and I don't plan on being president. So I didn't you know, wait till I was 35 to be like, yay, I'm 35, now I can run for president. I'm just like 21. After 21, just stop counting because there's nothing good. You're just getting older. So yeah. But what I will do, I think one way to not be too depressed about getting older is, like, as you're working on a code base, like I put, like this code base is called AAC 2020, and 2020 stands for when I made the code base. And the idea there is, if I work on this for like a few years, and I see, oh, it's like, when it's 2030, I'm going to be depressed because I'm 40-something, but at least when I look at my code base, I'll be like, hey, it's 2030, and this code base, the namespace says 2020, so if I'm working on this in 2030, then I know that, oh, this code base has been around for 10 years, and that'll give me something to be, like, not depressed about, you know what I mean? I know too much, and I can teach you it as well. Yeah, like, I don't know much about, like I used to, like it's been a long time since I took biology class. Like, one of the things I do is, so I know a few very simple things that I try to adhere to. One, protein. So I know that, one thing I adhere to is that um, yeah. So I mean, yeah, health stuff gets like really complicated. Like it gets ridiculously complicated, right? Like health is like when you talk about like working out and eating, it's almost like an it's the complexity level of like a RPG card game, except it's like your body. And yeah, it's like crazy. That's crazy stuff. And you know, it's important though, right? Like if you don't take care of your body, your mind is going to lose sharpness, right? So if you just sit and program all the time and you don't get any exercise, then you're going to slowly get mentally duller and duller and duller. So the analogy I also like to use is like cutting tomatoes. Like you could take your knife and cut tomatoes all day and do that week upon week without ever sharpening your knife, but you're going to get slower and slower and slower. And it's almost going to be like a frog boiling in water. You know, the like frog boiling in water analogy where you slowly heat the water and they don't notice they're getting boiled. Well, you could slowly get mentally duller and duller very slowly and not even realize it because the toll on the maintenance of your body, it takes a while. Yeah, like, yeah, so it's harder. Like, it was easier when I was living by myself because you could just, like, you know, you're the one who does the shopping. If you live by yourself and you're the one who does the shopping, it's really easy to adhere to a diet, right? You just go to the store, you don't buy anything stupid. And the other thing I did when I lived by myself is if I wanted something sugary, I would at least make it like a smoothie or juice or something, right? Yeah, exactly. That's when you reject their offer. Yes. So I have been doing that, but I need to do it more. But then I'm like, feel like I'm wasting food where I'm like, man, I have this stockpile of pork chops, but if I eat the food they're offering right now, then I can keep my stockpile. But I'm like, maybe I need to stop being in that, what do you call it? There's a growth mindset, and then there's like this mindset where you're kind of, a scarcity mindset. Scarcity mindset is what I'm saying. Like, I should probably get out of that scarcity mindset of, man, I really got to hoard my pork chops, so if somebody offers me Taco Bell instead of pork chops, well, then I'm just going to take the Taco Bell so I have that stockpile. I think that that is maybe a bad thing for me to do. Yeah, I definitely need to do that more. Yeah, definitely need to do that more. Yeah, right now I'm snacking on, you probably can hear me crunching on something. I'm snacking on green peas because I need like or green beans, frozen green beans, because I need more fiber in my diet. 15%. Times 9 equals the fat you should take. Okay, well that's something I'm not going to remember, so let's go over here for a second. And okay, just put that in there for future reference. If we can also put a little comment here. It is, oh, it's the second month of the year. It's the first. Okay, put a little note there, so I can come back to that later. Okay. So, let's give this a compile, and we're pretty close to getting this running. We just wrote a whole bunch of code without checking it, which is kind of a thing I do sometimes. Because sometimes if you try to... Yeah, yeah, like, yeah, I still think that, also it's hard to, with a, even if I wanted to go do some tumbling, like, I'm getting older, but I'm not so old that I can't flip around, right? Like, my joints aren't that messed up yet. But right, but unfortunately I can't even go tumble because, like, so tumbling is, so I'm not sure how familiar you are with, like, gymnastics, but tumbling just means the floor, right? So if you say you're going to go tumble, it means you're going to go to the gymnasium, but you're only going to do the floor. And I guess some people would call that tricking, but usually gymnastics is, right, is much more rigid than tricking, right? Because a lot of tricking, when people do tricking, they do a lot of spins on their major axis, right? They do a lot of, like, very arabesque kind of things. Yeah, I am, I think I'm 36. Yeah, try not to think too hard about it, right? Because, yeah, because I'm only getting older. So, I'm either 36 or 35. I was born in 1986. Yeah. Let's try to get this running. Well, if we can get to transhumanism before I die, that'd be cool. Like, upload your brain. I also think that, so let's do a thought experiment. If you could take every thought that you ever thought, and you could write it down in text, would that technically be, would that be a backup of your brain? Like, let's say, if we take all of our thoughts and we put it into, like, a giant code base, isn't that like a partial backup of yourself, if you think about it? So, like, the code base I'm working on, doesn't that kind of count as, like, a partial backup of my brain? And so sometimes I think of that. And also, the other thing I was thinking about was, like, you know, sometimes I worry about, like, okay, if I show everybody what I'm working on, what if somebody copies me and then I don't profit from what I'm working on because somebody beat me to the punch on my own thing? And I was worrying about that, and then I'm like, you know what? Even though I am worried about that, I'm more worried about dying and this never happening, right? Because I think this engine idea is going to be pretty cool, and I'm really worried that if I don't get it out there and I die before it gets done, that would kind of be worse than not making money, if that makes sense. Okay, so we're going to remove these. We changed our mind on that. And let's try to compile here and see what we got. Yeah, I think we will eventually. I think that actually will be a thing. I don't know, so there's, and I'm extrapolating on, there's this hypothesis called the, gas god, and I'll find a shortcut for you, or a URL for this, but there's a hypothesis called the gas god, and it's like, well, what if you had, like, a gas giant, right, like a, kind of like, not a solar system, but a gas giant is just what, like a whole bunch of, like, particles of, like, dust and whatever, like, floating out in space. And what if you had a collection of that, and somehow that collection of gas and dust was so complicated that it became sentient, right? And then this collection of gas and dust out in outer space becomes sentient, and then it decides to, like, probe different planets to, like, inspect them. And so it shoots out, like, cells and then populates different planets with life. So, like, so there's this, like, hypothesis that instead of life, like, evolving from the chemical soup on Earth with the right conditions and, like, lightning storms and stuff, and then chance combinations, well, what if, like, just basically like a solar system or something kind of, like, developed consciousness, created cells, and then shot the cells out in random directions to kind of survey the universe. And I think that's, like, a really crazy idea. And, like, if you took that idea, then you could take, like, the nihilist God is dead. You could take that, like, really literally, right? Because maybe that gas giant eventually kind of, like, eventually died, right? And so this like super consciousness in the galaxy creates these cells, shoots them out, and then eventually dies. And also interesting quote is the first cell never died, right? The first cell of life never died on Earth because we're all related to it. I think that's a very it's obvious when somebody says it, but it's like a riddle where until someone like says that you it's not, that fact isn't apparent to you. But let me see if I can find some quotes for that. So let me see if I can find Gas God for a second. I'm gonna just type Gas God here. So at 1 hour, 31 minutes, and 50 seconds of this video should be the Gas God quote, or Rods from Gods. Yeah, Rods from Gods, yeah. Yeah. And then, Gas God, and the other thing I wanted to find was, the first cell never died. The first cell never died. So, this is at 9 minutes and 15 seconds. So the idea is that when I'm trying to quote things, I want to give you the exact YouTube link and the exact timestamp, because these are like, 3-hour-long videos. I don't want somebody to watch a whole video just to see what I'm talking about. Yeah, but yeah, Rods from Gods. Yeah, so let me put this back on the other monitor and see what else I gotta fix here. So, God, what was IP for? File something output. Oh, file path output. There's the comment right there. So file path output. Let's go look at that for a second and see. Oh, great. Now, I hate when I do that. I do a Control-C on my terminal, and then I kind of lose track of it. So file path output just is not, it's not used right now, right? We have to use it eventually. And where are we using it? So here's our text output. So over here, yeah. So over here, we're just going to have to make a no-op for this right now because of my compiler settings. Because we have not figured out, we haven't added this function yet, right? This is a big to-do right here. But we haven't used this variable yet, so we just need to kind of stub that in to get this compiling. But I think we're pretty close to getting this compiling, and then I'm going to do... Alright, yeah, see you later. Yeah, I'll see you later. I'll be around. I'm going to do this quite often because it's just, today is coffee day, so I'm going to be up for quite a while. So the chances are you could go to sleep and come back and I'll still be doing this. Oh great, linker errors. Alright, let's go find where these are coming from. I know I did some externs. So, command pointer. So, these are not function pointers, and I've kind of written them as if they were. We need a signature that matches kind of like how they're actually declared in the code. And we can see in the code, it's like char pointer, whatever the heck. We actually have to do it like a forward declaration, right? So, first of all, yeah, this is just nonsense. I get why I did it this way, but it's not a function pointer, it's a forward declaration. So we really need something like char pointer. We need to make these kind of function prototypes. So char pointer, this thing. How about extern char pointer? And then it's going to take a char pointer as well. And then we also need to... So we need to do that for everything. I'm not even going to get rid of the CMD define. I'm just going to add this. Okay. And now let's just change the indentation here to keep everything. I mean, we could actually, hold on. What if we just changed it to, well, actually that all fits. It barely fits, but it still fits. So if it still fits, let's not break it apart. Right? This takes a care pointer, right? So it fits, exactly fits. Nice. Yeah, let's not break it into multiple lines. Let's not hard wrap it if it doesn't need to be hard wrapped. That also means that over here, this is wrong. These four declarations are for the same functions. So let's change these four declarations. And I'm still keeping to my rule of, if I use a forward declaration, it appears beneath, right? And it's just a forward declaration for the section to keep like a nice summary of what's there. But it's only limited to this section, right? So I'm not going to forward declare everything at the top of the file, because then I would destroy the ordering constraints that I get from not using forward declarations. Okay. Let's give that a shot and see if I've screwed up anything else or what else needs to be done here. It takes a care pointer, and it takes a care pointer. Oh, hold on. So right here, we're referencing this. And the function... No, that seems alright. It's right there. And there it is right there. What the heck? Okay, so until we can figure out why this nonsense isn't working, we're going to have to just comment this out, I think. And let's go into the data file. And so we have these things here. And let's just comment these out as well. Because I want to deal with this nonsense if I can just comment it out and have this work. And I'm just going to be like, you know what? Don't care. It runs. It might be ugly, but if it runs, that's the first priority, right? Undeclared. Okay, so let's look at this. Oh, do we have the casing wrong here? So here this is. And this is at the top of the file. And then here's this. Let's match case really quick. Yep, that's the problem. Okay. Oh, so I've just been stupid. So these are public functions. These are public functions, and I did lowercase for all this stuff. So let's actually change this back to extern, because now that I see the problem there. And this needs to be capital as well. They're public functions, so therefore the namespace should be capitalized. Okay, let's give that a shot and see what goes on here. Okay, so once again, this is a I don't know what I'm doing kind of moment. So this is in the C11 file, and the C11 file should be... Why is the C11 file referencing these? Should the C11 file be directly referencing these? I mean, it can, I guess. It comes after after the data file and function file have been included. So, I mean, that's fine if we want to do that. But we got to change the casing here, though. Right? So these are public functions, therefore capitals. And give that a shot and see if we can get this working here. Okay, so that's compiling. The next thing you want to do is we want to edit the build script a bit. So, because we're making a utility, hold on. Because we're making a utility, we're going to keep the executable. We're not going to remove the executable. So we're going to comment out this line where we remove the executable, so that we can run it as a command line utility, right? So we don't want to just run the build script and compile the executable, run the executable, and then get rid of the executable. We actually want to keep it around. So now that we have this executable, we can run it. Now, also, now that I realize something, we don't just want to call it exe.exe, though. We want to call it the same name as the project. So everywhere we see exe.whatever the heck, we're going to call it this. And then we're going to just, yeah, there we go. Remove, let's line that up a little bit nicer. Okay, awesome. So now we need to delete this executable, because we're going to name it something different. And then we're going to run this, compile it, get the executable, try to run it from the command line, see what happens. Okay. So let's move this over to this side. And just try ./PHEXDUM, and we want to do like C99 to PNG. And we need some type of file, so myfile.txt or whatever. So 3 arguments, or actually 2 arguments. 3 arguments would be like an output file, but we're just going to use 2 arguments here and just see what happens here. Segmentation fault, great, awesome. So interesting, if I do it on the command line, like this, I can actually see the segmentation fault error. Nice. I'll do that for, I'll remember that for next time. So we're doing all these crazy jump files, or jump whatever the hex. So I do see how we can definitely get a segmentation fault here. So wherever we're using a jump file, I know we have this assert here, and so that's probably safe, but let's just kind of do extra guards here, right? So let's do a guard here and just say that, you know, if, text out could be so there's a lot of criteria here. Okay, the enumeration should be between 1 and 4. You know what we're going to do? Okay. If, so this jump thing here, right? This jump here, this jump table with the command enumeration. We got this command function. Do we use it anywhere? We use it right there. And we even assert that they're equal to each other here. Now this assert could fail. Oh, this assert could fail. The assert itself could lead to a segmentation fault, right? So let's put that there, right? Let's put that there just in case. And if we get a command pointer that's null, if this is not equal to null, if it's not equal to null, not equal, now let's just do equals so then we're going to take the text out and say null cmd func pointer, right? So we'll just say air null cmd func pointer for the text output. And then we don't have to crash the program. We can just say this thing here, right? And so let's give that a shot. So let's try to compile this. So let's do ./phexdum.sh. Let's try to build that. And then let's try to run it with our thing here. So let's try to run this and see what happens. You get a segmentation fault. So we still get segmentation faults. Great. So just segmentation fault. This it's been so long since I didn't get segmentation faults, but I know why. It's just because I've decided to get crazy. And let's log and say, let's do a log and say about to call right. Let's make sure that this actually works, right? Like maybe we're making a mistake here. Let's make a logging function and say, you know, log is typically second, right? So it's typically the second function. We're going to do info any paste. Now, because this is a little bit different than how we usually do it, we're going to get rid of the silence wrapper. And we're going to say we're going to say PHEXDUM C11 info any, right? So it's not quite the same as how we usually do these messages. And so we'll say, we'll use this for the namespace, so it's coming from the C11 file itself. And then let's justify this, so now that we have this kind of thing here, we can define log as the info any function. And I want to get rid of the seg fault before I go do my exercise. So this is going to be log, and this is 05. Okay, so where is log here? That looks like the correct way to do that. Okay, so now we're going to give this a shot and see if maybe we can see that message, or if it's coming from somewhere else, right? We don't know where it's coming from, so let's just keep on doing this until we can figure out why this seg fault. So there's a segmentation fault still. Now, we haven't even called this thing, right? This jump table here. Also, this assert, though, this assert could be causing the segmentation fault, right? So we might as well... let's do 2 logs here, right? So about to assert JMP CMD enum, right? So we're about to assert this, about to do this, right? So the assert itself may be causing the segmentation fault, and I don't know if that's true, but it could be. So Nope, so the segmentation fault, as far as I'm concerned, is happening further up here. So it's not happening here. And so the question is, well, where is it happening? Well, it could be happening here, right? It could be happening in one of these helper functions, because we did a lot of craziness here. So we might want to say, we might want to log here and say, calling, or about to call, and then we're going to take this function here, right? Dot, 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 \n, sure, why not? And then, right here, we're about to call this thing. And I see that we have everything kind of lined up. Can we do that here as well? Do we want to line everything up so that we can see? Because everything's CMD name right here. It would be nice to keep that column there. So we could just do that there. Sure, why not? That way we can just see. That way we can see kind of like CMD name is like everywhere here on a nice little big column, right? And then CMD enum is, or CMD func is lined up there. So these two are different, right? So this is CMD func. So I think that the seg fault could be happening there. Log populating jump, about to populate jump table. Right, and here we're populating the jump table. So let's do that and see what that gives us. So build it. And this log function is not exactly how it needs to be, because we need like a 0 in there. And now we're kind of like up a creek without a paddle in terms of, well, it's a log function, so we should be able to just do this. We should be able to get rid of that new line, right? And we should be, yeah, we should be able to get rid of the new line because it's a logging function. And same thing with this, we shouldn't really need that new line, but we do need a 0 and like that. Okay. So compile, and then try to run this command. And about to call CMD name to CMD enum. So this first thing is, this is seg faulting on us here. So let's copy that. And we did a lot of crazy stuff in here, so I am kind of not totally surprised that there's a seg fault in here. So here we call this. So let's go take this helper function, right? It's the helper function, I'm certain, that's kind of crashing on us. So let's just take this and say, let's log the first line of this function. And then at the end, let's log the last line. Well, we can't really log the last line because then we got nothing, right? So let's log it here for the end, right, before we return the data. And let's indent, let's keep proper indentation if that's the way we want to do it. Let's declare some variables. Declare variables and then populate tables, right? So we have variables and we have tables. And we're running out of room to indent, so we're not going to indent, we're just going to space it. Populate tables. Okay. So these are our tables. And then find the command. And I think we might have messed up our loop now that I'm looking at this. Find the command. We start at 4, and the command is greater than or equal to 0. And then the command is this. Yeah, so we're segfaulting here because we're supposed to go backwards. Right, we're supposed to go. I don't usually write loops this way. That's kind of why. So we start at 4, and we go 4, 3, 2, 1, 0. And that's so that we can end on the invalid command index, right? This is the invalid command index here. Now, sin does have the last entry of this is, I don't even see where this is being used. So these are our synonyms, but I don't see the synonym table being used, so that's kind of stupid. So somewhere we're making a mistake there. So we'll fix that, but first of all, we have to just one thing at a time. Okay. So the table of functions and the table of synonyms, here's where we're looking through the synonyms, and here, this is table of synonyms. Oh, there's sin right there. Why did I not see that? Let's look at that again. So sin. So we're just making sure that the table of synonyms, the current table of synonyms, is equal to sin CMD, right? So sin is a table of tables, right? So I want to make sure that this thing where we're getting the table of synonyms, so we're extracting one of the tables. And when we do that, we want to make sure that that table we extracted from the data file matches the inline sin table right here. So we just want to make sure those two tables match. And then we're going to go through the table of synonyms. And we're just going to compare to see if the command name equals the synonym, right? Does the command name equal the synonym? And if so, then we have found the command enumeration, the command func, and the check enumeration, all that good stuff. Now, if none of this works, then this needs to be set to some type of sane default. Right? So this return data could be a problem. Now, so the command function, yeah, we need some type of placeholder command function, I think. Yeah, because that could also segfault on us, right? The command function and the command enumeration. So the command enumeration is 0, but this command function should be like some type of default, I think, would make sense. So we're going to do something like this. We're going to say we're going to make a function nothing found. We're going to create something called nothing found. And we could also go in here. And this nothing found function the nothing found function we're going to put at the bottom. It's going to have the same exact format as the other functions, except except it's just going to return so let's return kanji coder says command not found. And this character pointer, we don't care what that is. It could be null for all we care. We just care like if. Just want to do a no op on it. And I don't know if we can do this because it's a pointer. But let's just try that and see if we can get that working. So this nothing found command is, we want to use that here. So instead of the command function being this, we're going to say it equals nothing found, right? So we want to take the address of this as a default in case we don't find anything, right? So if we don't find anything, this function will be used. And that way we can avoid some seg faulting as well. So let's give that a shot and see if we've fixed all of the segmentation fault stuff, or if we have something else. Implicit declaration of log. Okay, so log here is not the same log as before. So this log needs to be a different log. So we need to go over here and say log typically second. And I need to make a note of this. (2021) 01 0201. And so right here, we're going to do it as we would PHEXDUM, right? So PHEXDUM is actually going to be the subsystem name once I put this into the main code base. And this part is not going to work, though. So we're going to have to change the formatting of this one so that we can comment out this condition for now, because it doesn't exist, because it's PHEXDUM. We got to comment this out for now because it's not, this code doesn't actually exist in our library yet. So we'll just comment that out, and then right here we're just going to say PHEXDUM log, and that's good for now. That's good for now. But also, we need to take this, and where we have our log function, we're using log. Where are we using log? Do we not even define it? Are we using log, and we didn't even define a macro for that? So right here, we need a log function. So let's just define log as this function. I'm not really going to care about the exact order of my of these things. I don't really think it matters too much to me. It just, the checksum matters, though. The checksum is kind of the most important thing. So we can kind of see that we have 6 here. We just added another one. 1, 2, 3, 4, 5, 6, 7, 8. Rather than try to figure out where that went wrong, well, since we have to remake that list anyways, we can kind of like put these in this order. Air and log, any function, const char. Let's kind of move these, let's put these in places related to each other. Command enumeration. Sure, let's do that. That looks a little bit better. And let's renumber these. Okay, so we got 8 of these. Copy this. Save this. And then go over here and just paste this down. Undef. And space. Then we'll change this to undef. Okay. So now, what do we got to do here? I don't know. We got to give it a run and see if that works, right? So let's just double-click this to compile rather than... Okay, so that compiles. So now the next thing is, hey, let's try this again. Okay, so our sin table has a mismatch. That's fine. Let's figure out what's wrong with it. That was the whole reason why we had this, is we wanted to make sure that the table that we pick from here with this command, I want to make sure that this table is equal to this thing here. So sin has these synonyms. It might be the first thing. So sin is right here. Yeah, so this sin here has this first entry is this thing here. And the invalid command thing is this thing here, and that's fine. But if we want to rebuild this table to make sure that it's exactly the same as the other table, then it definitely needs this here as the first thing. Otherwise, we could look at slot 0, and it might not match because of that. The other thing is we want to make sure everything is in the same order. So the next thing should be PNG file to C99 text. PNG file to C99 text. C99 text to PNG file. Yep. Okay, how about this one? PNG file to naked text. PNG file to naked text. How about naked text to PNG file? That all looks good. Okay. So that looks good. Let's give that a run and see if we don't get any more errors. Okay. We're better. Okay, cool. So it says C99 text to PNG file. And what do I see here? What did I type? C99 text to PNG? Excellent. So let's get rid of all this useless logging now. Let's just comment it out. So let's go into this here, and let's just if 0 is greater than 1, which it never is, then we'll do this. All right, we just want to shut it all off right now. And then we also want to shut off the logging over here, right? We have another logging function here. Same thing. Oh, well, wrong function. This is the halt function. We want to keep that. But right here, you know, if 0 is greater than 1, which is obviously always false, then we will do this stuff here, right? And then the other thing we can do is we can shorten this right here. So we could do define pf for printf, and then we could define ff, or flu for flush, fflush, and then we can undef it right here, undef pf, and then undef fflush, right? So we got this, and oh no, we wanted to do flu. So then we can shorten this and go bam, bam, and bam, and then we can take flu and put it here, here, and here, and now it's short enough to where it fits, right? And now let's try to compile that, and just make sure that it recognizes where everything is or not. Okay. So, okay. So how about PNG to C99? Whatever, dot, whatever. Okay. PNG file to C99 text, and then we also have C99, or we have naked to PNG. So we also want to be able to do naked to PNG. Whatever. naked text to PNG file. Okay, we want to also do PHEXDUM PNG to naked. Whatever. Okay, excellent. So all of the little things are kind of stubbed in place. So let's go over here and open up a git bash here. And make a note of this, right? So 6 hours to just stub things into place is kind of depressing. But, you know, my idea is to work slowly, not to work quickly. So, oh well. Um, okay, so we did what we did, and the comment message there is what we did and what to do next, right? So comment messages, just make a comment message useful. Don't subscribe to that dogma of, oh, the comment message has to be why you did what you did. I have what I did and what I want to do next. I think that's fine. So let's push this up to GitHub master. And then let's let's push this up to what did I do wrong here? Git push oh no, does this not exist on git remote -v? Oh, I see. Oh yeah, because it only exists on GitHub. That's oh yeah, because this is just a small utility. It doesn't exist in two places. It only exists on my kanji coder. That's fine. That's fine. Just as long as I know that. Okay, so that's fine because I can see that it's kanji coder. This isn't aliased as kanji coder, but that's good enough. Okay, so we need to do some exercise, and we also need to do. So here's what we're gonna do. We're gonna try 2 sets of 30 to get 60 push-ups done. And then we're going to, after we do our push-ups, we'll put a break counter on to do whatever else needs to be done. But and during our break, if we get done with our break earlier, then we'll do even more push-ups and stuff. But so let's get a timer here. Let's just try to get some of that exercise we need to get, because we're 6 hours in, and yeah, so let's, or actually, if we did 20 per hour, and we're almost at 8, then we want to do 40 and 40 to get to 80. Let's just try to get our 80. I mean, that's a lot, but let's try to get all that exercise done right now. So let's do 2 sets of 40 and see if we can manage that.
Six, 27, 28, 29, 30, 29, 30. Okay. 1, 2, 3, 4, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay. 30 dumbbells. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Okay, I'm gonna go upstairs, heat up my coffee. Then I'm gonna do 30 more. Yeah. Okay. Let's change this to 30. And we're gonna we're just gonna go upstairs, heat up our coffee, come back downstairs, and then we'll do 30 more, and then we'll be halfway to our 120 for the day. Yeah, I think that's how I'm gonna roll here. So I'll be back. Okay, so I have to do my dumbbells, but I did 30 other push-ups, crunches, and squats. Did those upstairs while I was heating up my coffee, but I got 30 more dumbbells. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, let's get back. Okay, so we've done 60, that's halfway, or halfway. I just don't want to wait till like the end of the day, where there's like 1 hour to midnight, and I still haven't done any of the exercise I need to do. Okay, so we have now gotten 60 push-ups, crunches, squats, etc. Trampoline jumps we do every 100 we hit, we do 100 trampoline jumps. So anyways, we're gonna go back here and figure out what we need to do next. So let's figure out saving to file first, right? So saving a file to disk, I know I've done it a few times, but I forget. So let's do, if we do save file to disk, do we get any hits? No. How about, if we do something similar, like file to disk, let's, if we do something similar like this, we'll say try save file to disk. I see that I'm about to type disk with a C, like it's some type of Blu-ray disc or something like that. Yeah, and I see I have a propensity to do that. So let's say that file to disk, file to disk with a C, file to disk with a C, file to disk with a C, and the same thing, try file to disk, and we'll say that this is, you know, 01, shortcut number 1, this is shortcut number 2, just to differentiate them. And if we do save file to disk, let's make some type of file for that. We don't know what the shortcut file is going to be, but it's something we need to do quite often. Well, maybe not quite often, obviously not enough that we know it offhand, right? So it's not something we do that often, but it's something that comes up common enough that I would like a shortcut for it. So that, you know, next time I try this, I can find it, right? So how about save text file? Use we're gonna make a shortcut for that called save text C99, because I would also like something like that, and also save text, save text, save text, and we're gonna say save text C99, right? So we're gonna have a thing for try. This one says try, this one says use, right? So they're slightly different suggestions. And then over here, We're just going to say save text C99. And this is going to be specifically a shortcut for ASCII text. You got to figure out what that's going to be. And right, so we can make a note of that. And then let's go look at how that's done. Now I already do this, like I've already done this a few times, so we could just look at some old code and find it from there, right? So we could look into our old code, our main code base, and we could just go find it, right? So let's go, yeah, I think that's what we're gonna do. So let's go look at the AAC 2020 folder for a second. And if we go into our library, we have a thing called FileBoy, which handles file system access, right? So if we look at FileBoy and we want to see what it does, all right, let's open it up over here. And we got halt, we got info string. We don't need those. Make one directory. So we make a directory, make dir, we got to make dir. I got touch file. So chances are we probably touch a file before we save a file to disk. So here we got save file PNG, and it might actually be using the load PNG library to do this. So we might need something else. So we got file PNG right here. And I'm going to guess that file PNG, so we touch the file. And if load PNG is included, result equals this. Yeah, it looks like this saves the file. I could be wrong. Maybe result is what we're saving. No, that's not what we're saving at all. Okay, so we have to look at how to do something similar to this, but we need to save the file. So, how do we want to do this? I would like to make the touch file is kind of nice, right? Because then we can because chances are we're going to have to touch the file before we try and save it, right? The save file stuff is not is using load PNG, so we should and it's actually called save file PNG, isn't it? Like everything that's called FileBoy save file, it's probably all save file PNG, right? So let's go look at that really quick. Yeah, it's all that. Okay, so here's what we're going to do. We're going to just copy paste a lot of this into the new code base. And that way we can... Yeah, we're going to take the save file to disk and the touch file. We're going to take both touch file and save file. And does touch file actually use this kind of like recursive whatever the heck thing? Does it use that? So FileBoy make one directory, is that in touch file? And it's in make dir. So if we look at this, we got this and we got this. And I'm going to guess that there's a high chance that touch file might be making use of one of these. Yeah, it uses make dir. And make dir is make dir using the recursive thing. Make dir is right here, make one directory. So where is make one directory referenced? Oh, right here. Oh, make dir, the recursive make directory calls make one directory. Yeah, so this is all needed. We need all the way up to here. So let's just steal all of this. Let's just steal all of this. All this stuff, we're going to steal it all.
Save file to disk. We're going to steal all this, all this, all this. Oh, hey. Let's see. Where can I get you up to speed on what I'm doing here? Oh yeah, I think. Yeah. Thanks for that big graphical list of books you gave me yesterday. So let me explain what I'm doing really quick at a high level. I need a utility to take, let's see if I can do a little diagram here. I need a utility where I can take a, let's go in our assets folder. Okay, so I have this asset right here. Here's this asset, and I want to put it into my executable. So I want to encode this asset into my executable. So we're going to write a utility that's going to facilitate getting this PNG file hard-coded into the executable. And the way we're going to do that, sorry if I'm repeating myself. We're going to write a utility to help us get this asset into the executable. And we're going to create a command line utility where we can say PNG hex dump. So we're going to do /p hex dump, right? So this is the library. And then we're going to say PNG to C99. We're going to say PNG to C99. And then we're going to supply file.png and then, output.c99 or output.txt. Either or would be fine. And what it's going to do is it's going to read that PNG file and then create something like this. It's going to create a U32 array of PNG data. And it's going to encode the PNG data as a whole bunch of bytes, right? So not bytes, but pixels, I guess you could call them, right? 4 bytes. It's going to pack everything into 4 bytes. Now, we have to remember that if we do this, we're going to have to worry about endianness. But I want a very compact way because I want to reduce these. I want to keep the size of the executable down, but I also want to keep the size of the source code down as well. So this is slightly less space than having to do something like 0xff, 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 0xff. Right? One of these right here is less text than one of these, right? So I want to keep the source code size down as well as the executable size, and that's why we're going to make something like this, right? So we're going to run this command on the command line from the utility we're making to convert a PNG file on disk to output like this. And so this is PNG to C99. And we're going to have another command that we want to use, and it's going to be called PNG to NAK, and NAK stands for naked. And so when we do that, instead of converting to this, we're going to convert to something like this, like a file that's just like this. So it's naked because it's like a naked array without the syntax around it. Now the reason we want something like this is so that when we're creating a build system, we can do something like, we can take this. Oh, hey, oh boy, okay. I guess I'll re-explain. Okay, so I guess I'll yes, naked array. Yes, I will explain exactly what's going on here. Okay, so I'm working on a utility. So let's look at this data here. So this is a data set for re-explain. Yes, I'm going to re-explain because you just popped in at the right moment. Okay, so this is the data for a tile set, right? And remember that all tile sets have different layers and they have different tile sizes, right? So this is the first layer, second layer, and third layer, respectively, of the smallest tile size, right? The smallest tiles, you have more of them, you got more granularity, you got more tiles, right? And then the next tile size down is half the size, right? So I know I've explained this part before. but now I'm kind of showing you with like a more graphical representation. So we have this kind of data in a PNG file, and we want to hard code this data into our executable. So we need to create a utility that's going to help us with that. So what we're going to do is we're going to create a utility called PHEXDUM, stands for PNG hex dump. Okay, so one of the commands is going to be PNG to C99. We're going to take the PNG file and specify an output file name. That could be .txt or .c99, doesn't matter. It's a text file. And that is, the SM64 decompile has a utility to turn PNG into C files that gets compiled directly. Ooh, nice. Could you link a GitHub or something? Could you, so let me put this up here, because that's, I think that's pretty valuable, what you just said there. Awesome, so let me take a look at that. Now, I'm not going to guarantee that I can understand anything that I'm about to see, but that does look helpful. Now, I'm already in the middle of writing this, so I'm probably just going to finish it, because I'm already writing it. Though that is kind of a sunk cost fallacy, but let's just look at what we got here. Assets, something, something. Boy, we got a lot of stuff in here. Okay, so we got some Python files, checksums. Okay, Super Mario 64. This repo contains a full decompilation of Super Mario 64. Naming and documentation of the source and data structures are in progress. Quick start for Ubuntu. Installation. Okay, so that's so. Boy, this is a lot of stuff. So I may want to take a look at this later. But oh boy, there's and what do you say? Let me look at your comment again. It's cool that GIMP also exports work to C code. Really? Okay, GIMP. So I am on Windows, but I am familiar with GIMP. I messed around with it for a while a couple of weeks ago. It's cool that GIMP also exports to C code. Oh, I didn't know that. Okay. So I should also take a look at that. So here's what I'm going to do. I'm going to take your commentary. So I'm going to take that link that you just gave me. So you just gave me that link. I'm going to just throw it in here for reference. So Super Mario 64. And let's take this, put that over here. Let me look at some of the commentary you're saying here. So you're saying, I'm gonna take that commentary for reference in my shortcuts, so I know what the heck this conversation was about. So let's see, date 2021, 0201. And SM64 decompile. So let me put SM64 decompile, and SM64 decompile. And then we can also, since this is the first time I have a piece of knowledge that you have given to me, I'm just going to put, I'm going to take that right there, so that I have this kind of like, if I ever want to remember something that people who have been watching me have been telling me, I can use that to kind of like reference. Okay, let's see if anyone else has said anything else interesting. The code is definitely worth looking at. I love the way they use macros to make a sort of bytecode for behavior scripts. I'm officially logged in the book. Oh, awesome. Okay. Oh, you mean my book. Yes, you are logged in the book. Let's see. Is that Daddy D-Hust or Daddy Dust, but like with where you pronounce the H, like, or I love the SM64 decompile project. Sadly, given my free time, I only contributed with decompilation of one function. Okay, cool. So it sounds like some pretty heavy duty stuff. It might be a little bit beyond me, honestly, but I will I'll try to take a few glances at it. I don't know if I'll get as deep as you peoples, But like I took a look at a while ago at the what is it, the Doom code base, like John Carmack like released the Doom code base like what, 10 years ago or something. I was taking a look at that, but a lot of times when I look at other people's code, I'm just like, I don't get it. But sometimes when I look at people's code, I get it. Yeah, let me actually see if I can find the link for that. Well, actually, you probably already know where it is, but let me see if I have the shortcut for that right now. Doom code GitHub. Doom code GitHub. I'm gonna put that. Yeah, I think that's not the root, because I think it was something I was looking at. But you know, save you a little bit of Google searching. I know that. What was I reading on Facebook? I don't know. I hate it when people tell me to Google stuff. It's like, if I ask people for something, it's because I want a human answer, not a computer answer. But that's a rant for another time. So yeah, so I guess I don't really have to explain too much about what I'm doing, because I think that it sounds like you know exactly what I'm doing here. Now there's two things that I'm doing here, though. I want to compile, I want to take my PNG file and turn it into something like this, but I also want to turn it into something like this as well. So in my build system, I want to be able to write code like this. Hold on. So, you know, include some PNG asset naked array dot txt, right? So I want to, in my build system, I might want to do something like this. So that's why I want to be able to output a file like this, but I also want to output a file like this. And I actually have a build system like this already in place, but not for PNG data. I have it for GLSL code. So we could take a look at that really quick. Let me close this, though, close that explanation, and show you where that is. I got way too many text editors open, but I think it's worth explaining. So let's look at the PAINT5D system. And within the, so P5D OGL, P5D1 OGL, that's the PAINT5D system code, but it's specifically the OpenGL code. And we have a thing called .fragment, and then we have .fragment.string. And this is just, my build system just uses the awk command and takes the C99 code and just wraps it in a string so that I can inject it into a GLSL shader. And you might be kind of like, wait a second, GLSL is not C99 code. You are correct, but that's why I wrote my GLSL code in a very specific way so that it could also compile as C99 code. Basically, I have a macro, right? Macro, this is OpenGL. And if it's OpenGL code, right, we define some very specific OpenGL things like uniforms, right? And then we have like another section. If this is OpenGL, all these different types get defined differently, right? So float32 is float, uint, int, ivec2, etc. Texel fetch is actually texel fetch, so TF is texel fetch, right? All this kind of stuff. And then if it's C99 code, right, uint32, ivec2, uvec4, texel fetch, right? They're all polyfills basically. So I have a polyfill namespace called polyogl, and so I've made my code like this so that I can unit test it, right? So I can compile it as C99 code, and I can run unit tests on it to confirm that my algorithms are all working correctly, and then I can just wrap it in a big string like this, right? Wrap it in a big string, and the build system responsible for that, it's not really much of a build system because I wanted to keep it simple, and I'm going to read your comment. So if we go into so my build system is just this. This is my build system. It's 3 lines of code, right? So just use awk command to take all of the non-empty lines and just wrap them in a string, and take that input file, right, the fragment shader, and then output it here, right? So take the fragment file and output it to a string. And then now that we have this file, somewhere else in my code, I just do an include of this, right? So I have something where it's quite literally something like, const char pointer my shader string you know, equals, and then, you know, we do like a hashtag include, and then that, and then we do that, and then bam. And then there's like a few like things up here for like, there's a few things up here that are kind of appended on, but it's basically something like that, right? Now let me read your comment, right? So let's close this. Close this. Oh, and I'm going to put the chat down here so you can see it. Okay, so, oh, interesting. I was watching a Rust guy the other day, and apparently there's a compiler for Rust that compiles to GLSL. That sounds awesome. So I've heard really good things about Rust, and it sounds like a good thing, but the reason I do C code is just because I have a habit of making things too complicated. I have a habit of making things too complicated, and so I'm really trying to keep the code base really simple. So a lot of times when I look at other people's code and I try to build it, I'm like, CMake, what's that? Make, what's that? I don't know what that is. Well, okay, I'm being sarcastic. I do know what it is, but I'm not very experienced with it. And so the build system I'm making here is, if this build system fails, if my build system fails, I still want people to be able to take the source code and just do like a GCC command on the source code and still have it build, right? So I want to make my build system, all my build system should be doing is pre-processing files. So eventually I'm going to add 2 build files, right? So one will be a full build, and the other build file will be just build whatever's there, don't pre-process anything. So that way people who are new to C code, or people who, like me, that just suck at building things, will be able to run my project, right? Because a lot of times the brick wall you hit when you're coding is not the code, it's the build. It's the build that gets you. And so I'm just like, you know what? I want to make sure that I keep the build system just as simple as possible. Otherwise, yeah, I just don't want a complicated build system. Yeah, I'm not a Rust guy. I also work in C like C++. Yeah, I mean, that's what I hear a lot. I hear a lot that, you know, all the game devs, when they're doing C++, they're actually doing C like C++. It's like they really just want C with a little bit extra, but they don't want like the whole monstrosity of C, right? Because then it gets like really out of hand really quick. So I totally get the C like C++. I totally get that. And that would be something I would do, but it's just I have this very paranoid mindset where I'm like, yeah, C like C++ sounds great, but I just be like, man, I might just modern C++. Yes, quote unquote modern C++. Or I don't know if you meant it sarcastically or not, but sometimes I feel like bringing everything in is kind of crazy. I've talked to a lot of companies that want to do modern C++. Yeah, like, yeah, it's too complicated. It's like, first of all, I'm not even sure I'm smart enough to do modern C++. And even if I was smart enough to do modern C++, I'm like, that extra complexity kind of seems like I'm wasting brain cycles. Like, like, even if I'm smart enough to, like, comprehend it, like, is that an efficient use of my brain cycles, right? It's like if you're making an engine, and you make that engine as efficient as possible, even though you have, like, a really great graphics card and a very great, and a great processor, and maybe you have, like, a whole bunch of cores or something, just because you have, like, a really beefy setup doesn't mean you don't want to make your engine as efficient as possible, because the more efficient you make it, the more people that can run your engine. And so sometimes I think of that in terms of, like, languages, where just because really smart people can understand it, wouldn't it be better if you just kept it simple enough that more people could understand it? So I'm saying I'm not that smart, and I don't think I could understand modern C++. I think it's too complicated for me. And like when I write my code base, I want a lot of people to be able to use my code base. I don't want it to be like just for like somebody who's like a genius or something. I want this code to be easily accessible, if that makes sense. Anyways, I was in the middle of mindlessly cutting and pasting stuff. So there's like file system access, which I don't do very often. And so I was just looking at an old code base where I had like some commands in here, like save file PNG. And that's definitely going to be one of the commands I'm going to need for this utility I'm writing. And I also have like a touch file command in here. Right, so I know that like with code reuse, usually cut and paste is not like it's kind of a dirty thing to do, but I do it. So it's like, hey, how's it going? Yeah, have you been here before? Because I can go over some stuff if you haven't been here before. Otherwise, I'm going to keep on kind of doing what I'm doing. Right now, I'm working on a utility to take a PNG file and convert it to text. Oh, okay, cool. So the first thing I'm going to show you really quick is here's a link to some technical demos. So I just put a link to the technical demos in the chat right there. And that's a whole bunch of tech that I'm working on that I'm going to put into a fractal auto-tiling engine. Or, no. It's just C code. It's just plain C code. I like to keep things kind of simple. Well, okay, that's a lie. I don't keep things simple. I make things complicated enough, so I try to stick to C, just so that I don't, things don't, like, get out of hand, because it's very easy for me to over-engineer things. So, using C kind of helps me not over-engineer. Too many bash scripts. Got too many bash scripts. Let me go back down here. Yeah, so I like to use C just so I can keep things simple. Also, I did a lot of... Thank you. I did a lot of ActionScript back in the day, and I made a game in it, and it took me like 2 years. And then right as we were finishing up the game, or we weren't even finished, we still had to do a lot of UI work, because I suck at UI. Hence why I follow Hirasa, because I think their UI library will be useful to me eventually, because I suck at UI. I suck at UI coding. I hate UI. I need something for UI eventually. Let's copy this. Let's try to... Okay, so here's this. What else have we got open here? We got this open. We got that open. Let's put this over here. Manage our editors. Okay, so we need to just throw this in somewhere into our functions file for this. I'm going to just try to paste this and reorganize it a little bit, because I don't know what I need to do. I need to change the namespace as well. Okay, just paste that in there. Let's see. And yeah, thank you. Is that pronounced co-rebel? Like, as in, like, KO? Like, KO, like, knockout? Like, co... But yeah, thank you. And I see somebody else followed me. I don't know who, but thank you for following. I mean, like, so you can see what my screen looks like, so I don't see a list of followers. I honestly prefer not to know anyways, because I feel like if people just want to lurk, they can lurk, and I don't know. So IMGUI is also an interesting option if you haven't seen it. But yeah, Hirasa's UI is pretty lit. Yeah.
So the one thing I gotta do to figure out how to use his UI is I'm Yeah, so I don't use the OpenGL headers. I kind of am a little bit crazy about how I do this, and I just directly grab all the function pointers. I'm doing like native Win32 code. I just a lot of stuff I do is not sane. It's not, yeah, it's not sane. But I have never once said that I do things in a sane way. So I feel like I'm good because I never made that I've never made that guarantee to anyone to say that, hey, I actually do things best practice. No, I do things in just the way I like to do them, and you know, I have reasons for why I do things, but sometimes I'm just completely insane in the way I do things, go about them. And because of my weird habits, I do need to kind of see how I'm going to get his code kind of working. So let's just say it's going to be the FileAccess section. File read write section. Yeah, file read write section. Yeah, let's call it that. And let's do we want to, I don't know. I think I'm going to make the section divider a little bit bigger than I usually make them, because this is kind of this section is kind of like, right, we added an extra layer of indentation, so I want to keep some type of hierarchy between these sections. But yeah, all this code, this is a ridiculous amount of code here. So the reason why I'm doing cut and paste rather than just including the library is just because I want to reserve the ability to change this code later to however I see fit for this specific utility. And I want to make it really easy to, after I work on this utility, to just cut and paste the utility into my main code base and just not have any problem, if that makes sense. So that is kind of why I'm doing what I'm doing. Now, this is gonna need reformatting. Let's not worry about all this formatting yet. Let's fix the main dividers here. But after we fix the main section dividers, we're not going to worry about exceeding the column limit right now, because working code is the first priority. I know I meticulously kind of indent stuff all the time and have like a very strict column limit, but despite the meticulousness that I have, my first priority is actually working code. Surprise, surprise. So I am going to just clean it up a little bit, but I'm not going to worry about this kind of stuff here. I'm just going to be like, screw it for now. Sometimes things turn into disaster, and it's okay. And anywhere I see this thing that says FileBoy, FileBoy is going to get renamed to PHEXDUM, right? So PHEXDUM. And we've got to match the case, and we're just going to go through here and just we're just going to change the namespaces on everything really quick. And we are going to do it one at a time, just to make sure that we don't accidentally do something stupid. Right? Like, there is a lot of like leverage when we do things all at once, but I find the speed that we gain by doing it all at once does not make up for the ability to really shoot yourself in the foot. If, like, for example, here is a good example. We don't have this system right now because this is, so we need to comment this out. This system does not exist because this is not in the main code base. So I'm just going to comment it out because I will want to re-implement this guard here. And so blah blah blah, 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 blah. Replace that. Okay. Save that. And, so let's see. OpenGL is done on the user side on VUI. It just pumps out vertices and indices. Alright, I'll have to take another look at it. I'm not, like, at the UI point of stuff, so as I get more desperate to get, like, UI stuff, I'll take a look at it. Right now, I'm just, like, doing everything with shortcut keys. So, right, get some basic shortcut keys to make things work, because the first release of the editor that I'm working on, it's just going to be enough that my artist can use it. So, you know, we both went to DigiPen and did like 3D computer animation. So we are very familiar with just, you know, one hand on the keyboard for your shortcuts, and then another hand just pulling and pushing vertices with the mouse and rotating and scrolling and zooming in and out and whatnot. So he'll be fine with keyboard shortcuts as long as I tell him what they are. But eventually I want something that is a little bit more friendly for other people to use. So I will check that out. And I'm going to put this back over here. So, okay, so he pasted a whole bunch of stuff in here. And let's just make sure that everything is still compiling, right? Because do we want to keep this open? No, let's close this. This is just the asset that I'm working on. We got too many things open. Let's close this. Okay, so let's just try to compile and make sure that we're not missing anything. Like there's not any time. So makedir, I'm gonna guess makedir is not okay. So there's some things that we need to include in the C11 file. So right, so these are all the includes that would be if we cut and paste our data file and our function file into the main library, then these things right here are includes that are already part of the system, so I don't have to include them. This is also already included in the main project. But yeah, so we need to include, what was that? It was, god damn it. Let's just run it again. It was makedir. So now let's go over to here for a second, and FileAccess is not something I do that often, so I'm just going to say like include makedir and see if I have an include that will include wherever makedir is from, and if I don't, then I'm just going to have to look around for a second. So it doesn't look like I do. But I do want to make sure that next time I run into this problem, I don't want to have to think about it again. So I'm just gonna do a thing for makedir, include mkdir, and then include mkdir, and then we'll figure out what this is eventually. And it should be just one line. Actually, we're gonna have to paste a file though because it has hashtags in it, and my shortcut script really doesn't like that. Okay. So we have to find that. Where are we going to find that? So let's go into the main AAC 2020 folder for a second. And let's look at where we're including everything. So it should be in our lib. We have a thing called libchan. So let's go look at that for a second. And let me actually explain what libchan does. So libchan, for a second, is part of my build system. My build system is mostly just C code. So if I, oh, and I see I got 48 followers, so whoever followed, thank you. If you want recognition, just say, hey, I followed you, and I will thank you personally, but I can't actually see who's following me. So if we go into our main C11 file, so this is the file we compile for the main library, I have all of the systems here. All of the systems here are in a big linear list. And the reason for this is I want predictability in terms of how the code is assembled. If we use something like dependency injection or some other dependency resolution, like even if we use something like include guards, right? If we used
include guards or dependency injection or any other type of fangled way to manage dependencies, we could end up with this problem where when we include one more dependency, it drastically changes the way the dependency graph is solved, right? Because if you have a graph of dependencies, that graph eventually needs to be turned into something linear. And what I don't want is a situation where I add one more subsystem to the project, and by adding that subsystem, it shuffles around how the dependency graph is solved, and then, I don't know, it just makes it a little bit more inconsistent. Like, I want more consistent compilations just so that it's a little bit easier to debug in the hackish way that I debug things. So, for example, we see that P51OGL stands for PAINT5D, subsystem 1, or actually editor 1, OpenGL. And so this is the OpenGL code library for this system here. So 33, it's assigned 33. So this says libchan cur 33. So that means I'm going to compile 1 to 33. Now let's say one day I do something very stupid in one of these libraries and I invoke some type of undefined behavior and I'm getting like random crashes, right? So it's not like something where I'm just consistently segfaulting or some type of consistent predictable crash. It's like inconsistent because I'm doing something really stupid, right? Like I allocated a certain amount of memory and then I'm like overriding my buffer, like I'm doing like a buffer overrun and I'm stomping random memory addresses. Like that's the one thing that really gets me is like memory stomps, where sometimes it'll crash, sometimes it won't. So if I ever do that, then what I can do is I can say, okay, I'm getting random crashes when I compile up to here. Well, let's split it in the middle and compile up to this spot here, right? And if we compile up to here and we run the executable and we're not getting any weird mistakes, like weird crashes, right? So we'll have to compile a few times, be kind of hackish about it. And if we don't have... Oh, sorry, I just saw a comment. You're the same... Hold on. I'm going to address Piggy Bank Studios, but I'm in the middle of a thought. So we compile to here, we see if there's any mistakes, like weird crashes and things. And if there are not any weird crashes, we know the mistake is somewhere between system 19 and 33. There's something, it's somewhere in between here. And we do a binary search, right? So then we can compile up to here, right? And we compile up to here and we say, is there any weird behavior going on now? And if there is no weird behavior going on here, then we know the mistake is somewhere in between here, right? And we just keep on subdividing, and then we can hone in on the offending system that's doing something really weird. So sorry, I just saw that. So Piggy Bank Studios, you have the same, the same color, right? The same colored name. So at a quick glance, like I didn't even notice because you have the same color as my name. As far as it's displayed in my chat. So how long have I been Twitch streaming? So I've only been seriously Twitch streaming for, so I can actually show you something. So let's go to my Twitch list. So Twitch list. So let's pause this for a second and wait for this to load. So I've only been, so this is the, what are we on? We're on like video number 120. We're on video 120. So I've been indexing all of these videos. So around when I started this project is when I started getting serious. The first thing I was actually working on was a renderer for rendering some patent drawings in an isometric view. And that's what these beginning tutorials are for like some shader toy stuff. But I've had this account for like 3 years, but I hadn't been doing anything serious on it where I actually explain what I was doing. I just use it as a way to like keep myself productive, you know, like where I never talked at all. For like 3 years I never talked at all. I just silently listened to music and coded, and I just did that as a way to keep myself productive because I could see how many hours I was streaming for and keep a time clock of my productivity. But then I thought that, you know what, it'd be really nice to have like a visual documentation of my code. Yeah, definitely. Yeah, exactly. Yeah, it's a helpful aspect of streaming because you can get those summaries, right? And so yeah, so I've only been doing this for like 120 videos, and let's see, we got too many things open. Let me close this. Do I want to keep this open? I want to keep that one open. Yeah, so I've only been doing this for like 120 videos. But holy crap! So this has been taking me a long time, and it's crazy because it seems like there's 2 orders of magnitude between my prototypes, how long the prototypes I made in JavaScript take, and how long this system is taking. And part of the thing is that there's just a lot of like groundwork here that needs to be done, like file system access and keyboard and user inputs, file system access, having a framework where we're actually doing things efficiently, organizing things correctly. Like, it's ridiculous. Because I figured out how long I've been streaming this project for, and then looked at how many hours it took me to do the original prototypes, and I'm like, it's 2 orders of magnitude more work, it seems, to do this in the C code. It's not just that C code is slower, it's also that I'm being much more meticulously organized with this, because I want this project to... I don't care if it takes me a long time to code this project, I want it to be around for like years to come. So it's just going to be one of those things where it's just going to take a long time. Okay, what the heck is this? Dep load PNG. Oh, this is in libchan, that's fine. Oh yeah, so we were looking for where we had so it's either in stat or types. I really don't know which one makedir is in. I'm gonna say that we probably should just take both of these. I'm just gonna steal both of these and hope that's... Well, errno, we're also using that. Absolute path of your exe. Yeah, all this stuff, it looks like I'm gonna need all this. I'm just gonna cut paste. So I am duct tape programming right now. Is space... Yeah, I am duct tape programming, but I guess it's better than duct tape programming from like Stack Overflow. You know, I'm like, slightly better than that right now, but not much better. But yeah, let's just throw this in here, and I'm just gonna make a note that this is stuff I think I need for mkdir command. I'm just gonna make a little... This is the section. The section, not the best section, but... So the thing with comments is, like, when you comment your code, it's a double-edged sword, because then people can realize when you're full of BS, or when you don't really know what you're doing. But, you know, I don't care. I'm not coding this to try to make myself look smart. I'm actually trying to code this to get stuff done. And so if I don't know exactly what the heck I'm doing, then that's what I'm going to comment, right? I don't really... I'm not... Now, if I was, like, trying to get a job, I guess, then 1, 2, 3, 4, then I guess I would try to, like, sound smarter or something. But the thing is I don't have to worry about that. I'm just working on this code base for me, and oh well if I don't know what I'm doing. And now, if we're gonna do this as such, then we might as well normalize the way we're kind of making these sections. So let's kind of... I know that a lot of my stuff is very, like, administrative, where it's like, you don't have to do this, you're wasting time, but I like things to be kind of well organized, so I'm gonna do it. Load PNG and data and function files. Also a weird section name. And the purpose of a section name is just so that I don't have to read the code, where I can just, like, glance at the section name, be like, oh, that's good, scroll over it if it doesn't interest me. You use a white color scheme. Oh, you mean the, Oh, so yeah, let me explain my color scheme. Because because my color scheme probably makes absolutely no sense. And I'm going to read Piggy Bank Studios. I'm going to read your comment after this. So my color scheme, so if you notice that all of my files are named, so besides the, so let's go in here for a second. So you notice that this is .d underscore, this is .f underscore. The only thing that has a proper file extension is C11 and the sh file. The only reason that this has a proper file extension is because I want to, when someone new to this code base is going to open up this code base and use it, I want them to grab the first thing that looks familiar, right? So this is named .c11 so that they can go, oh, this is a C11 file. Maybe I should start here, right? Or if they want to know where the build script, oh, it's a sh file. Maybe this is a build script, right? And they have the exact same name. Now, I divide everything into a data file and a function file. So all of my data is in one file, and then all of my functions are in another file, and they're paired together. So it's not quite the same thing as people where they do like the header file and then the implementation file. I don't actually do that. I actually divide by data and functions. And you'll notice that I always kind of put these underscores after file names. And the reason for that is I just got sick of syntax highlighting, and so I just, in my language, I just have this one syntax highlighting I use for everything, and the only thing I really highlight is comments. So you'll notice that like the numbers show up in color, but besides that, the only thing that really is colored is I have string literals and then I have comments, right? So it's kind of weird. It's like, why the heck would you only color code the comments and the code? And it's because I want coarse granularity. A lot of my design is based on coarse granularity, where I don't want to subdivide things too much, if that makes sense. So if I want to focus on something, I don't want the IntelliSense to tell me what to focus on. So if I want to focus on, say, flush and printf, I'm just going to go token highlight that a color and token highlight that a color, right? So anything I personally want to focus on, I'll decide what I want to focus on. I'm not going to, IntelliSense isn't going to tell me what to focus on, or, sorry, not IntelliSense. Syntax highlighting is not going to tell me what to focus on. If I want to focus on the fact that this is const char, I can do that, right? If I want to focus on that this is an int, I can focus on that, right? If I want to focus on this specific namespace, I will focus on that. I will highlight it, right? But I don't want the editor to tell me what I should be focusing on, right? And I don't know how that sounds. I don't know if I sound like pretentious or whatnot, but that's just kind of my attitude, and I know it is probably weird. It's weird as heck. Like, I'm sure that attitude is just absolutely weird. Why would somebody be like this? I don't know. That's just the way I am. I guess I'm just really stubborn. So, let's see. I made a little plugin for my text editor to quickly wrap/unwrap similar sorts of headers like this. Definitely worth the time investment. Okay. So let me read that again and make sure I understand what I actually read. Because there's that little time delay between when I read your comment and what I was doing. To quickly wrap/unwrap similar sorts of headers like this. Are you talking about like the section dividers that I'm making? Are you talking about these kind of little things, like this thing here, and then this thing here? And I do think I need to make a little script for this kind of stuff because I do it all the time, and I'm actually taking up a lot of time doing that. So I do absolutely think I need to make a utility for that. I've written a lot of scripts, and I need to write one for that. But I haven't gotten to that. I do need to get to that, though. Yeah, section divider syntax. Yeah, so I do need to get to that. I think it would be a great thing. And I know this probably sounds really stupid, but it's only been within the last maybe month that I've realized that you can use C code to create command line utilities, because so when people process like input arguments from a C file, I always thought that, oh, people process commands from C files because they don't know how to do graphics, and they just need to do like little academic exercises for little stupid programs that professors make them write, right? So that was my attitude. So I never thought any deeper about that. And so I wrote a lot of my processing scripts in AutoHotkey, which is a horrible language to write text processing in. And I wrote it all in hotkey. I wrote a whole bunch of text processing scripts in AutoHotkey to help me. And now I realize, wait a second, I could just do this in like a C file, right? I could do this in a C file, and I could just call the C file from my AutoHotkey script, and then my C files could handle this. And it's much easier to write text processing in C than it is in AutoHotkey. AutoHotkey is just super difficult to do that. Okay, so anyways, and I know that sounds really stupid, but that's the reality of how I was thinking about it. I was like, what text stuff? That's for people who can't do graphics. But now I realize, wait a second, there's a lot of utility here that I totally overlooked, and so now I'm kind of like making use of that. Okay, so we have kind of pasted in some of this file read-write stuff, right? And we indented it, and that's good and all. Let's hold up for a second here. We have a whole bunch of macros we didn't take. So all these macros for... Oh, no. That's good. That's for... Okay, never mind. So yeah, let's just try to get this compiling and see what else we're kind of missing here. Okay, so this was some kind of stupid macro that I probably shouldn't have put into that code. So I'm going to go find those two ridiculous... That is an aspect of some like bad organization of my... Let me put this over here. That's an aspect of some bad organization of my other code base, but we'll... Let's see, where are you? We'll just have to open it up again. So in the function file, we had like these two macros that I just like declared at a really weird scope. What is IS here? File boy info string. So these things were defined at like a really weird spot, and I don't know why I did that. It was a bad idea. It was a bad idea where I did that, and I can put them right here, I guess, like but not this. Let's undef this. Let's just put this over here. So IS for info string, that's fine. And then at the top here, we also have to define what that macro is right here. So we have to define IS, and do we have that info string command? We don't have that. Let's look at the syntax here. So info string. So we use it in a few places, so we are going to have to throw that in as well. So this little helper function, right? So just yeah, it's just a little helper function for logging, and I usually... Yeah, I had way too many logging helper functions, so we just gotta get this working though, so we're not gonna worry too much about the fact that we are getting too granular with the amount of logging functions we have. So now I'd like to keep logging functions to two functions. One function called halt that crashes the system, and then another logging function that does not crash the system, and just keep it to two functions and no more. But, you know, the older code I wrote, I got really crazy, and I just had, like, different info functions, and this info function takes a string, and then another info function would take decimal, and it just got way out of hand. Oh well. So let's just take this and comment it out, and then let's just say if 0 is greater than 1. So we're not gonna, 0 is never then greater than 1, so we're just gonna do this, right? But we just want to get this working, so we want to just throw it in here and kind of like do what we need to do to get this working. So PHEXDUM, right? We're going to change the namespace here. And then down here, we're just going to make that macro equal to this function, and then just try to get that working, see what we got going here. And I have a comment within a comment, really. I did not take a quick enough look at that, did I? So over here, it doesn't look like, oh, because I don't know what I'm doing. So that is an aspect. So that was an aspect where that could actually really help me with like syntax highlighting. Is that stupid mistake that I just made? I try to write it off as I like to encourage myself to write correct code by not having the editor tell me what I did wrong. Okay, so 401, we got a mistake. Not in here, though. This is in the function file. So let's look at the function file and Control G, and let's just go 401, see where that is. That's not what I would have... Oh, holy crap, how the heck did that happen? And, oh well. Okay. So I am paranoid that I might accidentally delete things, and sometimes I do that. Okay, so this is compiling. Now let's just go over here for a second and see if one of our stubbed-in methods works. So PNG to naked, whatever. And okay, so the stubbed-in functions are there. We still need to kind of save a file. So we need to figure that out. I kind of like threw in some FileAccess stuff, but we still need to figure out specifically saving a text file rather than a PNG file. So all the stuff that I kind of threw in here, we got save PNG file to disk, but we don't have anything for saving a text file to disk, right? So you have a touch file command, and then we have recursive make directory for our, like for the touch command, but we don't have anything for saving just a normal file. So I think right here we're just going to make a section, and we're going to say save txt file to disk, right? So even if it's a C99 file, right, it's still a text file. So that's what we'll name the section. And if we wanted to, I'm not against, I do like lack of abstraction. So txt file is more abstract than saying C99 file, right? So C99 file is the use case for what we want to do. So we might want to say this as well. So kind of like double label this section, just so that we have the abstract case and then the specific case, if that makes sense. And let's look at how this works, and kind of like, we want a consistent interface, right? So let's look at this and see if this makes sense or if it needs to be changed a little bit. Okay, so we got the name of file with extension, so I think we should keep this variable name. We should keep this parameter, absolutely. Then we have like a pixel array and the width and the height. So this basically is a length, right? It's just the length, but it's encoded as a width and a height. And this is used to derive the length of this pixel array. So you take the width and height, and oh, it's a unit 32. Okay, so yeah, just take the width and height, and then you get the length of. No, hold on. Sorry. I was looking. You take the width and height, multiply them together, and then multiply them by 4, because I can see that this is a byte array. So number of pixels times 4, right? Because R, G, B, and A. And then you get the length of this. So if we want a signature that is consistent with this pattern here, then, well, first of all, we can just do this, first of all, right? And also, we didn't do it over here, but let's try not to do this and actually use our type defs. And this pattern, this thing here, instead of calling this pixel width, this one is going to be the array length, or the string length, so like strlen, like that. And I guess I don't have a shortcut for that, which makes me scared. And this one is just going to be the string. Technically, it's a character array, so I don't know if we want to call it, you know, well, it wouldn't, str array would not actually be correct. It's actually a character array. And so character pointer and name of file with extension. So we're going to assume this is null terminated because we don't have a length. I mean, a lot of stuff might be, this might also be null terminated, but just for safety, we're going to include a length variable as well. And then we need to shorten up this. This is obviously not a pixel array, right? So this is the string to save to disk, right? And this is num chars. Now, do we want to include the null terminator in here, or do we not want to not include the null terminator? I think we do not want to include the null terminator because maybe this is null terminated, maybe it's not. So I think strlen should just be the length minus the null terminator, just in case this may or may not have a null terminator. Also, it seems that the convention for string length is to not have a null terminator encoded in here, right? And so strlen is very much named after the command strlen, right? So we should probably, if it's named after that command, we should probably conform to the conventions of the command. So num chars in char array, right? So the number of chars in char array, and then we're just gonna kind of enforce the bounds. So the only reason I pad it like this is just to, if somebody's not using a 64 column limit, which would be what, 99% of people probably don't use a 64 column limit, I still want it to be very obvious when somebody opens up this file that they probably have a very specific column limit. So I'm going to do a lot of this kind of nonsense just so that when anyone opens up my source code, they can see right away that there is a very obvious column limit, right? Okay. So we want to define all these things. So we want to define int32, we want to define a character, and we want to define u32. And u32 should probably be over here. Then we want to just align things a bit, create a little checksum, right? Create a checksum of all of the local defines because we're going to undefine them after we're done with them. And the reason why we make all of our defines local to sections is because it gets out of hand really quick. And I could demonstrate that, but unless somebody requests to demonstrate how that can get out of hand, I will not pull up the examples of some old code I wrote where it spirals out of control, right? So like, if you try to do like project-wide defines, like you can get lists that are like hundreds of defines long. So that's too much to remember. And so we just want to think about the defines for specific sections of code and nothing more. Okay, so we know. Also, this is going to be save file. Now, do you want to call it save file text, or do you want to call it txt? And a lot of the code I've been calling things text for text, even though that could mean texture, and txt is probably more commonly known. Though some of my variables for text strings are actually tex, so we got to think about this, about how we should do that. Let me think for a second. I'm going to stick to txt, just because I think this is less ambiguous. And maybe I will regret myself later for that choice, but I think that's a good choice here. And Also, the thing I can do is I can make a little note here. I haven't done this very often, but we can do something where we make a note, and I'll put the summaries of what a function does inside the function rather than on the outside. I'm not using any IntelliSense, so I can actually get away with this. But we can take the video ID, right? We're at video 120, and the time is 7 hours, 44 minutes, and, I don't know, 5 seconds. And decided on, instead of text, because text can mean texture in some contexts. Right, so now we have a video and we have a timestamp, so if we're ever like, what the heck were we thinking, we can actually see the video. Now, obviously this is very bulky, but the thing is, we can always go into the code later and strip stuff down and make it cleaner. But we can never do the reverse. We can't add these comments a day later, right? Or say a month later. We can't go back. We can't revisit old code and add commentary of what we were thinking back then. But we can subtract. So I'm going to err on being more verbose rather than less, just because we can always subtract stuff later, but we cannot add to it later when it comes to like commentary. I guess you could like reanalyze the code to figure out what you're thinking and add the commentary later, but it's not as good as far as I'm concerned. Okay, so we got this save file txt, and the first thing we want to do is we want to invoke the touch file command. So this touch file section up here, we just want to eliminate some of the complexity of we want to eliminate some of the complexity of what we're doing by running touch file, right? So sometimes some file access methods won't work how you want them to work if the file doesn't already exist. We want to eliminate that part of the equation to simplify the problem, right? So we're going to take this touch file command, and we're going to take the name of file with extension, right? So example could be touch file and my text file.txt, and I can't remember if the name of the file needs to have a // or not. I honestly don't remember, and we'll find out. We'll find out, I guess. So even before we add any other code, we're just gonna stick with this and make sure that this touch file works correctly, right? So because I have very strict compiling settings, we're gonna do a if character array. We're just gonna do some no ops for this to get it compiling. And then for the string length, same deal. We're just gonna do 2 no ops to just get this compiling, right? Because we got to use all the variables, otherwise my compiler is going to be like, hey, you don't know what you're doing. Which is usually helpful, but sometimes when things are under construction like this, it just creates problems. Okay, so we have the save file text command, and we want to use this in the main utility. So let's just take this, and not in the data file, but in the main file, right? So save text output to file, right? So this is where we want to do this. And we don't know all the implementation details, but we know once we have them, it's going to be this. And the name of the file, let's call it, we actually should have a name of file kind of like provided, right? So the name of the file is something, I forgot what it is. And so this should be the text output, and then we can just do like this. We can do strlen text output, right? And let's look at the parameter. So the the file path in and the file path out. So now it looks like we don't always provide that. So file path out could be this null pointer. We probably shouldn't use. We probably should say like default something or other rather than this null pointer. That's going to just make things harder on us. So if it's not if we don't actually supply a third parameter, we should just hardcode something like default output file name dot we're gonna call it PNG or TXT, and dot underscore. Okay, so the reason why we're gonna call it that is because this output file, depending on what command we're running, this will either be a PNG file or a text file, so we don't want to give it any extension. We're just going to go dot underscore for, right, because that's going to be our extension, is just going to be dot underscore. Now, dot underscore is what I usually use, so I'm going to triple underscore it so it gets my attention, so that it's not the convention I usually use. And this is just going to be my convention for saying, I don't know what the heck this is. You should probably fix this and be more specific, right? So if we can change this somewhere else later, but right now we'll just keep it like that. And so we know this is the file path output, right? So so then down here we're just gonna say this is so file path output. Right, or slash file name. I don't know how we want to give a little tip on what that is. Right, and so text to save to file. Right, and then this is kind of self-explanatory. I don't think we need to get into that. Though you never know. Length of text. I'm running out of room here. Length of text, sure, why not? Just be descriptive. And let's just give that a run and see if we can get the file, just a touch of file, right? The whole thing isn't going to work yet, but let's just make sure that it compiles and we can, right, like I said, comment within comment. So I'm going to guess I did something stupid with the formatting again. So right here, I don't see it. It's in my no ops. Oh, right here. My example. So sometimes because I don't use syntax highlighting in a traditional way, I make really stupid mistakes. So maybe I should rethink some of the ways I do things, but that's the way I do them for now. Okay, so let's try this and see what we got. Blah, 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 something, something, bracket matching. Okay, so let's go look over here. It's in the function file, and it's on line 277. So we didn't do something correct here. What the heck did I not do correctly here? Touch file, that actually looks... That doesn't look like I did anything... So it says control reaches... Oh, yeah. Now, why is my save file... Why do I have int 32 here? I think it's because I did it... I kind of did this, right? And this has an int for a status code, so I kind of like wanted to mimic this. But I don't think I'm actually going to use that for anything. But if we have to mimic that interface, right? It's just I want the two functions. If I have save file txt and save file png, I just want the function signatures to be the same. And I guess technically it's not a function signature, it's a function prototype, but yeah, I just want consistency. So sometimes code will get a little bit weird because of the level of consistency that I desire. So it says enter to exit, but that looks a little bit strange. That should actually... We're going to have to run this on the command line. I think I'm segfaulting somewhere. So /PHEXDUM.sh. That looked like a... Yeah, segmentation fault. Oh, God. You know, you think I would know what I'm doing, but... Apparently I don't know what I'm doing today, because I've made a lot of segmentation faults today. Line 23, okay, well, let's look at the code we added. There's the possibility that this output, yeah, the output here doesn't have a... This output... So this was kind of hackish, the way we did this, right? Because this string here, this text output, does not necessarily have a null terminator on it, does it? Well, most of this text does not have a null terminator. So the question is, how are we going to save the text file if, like, all of this default text that we use is, like, not null terminated? Well, how about we null terminate it, I guess? That would be the easiest solution. What's another solution? We could... Now, I think the best way to do that is to null terminate it, right? Because right now, strlen, we're not... Yeah, we gotta null terminate this text. Otherwise, this is just not going to work. So, we got this error output message. Yeah, any of these output messages need a null terminator on them. So, like a \0. All right, so, yeah, we need a null terminator on everything. That could get kind of weird, because now we have to check. This seems kind of hackish, where that means I have to individually check any one of these assignments and just make sure that it is correct. So if this is null, this should never happen. Yeah, so we're just going to have to look at every one of these places where we make an assignment and just make sure that the assignment... So we have this thing here, and this output could come from any one of those functions. So the stubbed in text also is going to need a null terminator on it as well. So this is just a lot of... that's fine. So all these functions that we stubbed in here, and yeah, so the main functions that we stubbed in, we're going to have to just put null terminators on the function stubs. So where are you? So these function stubs that we're returning, right? So they need to be null terminated. So we need to do a \0 and why not \n and \0, just so that we know. Usually we do like a new line at the end of things, and so I just want to make it known to myself that I didn't accidentally do \0 when I meant \n. So I'm going to do both of them just to be kind of like safe, if that makes sense. And here, like any of these strings we're returning, we need to make sure that they're null terminated. Otherwise, like, I think that's probably the source of the segmentation fault. I could be wrong. And let's just clear and try to do it again. Right? Like, I could be wrong about where we're segmentation faulting, but yeah, okay, great. So I don't know what I'm doing. Okay, so we're gonna first thing we're gonna do is we're gonna go into the logging that we wrote earlier, And we kind of hackishly turned off the logging functions, I believe, didn't we? Yeah, if 0 is greater than 1. So we're going to change that to if 1 equals 1. And then we have more logging functions. We have one in here as well. We're going to turn that back on as well. And kind of see, like, how far does it get before it kind of fails on us. So if 1 equals 1 over here. Okay. And we'll kind of recompile that and see kind of like how far. Not far at all. Okay. Alright. What the heck? I did not expect that to happen. I expected to see something. I did not expect the main file to just kind of like on me like that. Okay, so we know we added that file access code, and that was what was... Okay, well, you know what? So let's just kind of like log and, you know, here's main. So here's the beginning of main. Right, so here's the beginning of main. We're just gonna... How the heck... So let's see if we can at least get to... into main. Right? Can we at least get into main, or is there something... Okay, so we get in there, and... Okay, so our logging function is working. It's just, like, something about what we changed. It seems to me like it's not even... Something we changed... It's not even... It's not getting to... I don't even think it's getting to here. So we could... Yeah, because we have this printf... let's just do log, and let's say, let's take this section here and just say save text to output file begin. And then at the end of this section, we're going to do the same log, right? But this is going to be end. This is the suspect code that we were just working on. Did we forget something we were working on? Did we add some offending code somewhere else that we're just not thinking of? Well, that's a little bit better. Let's clear this for a second. So, it compiles it and it runs it without any arguments. Use exactly 2 user args. Okay, so it's expecting some arguments, and if we don't give it arguments that it requires, well, we shouldn't just segmentation fault, right? Like, we should handle this gracefully. And it is getting to save text to output file. So it's just that it gets here and things aren't what they should be, and that seems to be because we're in a path of execution. The execution path should kind of be fault tolerant against, you know, not having any inputs, and so one of these things is just not looking good for us. So I thought we kind of did this. We'll just assert some things, right? So all these things, we're just going to write some asserts, and we're just going to write them kind of verbosely. So we're not going to use the assert.h blah 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 stuff. We're going to use we're just going to say that, you know, if so the file path is a character pointer, right? So a null character pointer, and if that is equal to the output, then we're going to say error and say nil. Can we get this on one line, or are we not going to get this on one line? It looks like we're not going to get this on one line. We're like almost. I'm going to just say that, you know, right here, I'm going to say, actually, let's make the defines local to the section that we're in. So let's go over here and define a null string, null string is just going to be character pointer 0. And then down here, we'll undef that. 2 spaces between to keep this properly aligned right here. Right? And if we shorten that a bit, can we get this on one line? Yeah, so now we can get that on one line decently. And we need to look at the file path. We need to look at text out as well. And strlen, that could be a problem for us. So, let's say, you know, if 0, or I guess strlen less than or equal to 0. I know you could never get a negative, but I do this. I really get paranoid when we do chucks exactly equal to things. So that's just me being weird. Len strlen. And now I'm going to take this out of here, right? I'm going to take the inline calculation out of here. And I'm going to put it, like, above, like, over here, right? So, well, actually, we can't put it there. We got to put it here. Now, text out is right there. So we got to take strlen. If we want to do that, then we got to put it in here. And say strlen equals strlen text out. That's kind of ugly. Oh well. So int32 strlen. And we'll set it equal to 0 or negative 777, right? Just some type of trap value, invalid value. This is kind of weird to read because we got all these asserts, and then we have this kind of like tucked in here like that. That's kind of a but oh well. And then we'll run this command here, and we'll printf this, and we'll flush the console. So now we can kind of see if we can at least get to here. Okay, so let's give that a run. And save text to file. So hold up here. So why is this showing up twice? Let's not do that. Let's not make something confusing where we have a message that kind of shows up twice, and I think I know why. So this is the output message. That's fine. And then we're printing. Why are we printing the output message here? Where are we? Got it. Yeah, so that's great. That's great and all. I see why I'm doing that, but it's just confusing to see it in two places like that. So yeah, I'm not. Yeah, I don't know what I think about this. I guess it's nice to know that we're using it in two places like that. I don't know. Okay, well let's. Yeah, let's just comment this one out for now, I think. Yeah, because if we're looking for this, we can find this assignment easy. It's actually the other site where it's getting printed out that's actually harder to find. So let's remove that from there. And we're still gonna segfault, But I just want to see one message, right? Like when I don't want to be confused by seeing the same message twice, right? So, right, this is the output of the function, and then this is the text output, right? So this text output is being printed, right? So right here is we're printing it, and then we're actually segmentation faulting in here. So the save file function is what is screwing us up. So let's put this over here and look at the save file functionality and figure out what we're doing wrong here. And we want to be able to catch ourselves, like if we're about to seg fault somewhere, we ideally want to catch ourselves before. Oh, you know what it is? Is this supposed to be null terminated, right? So I'm going to guess. So first of all, let's go into the old code base and see how I actually use touch file, because I'm going to guess that I have a very specific format. Like the file name might actually need to be like // or whatever the heck, or something like that. And this is why I kind of cut and pasted, because I have a very specific way that I am writing this code. So let's go into the file system code here. And let's see how we use touch file. Oh, wait, no. We have to find in files for this. Find all. So I just want to see where I'm using this. We don't have a touch folder, only a touch file. So here's a place where we're using touch file. It has a file PNG, and it looks like it has a null terminator at the end, right? So this has a null terminator, right? We're making absolutely sure it's null terminated. That's probably important. So name of file. Oh, so we're doing a lot of stuff that... Is this relative... Oh, this relative file path is... I got it. So, okay, I see. So we're not actually using touch file like I thought, right? So we're taking the... We are taking... Oh, so we're adding a mod folder onto this, right? The base name. File PNG, allocating some stuff, blah, blah, blah. But the important thing about this code is, or at least to me, is that we have a null terminator on the end of it. And that makes sense. Like, how are we gonna touch the file and not have any problems if our string isn't null terminated? So this is just very basic kind of like screw ups here. So that's fine. But this name of file, it needs to be null terminated. So let's look at where kind of save file txt is being used. Wait, no, where are we? Oh, it's being used over here. So this name of file without extension, or sorry, with extension. File name. File name. Name of file. So it's the name of file type. Yeah. I don't know what I'm doing here. Yeah, but this needs to be null terminated. Absolutely needs to be null terminated.
So let's kind of look at where we are kind of using this and see where that mistake could be coming from. Is it not null? It should be null. Isn't it null terminated when it comes through the console? I've never had any problem with that before, though. Well, let's... So it's not a null string, right? Because then this error would happen. Oh, you know what? But we probably have some type of default output name, don't we? This is the output, right? The output file. Yeah, this is the output file, and we don't always provide it, and we did this nonsense. Yeah. So this needs a null terminator. Oh boy. So actually, let's create a name for this. So like AAC 2020 PNG hex dump default output file name. Default file name, sure, something like that. Or how about default, right? So name it after the actual variable. That would make sense. And then in our data file, I don't know where to put this. So I'm just going to say, I'm just going to make a misc section so I don't make things too granular, and just say misc whatever. So anything I want, I'm going to put in this section. And then if we see any patterns that arise where it's like there's an obvious new section that kind of needs to be defined, then we can extract from this later. But let's not get overly granular. So let's kind of just say we got this misc whatever function, and we have this default file, this default file path output, or yeah, file path output, yeah. So we'll just take this, and you know, it equals this, and it has a null terminator on it, right? The null terminator is the thing that is kind of screwing us up, I'm pretty sure. Because how can we touch a file and use the touch file command on something if it has no null terminator, right? So we'll just say that define CHR, and then we'll undef CHR over here, and then we'll just say character pointer. This is our default output file name, and let's just kind of do something like that. Let's kind of hard wrap it like that. PNG or TXT dot three underscores, right? So we really don't want to use this, but if we have to, then here it is, right? Now we could make a default PNG file as well as a default TXT file, but let's just get this working first. So now that we have that, over here, or actually not over here, over here, okay, that's assigned. So now I think that will fix that segmentation fault. I could be wrong, but I think that's the big mistake I made. Oh yeah, so I am using pedantic, so I can't use two parentheses like that. I like to use two parentheses whenever my statement takes up more than one line. It's just a weird thing I do. But because I'm pedantically compiling, I have to be careful of, oh no, come on. Okay, I don't know. I guess I'm gonna have to look a little bit deeper than I've been looking. So let's go into the function file. And we know that it's happening in, we don't have a guarantee that it's, well, maybe we're getting here, maybe we're not, right? So let's log here. Let's do a log and say, I don't know where we want to put the log. Actually, let's put the log here. I don't know. And this is the function we've entered. And we're thinking that maybe we don't know if we're here or not. Like, we could be here, maybe we're not. I don't know how far we're getting. So let's just do our poor man's debugging. And no, actually, if we're gonna
want to, since we have a return here, I don't want to wreck that. So let's indent that. Okay. Let's just kind of see kind of like where we are here. So we got no log function, so we got to make a macro for that. So let's do define log, and that's going to be AAC 2020 PHEXDUM, and it's going to be info any. Right, so it's our info any function, because we are in one of the files that will be kind of pasted into the main library once we get this working. So we are going to use the naming convention for that. Now, actually, I kind of like, lately I've kind of liked doing this. I think that, I don't know, maybe it's a bad idea, maybe it's not, I don't know, but I feel like it makes the division between the different sections a little bit bolder by, I don't know, whatever. Okay, log function. Do we know what we're talking about? Are we correct with that? I'm pretty sure if I'm consistent enough, then yeah, then we're correct. Cool. Okay, so now that we have that log function, let's give that another shot and see. Oh, and by the way, if anyone wants like a little technical demos to look at, like if you're new to the stream, just ask and I will give you a link to the technical demos. Oh yeah, and then also, I don't remember how to use my log function. Well, I do, but I just keep on forgetting that I need a null pointer at the end of my log functions, because it's a log function that logs any kind of data. Okay. So we do get into save file txt, that's fine. And I'm thinking that it's something about touch file, because the way we're using touch file in the other code is we were kind of like pre-processing what we were doing, and now we're not. So I think that touch file, I think it might need a dot / in front of it, maybe. Like it might need to be like the string for the file might need like to be like dot / whatever or something, or possibly it needs to be in a folder. There could be a lot of like constraints that I didn't realize I had imposed, and then I didn't make a note of them. And this is kind of why I cut and pasted, because now it gives me the freedom to change how this function works. If I think this touch file function sucks or it needs to be changed a little bit, I can do that. So this info string, are you not even getting into here, or let's not worry about that. Let's just kind of put some more logging in here. Right, so we're at the beginning of the function here. And we also need a log macro if we're going to do this. So define log, AAC 2020, PHEXDUM, and info any. And we want to take this log function and we want to go all the way down to, oh, is this all the, yeah, it is. Okay. So there's a lot of code in here, so it's not like surprising that something went wrong by cutting and pasting it. And then down here we'll just undef the log function. And then we will give it another shot and see kind of like what we see in terms of where we are. Okay, so touch file. We're getting into touch file, and then something is happening. And we don't know what it is, but something within this code is segfaulting on us, which I don't think we want any segmentation faults, do we? So is this? I doubt that's. Let's look at this for a second. So touch file right here. And then this thing isn't doing anything? Why is this not doing anything? Let's look at this. It could be that the logging is turned off, or is the actual log message that is doing it to us. This info string, is this, because I don't see anything from this info string. Is it screwing with us? Well, first of all, where are you? Because, oh, this is not that anymore, right? We changed the namespace, PHEXDUM. Okay, so let's look at that and see if there, oh, hold on. So if 0 is greater than 1, which is never, or, oh, hold on. Okay, well, let's just remove some of the let's just simplify this. Printf, whatever, then we got this printf. Let's also do a flush right here. So we want to see this message before we try to printf this. In case this causes a segmentation fault, I just want to be able to see this message here. And so I want to flush the buffer. I can't type. Up. Not enough ups. Okay. Okay, so yeah, our info string is the thing causing the segmentation fault, so that's great. That's sarcasm, by the way. So we have, oh, sorry, our format string, or something is wrong here. So a format string, and we have this string, right? So the first thing we might want to do is just make this a little bit more robust. So if, and also let's change this up a little bit. So define character right here, and then down here we're gonna define undef character. So undef chr right here, and then instead of saying const char like that, I'd rather just use this. And then right here, let's just say that if msgf, or actually no, character pointer 0, right? So a null character pointer. If that equals msgfmt, right? So Yoda expression to make sure that if we accidentally do a 1 equal, we don't shoot ourselves in the foot. And, you know, nil msgfmt. Duplicate this line. And now it might not be this, right? So if we see this but we don't see this, it means that our format string is probably missing like a %s in it, which is likely. And we could say that, you know, if you see this message, but not the next message, it probably means your msgfmt string does not have the proper number of format specifiers. %s, %d, etc. Okay, so what we can do here is we can actually make a note of the timestamp in this video. So if we want more information about what the heck we were thinking when we wrote this, we can just say, hey, you know what? We're at 8 hours, 27 minutes, and 20 seconds, and at that time, this is exactly what we're thinking at this time. There you go. And we could also kind of like indent this so that we know that this commentary is for specifically this one line, right? So kind of bulky, right? Where it's like, we just wrote one line of code and we have a big paragraph. But like I said, we can always subtract things. We can't add them later. So let's just give that a shot. It'd be nice if the mistake is something very trivial. Error macro. So define, well, the error really differs depending on where we are. So it is going to be AAC 2020 PHEXDUM for PNG hex dump, and it's going to be halt. And then down here, undef error. Okay, so let's give that another shot. Oop. Okay, so it says info string below, the strings weren't null, it still failed, right? And we got this big message. So basically, if we see this, which we did, but we did not see this, and these null checks they pass, then it means that our format specifier is somehow screwed up. So let's go see how we're using this function. And we have this info string here. So everywhere we use it as is for info string, I believe. Let's make sure of that. So let's see where it's referenced. Yeah, so anywhere we're referencing it, it's just called is for info string. And %s in the path. Well, what if the path was null? How about this thing? Touch file, file name. Well, what if the file name is somehow null for some reason? Do we not have proper sanitization here? I'm going to say that is, that's a potential, I think. So let's, and also what kind of file name is this? Is this a file name with an extension, a file name without extension? It seems like we have some requirements here that number of dots and number of backslashes. So if number of dots is greater than 1, too many dots, so we expect exactly 1 dot in the file path. So it's like a dot slash whatever, or is this like a... No, if there's only 1 dot and we expect an extension, then it's a file name without an extension. So we should probably make the file name variable kind of reflect the form, like have a naming convention for this that reflects the, this is a bad variable name. Like I know this variable name is sloppy, and that I haven't thought it through because it does not adhere to my convention of exactly 7 letters or 3 letters for a variable name. So 1, 3, or 7 is the length of most of my terse variables. And so I know that this is a bad variable name. I know this hasn't been thought through. But yeah, there's no null checking here, right? So if we did a strlen on something that was null, that could be bad. The file could not be null terminated. That could be a mistake. So yeah, let's so I don't know how that would. Well, actually, no. It's when we use this, it doesn't crash on us, right? It doesn't say, hey, this is null. So that's not a mistake. Now, what if there's no null terminator though? Like we're trying to send this off to like a printf function basically, and if there's no null terminator on it, maybe that is the thing that's messing us up. Now this touch file macro call, that already existed in the code before, so it's not, I don't know what we're gonna do. We're just gonna say we're gonna add another null check just in case. So we're gonna say if character pointer cast 0 equals file name, and we're just gonna err and null file name, or nil file, something like that. That's not actually going to catch anything, I don't think. I'd be surprised if it catches anything, but I want a little bit more robustness, so. Now, touch file, okay, it's only, I would have thought that would only, whatever, okay, so undef undef and then the error function. And I don't think that's going to catch whatever stupid mistake I'm doing. I'm going to guess that, see, I do not do much file system access stuff, so I'm just making a whole bunch of stupid mistakes that somebody who is more used to doing things the correct way would not be making these mistakes. So I'm going, my guess is that this file name probably also needs a null terminator, and for whatever reason it doesn't. That is going to be my guess, because it's failing in the print function. And I'm pretty sure this is just a refactor of the other touch file command. So if we actually look at this, and we can confirm that, right? So we can go open up this thing here, right? And we can go look in there for a second and say, hey, where we're calling you from. Yeah, so we have this already. So we already cut, right? That's what we cut and pasted from, right? And that works. It doesn't segfault, and it saves a file to disk. So I would say this doesn't have a null terminator on it. That's my guess. So I just want to make sure that, oh yeah, and also if we're going to do that, we also need to define a character. And then down here, we're going to undef that. So right here, we're going to undef that. And okay, yeah, so now let's give that a shot. Yeah, so I'm gonna guess that it's not, and we could actually, yeah, oh, cancel, yeah, so my guess is it's not null terminated. Let's, what do we want to do here? Well, first of all, let's look at where we're touching this file, right? So, in the main function here, well, actually, we don't do it there, right? We do it in the save file functionality, right? So right here is our text save file thing. This name of the file with extension, and then from over here in our C11 file, here's the file, and this is null terminated, though. It's in the data as null. Do we not know how to write a null terminator? Are we just being stupid? Let's not overlook that. So null terminator, C code, literal, something or other, right? So, let's not. So, I'm not going to rule out my ability to do something stupid, because I seem to be doing that a lot. So, let's see what we got here. Null terminated, whatever. Yeah, \0, right? Right? Yeah, or like this, right? Well, yeah, that's what I expected. Okay, yeah. Then what the heck am I doing wrong here? Okay. I don't know what I'm doing. Is there some... What could I be doing that is making this... Huh. Not... I mean, it's right here. And... Okay, well, that's that, but, what have we been doing in the console, though? The console shouldn't be getting any extra arguments. Actually, it's not getting any arguments. And does that change? Okay, so we're either here or we're... No, I mean no, because it's not the... Hold on for a second, am I not... Okay, there's no arguments there, and then all of a sudden we're over here. Okay, I see. I'm just not looking at the correct execution path. Yeah. Okay, so if we're going to set default values for things, this is not the place to set a default value for this at all. Because here's where we're saving the file, and this section here is where we do the work, right? So so first of all, let's fix the problem first. So let's fix the problem and then organize the code a little bit better first. So the thing that worries me, first of all, is that, well... Oh, yeah, I see. I'm burning myself because I'm not... Like, this would have been caught if I hadn't done this, but I'm like, I'm going to be careful, I can do this because I'm smart, and no. So we really should probably... I like it like this here, it's easy to read. Because, right, we can have the definitions of each one of these before we assign them to things later. But, if we want to do that, I think we're fine. If we really want to do that. Default values. So, if we still want to do this kind of C89 style of, like, declaring everything before we assign it, then sure, we can do that. If that's how we want to roll with this function. But we gotta move this into like a default values section, right? So this code execution path wasn't being called and it was segfaulting. The other thing that worries me though is that, yeah, okay, it's segfaulting because it has a random memory address, and is there any way to, well, it's random, yeah, it's I don't know if it's technically undefined behavior or not, but trying to print a print using a random memory address would not be the safest thing to do. And I don't really see a way I could accurately check for that, so... Yeah, because I would like some more robustness here. Like, I'd like robustness for, like, oh, if this is a random memory address, you know, notify me, right? But I don't think I have a good mechanism for that. I think I just have to fix it and let that be that. So the text output, is that already assigned some type of default? So this default is assigned here. So rather than assigning it in our branch, because this branch right here is going to be really easy to miss, right? Because we have this if here, a whole bunch of stuff, and then a little bit of stuff, right? So we might want to flip it around so that this branch is either at the top, and then the big branch comes next, so we don't miss this little piece of code. Or it might make more sense to put this in the default initialization section, or actually, okay, we're gonna come back to this. Let's highlight that so we know to come back to it. I like the idea of having just the default values section here. And AAC 2020, let's kind of continue this kind of pattern here, right? So default, and this is the text out, right? So let's just do that, right? And then over in the data file, where we have this thing here. Same deal, right? So we can go here. Oh, or hold on. And for this text output, how does the text output work though? Hold on. When we have the text output, do we just know the length of the string, or do we do str length on it? Like, how do we... Here's text out. Yeah, we use strlen on it right here. So the text that we're generating needs to somehow have a null terminator on it. So we can throw a... Okay, this is the output text, and we don't have to get fancy here. We could just do this. We could just go here, and we could just say, we could just put, this can be our default output text, right? Just like, you know? So we're going to make sure it has a null terminator on it. And a new line, sure, why not? And the null terminator, yeah, that's good. What else do we want to do? Do we want to keep it lined up like this, even though it's not consistent with this? Do we want to wrap our code like that instead? Like, I don't know. But let's... Yeah, so that probably will fix the problem. And then we need to address this nonsense over here. Yeah, so this is... Okay, so here's what we're gonna do. Like, if that's really... I don't know if we really want to do that. I don't know if we really want to... We weren't printing anything out, were we? We commented that out, right? Error output message. Oh, okay. So hold up here. This is already... Oh, well, first of all, this is... That might create a problem. Okay, well, I see kind of a variety of problems that could be happening. Let's go up here and, if 0 equals the argument count minus 1, so, right, 0 user supplied arguments. If we have 0 user arguments, then... Hold on. Else. And we're gonna put the shorter case at the front, right? So that way, we can kind of see it easier. Now this, well, zero args wanted 2 or 3, right? So let's just make a more useful... Let's make a more useful error message and see what happens here. I'm still a little bit lost right now. I'm lost, but I didn't segfault. So that's good. Now, was it that default that we added, or... Yeah, it's the default, right? Because, well... Okay. Okay, let's not worry about it. Let's not worry about exactly why it works. Let's just say PNG to C99, and then whatever .txt, right? So let's run the command, and we got all this logging. It didn't crash on us, that's good. And then let's look at, oh hey, look, we have the, whatever, we got this PNG or TXT file, right? So it touched the file as we wanted it to, so that's good. And the next part is, well, instead of just touching it with that default thing, we supply this parameter, so what's up with that? So if 0 or 2 equals the arg count, so the output file, this text output file should be the, or not text output, but the, ooh, are we messing up? Are we mixing up the output? Hold on. Yeah, the file path output should equal this third argument. And it's not? So when we touch the file, what are we doing? We're using... So this is the file path output. And the file path output is not... This is not happening. So arg count -1. So we're expecting... Well, hold on. It's because we only have 2 arguments. So why... Oh, got ya. So I just don't know what I'm doing. This needs to be 2. This is the second argument is, yeah, they just can't, it seems I can't count past 1. Okay, so let's give that another run. And now if we look in here, do we have whatever oh, we have to actually recompile that though. So let's just change this to .sh really quick. And then if we do, so we have the default thing because it got executed without any commands, but any parameters. And if we do .exe and then PNG to TXT and then whatever whatever, weird. Okay, so expression command enum is... Oh yeah, because PNG to TXT is not valid. So if it's an invalid command, we don't want it to just segfault on us, right? If we use an invalid command, we want to say, hey, select a valid command or whatever. That's not what we're doing. So there's no such thing as PNG to TXT. What I basically meant was PNG to C99. So let's there's a few ways we could solve this. Well, let's first solve it for any type of gibberish, right? If we can type complete nonsense into here, we don't ever want an assert to fail, right? Because we don't control what the user is going to put in here, right? We should only fail if it's the programmer's fault, not if it's the end user's fault. This is an end user case scenario of it's the end user's fault, we should fix that. Okay. So on line 137 of the C11 file, right here, the command enumeration is ending up out of bounds, right? So it's probably ending up as 0. And we should have, in this jump table, there should be like a default function for this. Or we should be able to... So let's look at the functions here for a second. So I thought we made like a default function somewhere, or yeah, nothing found. Command not found, right? So let's take, hold on. Yeah, so rather than So rather than doing, between 1 and 4, let's just use this nothing found command in the jump table. I mean, there's many ways we could solve this, and maybe this isn't the way we should, but we already have this nothing found command. It's exactly what we want. So why not say that, let's just assert the command enumeration is between 0 and 4. And then for this slot here, right here, we're going to make this slot actually something. Right? It's the nothing found command. And then right here, we also check to make sure that we're between 1 and 4. We're going to change that to between 0 and 4. And we want to make sure that pointer is good. Look at the jump table, make sure that looks good. So we want to assert that this command function is equal to the function in the jump table. And this command function, we're actually getting it from here, not this jump table here. So this jump table needs to match the jump table that is inside this function here. So we need to make sure that we wrote that code exactly the same, right? It's like a little redundancy. So we're calling this helper function here, and we're assembling a jump table somewhere of the different commands. So we have the synonyms, so these are synonyms, these are enumerations, and these are commands. And we see that this jump table does not have the nothing found command in it. So let's take this table. Are we certain that's what we want? Yeah, it's the table of functions. JMP probably is for hold on a second. That macro is how the heck does this even run? Hold up here. Define jump as CMD jump. What the heck? Oh yeah, because CMD jump is a jump table. Okay, got ya. CMD jump is for a jump table. CMD func is the func from the jump table. Got it, okay. So, down here, we just want to make this table exactly the same as the other table. And it's named differently. We might want to make a note that tab function, this thing is the same exact thing as CMD jump, right? CMD jump. And this table of enumerations is the same thing as, so table of enumerations equals CMD enum, or is that not true? Let's look at is that not true? I'm not sure if that's true. Let's not worry about this one yet. Let's not worry about that. But we know that this is true, that this is this, right? And now when we're going through this table, this jump table of functions, are we skipping the 0th? And it doesn't look like it. So 4 to 0 going backwards. And do we want to set a default, or do we just always want to find it and just give it the default? I don't know. Let's just run this and see if that fixes things, or if we need to. I could see this not working. Well, let's just try it and see kind of like what happens, and then we'll kind of like edit it from there. So PNG to, well, actually blah 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 whatever .txt, right? Because the idea is the first parameter is complete gibberish and we don't understand it. So now okay, so right there, okay. So this is a lot of command not found. Fine. And the other question is it creating any files, right? So let's just look at this and say, okay, let's clear this. Let's give it another run. Does it create like a whatever.txt? It does create a whatever.txt, which is kind of weird because it's like if the command's not found, then why? Well, I guess if that's the way we're going to do it, we could just create a, I think what we want to do is just create this whatever.txt, and then inside the text file we'll say, like, command not found or something. I think that's fine. I think that could also help not break your, well, it could still break stuff, but it may or may not be useful. But we've got it working, but holy crap, this is a lot of logging that we just, well, let's not turn it off just yet, because we sure have been making a lot of mistakes. So, we're able to touch that file now. It still feels kind of shaky the way we're doing this. I feel like it's a little bit, not robust. Flimsy. Flimsy is the word I'm looking for. Let's close this. And let's look at the touch file command, or not the touch file. This should call the save file command somewhere. So save file txt, and then over here we want to look for that and say, okay, save file txt. What are we doing, right? So it touches the file. That works all right. And then once we touch the file, we want to actually write to that file, right? We want to open the file for read. So, you know, open text file for read, I have no clue. So I know that somewhere I'm actually doing this kind of stuff. So, open txt file for read. Actually, we need to, open it for write, right? We're going to overwrite it, right? So open text file for overwrite is what we really want to do. Okay. So let's go look on Stack Overflow or wherever we got to look and figure out where we got to do that. I know we're going to have to do like, use the read write flag or something like that. We're going to have to use like ftell to like seek the beginning something something something. Open C file for overwrite. Okay, so open a file which overwrite existing content. Somewhere I've been doing this before, I just don't know where. O trunk. Okay. O trunk flag. So I want to know what that actually means. When you use the O trunk flag to open, orient with the existing flags you have above. Okay. Okay, O trunk. We're going to look at the man file ourselves, but let's read this. O trunk. If the file already exists and is a regular file, and the open mode allows writing, i.e. is ORDWR, or O... I keep on reading this as wrongly. Read write only. O read write only. It will be truncated to length 0. If the file is a first in, first out, or terminal device file, the O trunk flag is ignored. Otherwise, the effect of O trunk is unspecified. Okay. Truncated length 0. Okay, so if it's a file where truncation makes sense, it does truncation. If it's a file where truncation does not make sense, it just gets ignored. That's what this says. And the other thing it says is that truncation just means, you know, make the file length 0. Okay, got it. So, instead of 644. So I don't know why. Now, when we're talking about permissions or whatever the heck this is, shouldn't this be like an octal number? Or it makes a little bit more sense than a decimal? I feel like I write a file somewhere. I just don't know where I do this. Okay, so I think the first thing to do is just get something working, and then after we get it working, we'll read about everything we're using, right? We want to know what our code actually does, so throw some stuff in there, duct tape, program it together, read about what things do, and make sure we understand the code before we're done with it. So just get something working first, then worry about the details later, I think. So output file name. So int fout, is this a really weird way to do a file pointer? Because I feel like, or are we supposed to use fopen, right? Let's look at that for a second. Open versus fopen. Uh-huh. Okay. So this has like a mode. Well, I'm not using Linux, but I know I'm using ftel in other places, so I might want to use fopen. Fopen is part of the C standard library. Open is not. Use fopen when writing portable code. And I know I'm already using ftel in some places, so I think fopen is what I want to use. First, there is no particularly good reason to use fopen if fopen is an option and open is the other possible choice. You shouldn't have used open to open the file in the first place if you want a file pointer, so including fopen in that list is incorrect and confusing because it isn't very much like the others. I will now proceed to ignore it because the important distinction here is between a C standard file pointer and an OS specific file descriptor. So let me read that again. So it's saying ignore fopen if open is a choice. And it's saying not to use open if we want a file pointer. Oh, hold on. So I didn't read that right. This is FD open, not fopen. My bad. C standard file pointer and OS specific file descriptor. There are 4 main reasons to use fopen instead of, okay, so not fopen, so this is FD open, this is fopen. I just did not read the D there. Okay, so fopen provides you with buffering I/O that may turn out to be a lot faster than what you're doing with open. Fopen does line ending translation if the file is not opened in binary mode, which can be very helpful if your program is ever ported to a non-Unix environment. Though the world appears to be converging on LF only, except IETF text-based networking protocols like SMTP and HTTP and such, A file pointer gives you the ability to use fscanf and other std IO functions. Your code may someday need to be ported to some other platform that only supports ANSI and does not support the open function. In my opinion, the line-ending translation more often gets in your way than helps you, and the parsing of fscanf is so weak that you inevitably end up tossing it out in favor of something more useful. And most platforms that support C have an open function. That leaves the buffering question. In places where you are mainly reading or writing a file sequentially, the buffering support is really helpful and a big speed improvement, but it can lead to some interesting problems in which data does not end up in the file when you expect it to be there. You have to remember to fclose or fflush at the appropriate times. If you're doing seeks, aka fsetpause or fseek, the second of which is slightly trickier to use in a standards-compliant way, the usefulness of buffering quickly goes down. Of course, my bias is that I tend to work with sockets a whole lot, and the fact that you really want to be doing non-blocking I/O, which file pointer totally fails to support in any reasonable way, with no buffering at all, and often having complex parsing requirements really color my perceptions. Okay, so we don't really care about all of the things about blocking I/O. We don't really care about portability. We just want to get something running. But yeah, so FD open is what I want to use. So let's go see if we can find like a FD open man page or something like that. And also, if you've never been here before, technical demos, I'll drop a link to those in the chat. Okay, FD open. Okay, so care pointer, path, and mode. You know what? One thing I'm going to do here, I'm going to look at my other code base. I don't want to say my old code base. It's actually the main code base I'm working on. Let's just like open this up really quick, and let's just do a search really quick for FD open. You know, because there's a chance that somewhere we're already doing this, so no, I guess not. Maybe I'm using fopen instead. Oh, that was not what I wanted to do, but so yeah, it looks like I'm using fopen, not FD open. So this is load PNG. What about my personal code? Fragbed. Yeah, because I save text files. I'm saving shader code to disk. Of course I have this. Now we're not writing binary, but same deal. And saving a binary file, write binary. Yeah, of course I'm already doing this. Let's just see how I do that. So fopen, read binary, file handle, fseek, ftell, etc., etc. I'm going to keep this on another monitor for reference, because yeah, this is something I want to reference that, and we can try with FD open instead of fopen, since it seems like the recommendation is to use FD open. And so let's just do, first of all, let me look for fopen again, fopen. And we may find out very quickly why we're using fopen rather than FD open. And if we find out there's a particular reason why we're doing that, then we'll kind of fix it up a bit. But yeah, so we need a file pointer, and we're gonna just call it let's see, file handle. So do we just want to call it I'm gonna call it file handle like that. I'm gonna call it file handle, and it's gonna equal fopen And then we need the actual file name. So the name of file with extension. Sure, that should be fine, I think. I hope. And then we want to open it up for write, and we don't want to do. I feel like it should be W plus, but I don't remember what the plus is for. So we want to open it up for write, and then binary is B, and then plus is. Let's go look at that for a second. W. Open for reading and writing. Oh, no, that's R plus. Reading and writing. W. Okay, hold on. Does this go to this, or does it go to this? A little bit of spacing would be helpful here. Okay, so yes, this is here, so it goes like this. Okay, got it. So reading and writing. So reading plus. So then, could you also do RW? Is this also reading and writing then? Write plus. Open for reading and writing. The file is creating if does not exist. Otherwise, it is truncated. Okay, got it. The stream is positioned at the beginning of the file. Okay, at the beginning of the file, and so what the heck is the difference here? Created if does not exist. Okay. Open for appending. So I don't know if this is automatic. I don't know if W plus is automatically going to give us truncation, or if we're just going to get like weird artifacts at the end of our file. But it looks like W plus is actually what we want. We could also steal that from the manual, right? So we can steal this W plus from the Linux manual and just put that in the commentary here. So I don't know what I'm doing. But yeah, we can just steal this commentary from the manual, right? RTFM. So I may be going painstakingly slow, and it may be like, man, I don't know what I'm doing, but at least I'm reading the manual. At least I'm trying to know, you know, what I'm doing, I guess. That makes sense, right? Like, yeah, I go painstakingly slow, but at least I'm trying to know what I'm doing. So at 9 hours, 16 minutes, and let's say 20 seconds. And this is from over here. So let's just put the, we don't need the HTTPS. We can just do this. And that's not actually what we want to do here. We want the video ID is, the video ID is 120. So 0, 120. And that's the time. Okay, cool. So W plus. I don't know if we want to just put that light right there, so I know that this comment here, this timestamp is for why we're using W plus. We think that W plus is going to truncate things out of the box. That's just a guess. I don't know if that's correct. So we have this file. We have a file handle, and now we need to like seek through the file, or we just need to write. So yeah, okay, yeah, so that makes sense. So I'm just gonna start stealing some code from other places that I've already written it, because this makes perfect sense to me. So right, seek to the end file, right, to get the number of bytes, and this is going to be a file handle, right? We're going to normalize these function names, so file handle and file number of bytes. So file number of bytes, Now, I don't know if I have a variable called file handle like that. How about file number of bytes? No, I don't. So I might as well make a note of these while we're here. So over here, let's go into our notes really quick. And oh boy, we have a lot of stuff in here. File handle, or not file handle, file handle. File handle, and file handle. If we type something like that, I just want, this variable like that. And if we do something like file number of bytes, or file, how about file size? Something like that, we want to see NOB, file number of bytes, right? And let's just kind of section this off for a second, because we're going to just write a whole bunch of stuff in here, so that as we write more kind of file access code, we have more consistent variable naming. So if we type file handle like such, then we just want to say that this is correct. And if we type file number of bytes like this, then we also want to know that this is correct. And if we type something similar, like let's put this one over here. File hand. If we do something that is very similar, like file hand or file hand, like that, then we're just going to correct it, right? We're just going to say, good enough for me. Just correct it. Okay, if we type something, so now for file number of bytes. So file number of bytes or file number of bytes. If we do that, we're just going to correct it. Now, if we do something backwards, then we want to not quite correct it, but tell us that, hey, you typed that backwards. So if we say, like, handle the file, right, which is potentially something we could do, we want to make sure that we don't type it that way, right? Because we want to say that if the variable stands for a certain piece of information, a certain type of information, one variable for one type of information. We don't want to do multiple searches to find all the points at which a certain type of data is used, if that makes sense. So we want to reduce the mental search space in the main code base by converging on very specific variable names. So if this is here, we're just going to say backwards, use, and then say file handle, right? And then if we do number of bytes in a file, or number of bytes in a file, or number of bytes in a file, same thing, it's backwards. So file number of bytes is what we want to use. Okay. The last thing we want to do is just make a definition so that, obviously it's a very terse thing. We want our shortcuts to tell us, what the heck did we mean about that? Like, so, or, right, so a few ways to put it in the shortcuts, and then it means file handle, right? So when I abbreviate things, I usually just take the first three letters, unless it's kind of like a common abbreviation, like str for string, or cmd for command, or maybe txt for text file, right? But otherwise, first three letters when I'm abbreviating. Okay, so now, same thing with the number of bytes. So for the number of bytes, we're going to say file number of bytes means file number of bytes means file number of bytes means, and file number of bytes means, right? So a few combinations. And then this is file number of bytes, right? Okay. So that's good. I just want to codify what the heck I'm doing. So now let's look at this. So we got this file handle, and we need to normalize this, so that's going to be that. We should also fix some other code, but let's just get this working. So I see I have this macro here, right? And you know how I know it's a macro? Because it says macro, right? So a lot of times in my macros, I will literally spell it out and say, hey, this is a macro, and ooh, this could be a bad idea. You know what, if I break something, I break something. Let's not, do I want to do this? I'm thinking about my life choices here. Well, we're already here. We're already here. So I guess, you know, if that's the way we're gonna roll, then I guess that's the way we're gonna roll. Undef, right? So undef macro seek set, and then undef macro seek end. So right, so there's obviously some reasons why you might not want to do this. But a lot of times I like code to be very explicit and not abstract. So we're getting rid of some abstraction by knowing exactly what numbers these are, rather than directly using the macro. Instead of using whatever is defined in these headers for these numbers, right? We're creating our own macro for them and directly using 0 and 2. That creates a lack of portability, a lack of flexibility, but it adds a lot of rigidity and simplicity to the code, I think, because we can just say, what are these actual third parameters, and we can know right from reading the code, right? We don't need any IntelliSense or anything. We can just tell that, oh yeah, 0 and 2, that's what these things are, right? So we're losing flexibility by doing it in this way. We're potentially adding places that are going to totally break our code in the future, but the code at this time, by using this kind of rigid method, is going to be more understandable, if that makes sense. So, so we just want to say get number of bytes. So this doesn't actually... Why do I want to do this? I don't really want to open this file and append to it. Yeah, I don't know why I would want to do this. Why would I do that? Yeah, I don't even want to do this, do I? Well, hold on. We kind of might want to, because we actually want to make sure it's truncated, don't we? We want to somehow make sure this file is truncated. So maybe we could say that, yeah, we actually do want to do this because we want to make sure that it's truncated. So make sure number of bytes is 0. I don't know. So maybe that is something we want to do, because we can say, hey, you know what? We might want to make sure that it's truncated. And we already have this code anyways. So just say that, you know, if file number of bytes, or if 0 is not equal to file number of bytes. Now I'm not sure if that's going to be quite correct, because, like, what about, like, a new line, right? Or, like, if it's truncated, does it still have a new line in it? So I'm not certain if this is correct or not, right? But let's just say error, expected truncated to 0 file. We'll just add, like, a little message here, and then we'll just print off the file number of bytes, because maybe the number of bytes is like 1 or 2, because it's just like a null terminator in a new line, and maybe everything is okay and we're just kind of like being too stringent. I don't know yet, so let's just put that there in case we actually get this, because I think there's a high likelihood of that. So we have this file number of bytes, we have this file handle. We should make a kind of section at the top for these variable declarations and kind of like consolidate all of the things we're working with. think it's going to be easier to keep track of the problem if we make a section for this. So let's just say declare variables, and just make a nice little variable section here for everywhere that we are declaring variables. Or sorry, not everywhere. All the variables that we want to work with, we want to just declare them up front. And I don't always do this, but sometimes when I don't know what the heck I'm doing and I want to collect myself, then I will kind of do this. So we're going to take this file pointer, file handle, and we're going to put it over here. And let's not give it junk data. Let's just give it like a, I don't even know what the type of a file pointer is, so I guess maybe we should do this, or we could do this, right? So we can make it like that, I guess. File number of bytes, that should be an int32, I believe. I know some people use like a size type, which the thing is I'm not creating giant gigabyte sized files, so int32 should be fine for my needs. Number of bytes, that should actually be some type of trap value. So like it's signed, so we can like use some type of negative and say, I don't know, 747 is a trap value. And when I say trap value, I mean it's an intentionally incorrect value that will cause noticeable problems if we use it before we assign it to something else. So number of bytes. Now, if 0 equals the number of bytes. Now, if the number of bytes is negative, we might as well make a note of that. So if 0 is greater than the file number of bytes, right? So if we have a negative number of bytes, then we're just going to say, let's just copy this. Negative number of bytes in file, right? So that's probably the trap coming from the trap value, but let's just make sure that we check that scenario. Okay, and what else do we got to do here? So I know we had like truncation here. So we have some flags. Now, is the second parameter of fopen flags, or is it not the same kind of deal? So fd open, so it doesn't take any flags, it just takes this mode string here. Let's look for truncation. Truncate. So we don't actually want W+. Are we just read that incorrectly? Truncate file to 0 length, or create text file for writing. The stream is positioned at the beginning of the file. That looks like what I want. So why did I initially think it was W+? Open file for reading and writing. The file is created if does not exist, otherwise it is truncated. File is created if it doesn't exist, otherwise it's truncated. The stream is positioned at the beginning of file. So once again, I am confused about these two things. Truncate file to 0 length, or create text file for writing. Oh, it's just the only difference here is open for reading and writing, right? Yeah, I think that's the only difference. Okay, so once again, it's not it is not a, it's just W. It's just W. So let's go back here. So let's just comment that out. Let's just make this shorter. Let's just say, you know, let's just keep this, let's just keep the full URL here in the commentary and be like, you know what? We changed our mind. Here's the point at which we changed our mind. we can keep that for reference and say, you know what, at 9 hours and 33 minutes to try to do a simple task, we decided, you know what, we decided on just W, right? So we changed our mind. At first we thought it was W, and now we're like, you know what, at first we thought it was W plus, now we think it's this. Fine. So here's our W here. We're expecting this to truncate the file. Create if not exist. Truncate to 0. Alright, so we can make a note of what we think we're doing. Right, so this is the purpose of... So sometimes people say if the comment doesn't match the code, then the comment is out of date. But sometimes it's I don't know what the heck I'm doing. So if this code doesn't match this comment, what's likely the problem is that the code is wrong and the comment is correct. Which is kind of inverted from what a lot of people sometimes say when they're talking about clean code. So I'm going to have to stop this stream and restart it really quick because if it hits 10 hours, and we're very close to hitting 10 hours, then I'm going to not be able to upload this to my archives on YouTube, but that's going to be a big problem for me. So we're going to stop the stream and restart it immediately. And when I stop the stream, I do have to change the number in the bottom right-hand corner. So it will take a little bit to change some of these identifying markers on the video, but no less than, say, 2 minutes to do that. So I'm going to stop streaming. If you come back, that's awesome. If you don't, that's cool. But yeah, I just need to stop and restart the stream really quick because we're at 9 hours and 35 minutes. If we get to 10, I cannot upload to YouTube. So I'll be right back. Let's stop on this screen here. Right, we're on PNG hex dumper. This is part 51, or we might actually have that number wrong. Yeah, this is actually not part 51. This right now is right now we're actually on part 52. I need to get these numbers straight. The most important thing is the number in the bottom right. Other identifying markers are sometimes incorrect, so I am sorry. Okay, I'll be right back.